dead. Wake up.
In this tutorial, we are going to create a Zelda Breath of the Wild inspired game in Godot. This video also serves as an introduction to 3D game development more generally, meaning I will start with the basics of 3D graphics and then cover how to manage them in Godot. After that, we cover animations and how to make things interactive. I will also talk about the different ways to create levels. There are quite a few, and a big chunk of this tutorial goes on lights and special effects like grass, fireballs, and water to make things extra pretty. By the end of this video, you should have a solid foundation to create basically any kind of 3D game. Now for this course, I expect that you already know the basics of Godot, meaning you should know about nodes, scenes, and at least some GD script. If you check out my ultimate introduction to Godot, you should get all of the basics, although I would recommend that you have a bit more practice. That would really help. For that, I can very much recommend the sponsor of this video, Zenva. If you're looking for a good source of tutorials on Godot, check out Zenva Academy. They have a ton of courses that cover both introductory and more advanced concepts. I even made 3 courses on shaders there myself, something that would help you a lot for this video and in general. Zenva offers videos, written lessons, and interactive quizzes, all of which are super high quality and which give you practical lessons across various genres, from RPGs to bullet hell shooters. These courses also aren't limited to Godot. They also offer courses on Python, Unity, Unreal, and other essential tools. For example, I have made 3 courses on image manipulation in Python. Zenva offers a lot of free courses, including a fantastic free introduction to Godot. And with a single subscription, you unlock over 300 courses. And with the coupon code below, you get an extra 20% off your first year. Although that only applies to the first 50 people subscribing. So make sure to use your coupon today and start your game dev adventure. Before we get started properly, I want to cover some foundations. Most importantly, 3D game development in Godot is not fundamentally different compared to 2D. You are still placing nodes in scenes and make everything interactive via GD script. In fact, there are loads of nodes that should be familiar. For example, instead of a static body 2D, you now get a static body 3D. Same with the character, rigid body, and area nodes. On top of that, general nodes like timers and animation players are still just as useful. However, there are a few major differences that you need to be aware of. Number 1, we now have 3 axes, X, Y, and Z. This makes the math a bit more complex and introduces some extra challenges. For example, because all user input is in 2D, be it mouse, keyboard, or gamepad, we have to translate all of that to 3D movement, which isn't a major challenge, but something you want to keep in mind. Number 2, a 2D image is effectively a bunch of pixels in a grid, and if you wanted animations, you would just play all of them in sequence. Super easy. This does not work in 3D anymore. Instead, you need a character model, a graphic for the colors, and then a skeleton for the animations. I will talk about that in a bit more detail in just a second. For now, just keep in mind that the objects we are working with will become much more complex. On top of that, number 3, you cannot just place objects in the scene anymore and expect them to look good right away. In 3D, lights, cameras, the environment, and special effects like shaders and particles are much more important to make things look good. I will talk about all of them in quite some detail for this tutorial. Now, I don't think any of these issues are a major obstacle. If you spend some time on it, you should be able to learn all of this quite easily. So don't worry too much about it. I will go through it step by step. And the first thing that we have to cover is how 3D models work in general. There are basically 3 main concepts that you have to understand. A 3D object is defined by a whole bunch of points. These are called vertices. For example, to define a cube, you would need 8 points. These 8 points are then connected via edges, and once you have at least 3 connected edges, you're getting a face. To that face, you can add a graphic, and that is what the player would actually see. We will talk about that more in a second. Via vertices, edges, and faces, you can define really complex shapes. The boss would look like this, for example. The model consists of hundreds of vertices that connect in different ways. All of this you could create or manipulate yourself. This software I'm using right now is called Blender, which allows you to create and change 3D models. It's completely free and incredibly good. I would recommend that you have at least a passing knowledge of it, but it won't be required to follow this tutorial. Just something you should do in general if you're interested in 3D game development. Anyway, number 2, on the faces, we are adding an image to get proper colors. For some reason, everyone is calling this graphic a texture, but well, all we are doing is drawing on a PNG file. For the boss, the texture looks like this. It's literally just an image. For that, however, we have a problem. PNG files are 2D only. So how do we know where to put the 2D graphic on the 3D model? For that, we have a UV texture. This effectively is a mask that picks bits of the texture and applies them to specific faces. That's literally all it is. Finally, number 3, we have animations. For that, in 3D, you basically want to have a skeleton with multiple bones, and each bone is going to get a couple of vertices attached to it. That way, once you're moving a bone, you are moving the vertices along with it, which can animate the model in basically any kind of way. Those are the basics of a 3D object. You have a whole bunch of points. To these points, you apply a texture, and you animate all of this via a skeleton. Nearly done. The last thing we have to cover is how to store all of this data. There are quite a few file formats for that. And the two that you want to use are called GLTF and GLB. Those are actually basically the same file format, with one being human readable, so the data is stored in a JSON file, while the other is machine readable, meaning you only get binary data. The major difference between these two is that a GLTF file is slightly larger but easier to modify, while a GLB file is smaller but is harder to modify. In practice, you can use either without worrying about it. They both store objects, textures, and animations and work really well with Godot. Because of that, they are the default option. There are other formats though that you see once in a while. A common one is .obj, which also works but is a really old standard that isn't developed anymore, and is also less powerful than GLTF or GLB files. So really no reason to use these anymore. Finally, there are FBX files, which are kind of similar to GLTF. Although the difference is that FBX is proprietary, meaning at some point someone has to pay for using it. Because of that, these FBX files are not supported in Godot by default. In fact, if you read the Godot documentation and try to import an FBX file, Godot is telling you to convert it to a GLTF file. Basically, all roads lead to GLTF in 3D land, and this is what I will also be using for this game. Speaking of, there's already a starting project with all of the data. Just check the video description, download that one, and then open it in Godot to get started. Alrighty, so here we are in Godot, and you can tell at the moment we do not have a single scene. On top of that, if you go to scripts, you can see that we don't have any. For all practical purposes at the moment, the project is entirely empty. However, if you look at the bottom in the file system, we have an audio folder and a graphics folder. The graphics folder is much more important. Audio is just a couple of audio files. Inside of graphics, we have all of the assets for the game. At the moment, they don't matter that much because I want to focus on the basics of 3D first of all. But I would still recommend you to have a quick look just to see what's available. For example, a really easy object would be one of the rupees. And in there, if I extend this, we have one texture and then 3 files with the ending GLTF. If you click on one of them, let's say Ruby Red, there you can see the ruby, a preview, and you can rotate around. On the left side, you can see the mesh that's imported and the actual 3D object that we are getting from Blender. On the right side, we have a couple of import options, but those aren't too important. This would be a very simple object. Besides that, if you are looking at the characters, and in there we have Nagonfort, the main boss, in which we have a 3D file and a texture. The texture is just a PNG file. And the nugget for animated, if you double click on it, is a 3D object that is a skeleton 3D with lots of individual parts, all of which were made in Blender. And on top of that, inside of Blender, lots of animations have been made, and those are imported inside of an animation player, which makes it very easy to just play them, and then you get one animation, and well, you can simply play whatever you like. There are quite a few animations that you could be working with. Managing all of this is going to be a major part of 3D game development. It's going to be a fairly large section of this tutorial. But once again, for now, this isn't too important. I do not want to import anything for now. Instead, I want to work with the really basic 3D system inside of Godot. And in there, you can already tell we have a 3D space in which we can move around. At the moment, I am holding the middle mouse button and then simply move the mouse to rotate. If you hold Control and the middle mouse button and move forward and backwards, you are zooming. This can also be done with simply using the mouse wheel. And if you hold Shift and the mouse wheel, you are panning around. That way, you are navigating in this space. However, very often, this 3D space makes it very difficult to figure out how far an object is. And to make that a bit easier, you can look at perspective. In there, at the top, you can, for example, get the top view and then only look at the top from the current scene. There are loads more options, and they're all fairly self-explanatory. To get out of it, you simply use the middle mouse button, move around, and then you rotate back to the normal view. Besides that, the other important thing are the axes. We have an x-axis that's effectively left and right. Then we have a y-axis. This one goes up and down. And finally, we have a z-axis that goes backwards and forwards. This works very similar compared to the 2D space. However, with one major difference for the y-axis. If you want to go up on the y-axis, you have to increase y. Whereas in the 2D space, if you want to go up, you have to decrease y. But that's basically it. If you want to go further to the right, you would, for example, have to increase x, and so on. The system becomes fairly straightforward. And with that, let's create a 3D scene that I want to rename to level. This I want to save right away, and for that, I want to create a new folder called scenes. Inside of this folder, I want to create another folder called levels. And in there, I want to save level.tscn. With that, we have a very basic 3D scene. And in there already, we could use transform to update the position, the rotation, and the scale of this point. Although that wouldn't do very much, because we are working with a single point in 3D space. To actually see something, we have to create a node that can display 3D objects. A really powerful one that you want to start with is called Mesh Instance 3D. If you add this one, nothing is going to happen. Although let me expand the window just a bit so you can see the full name. So right now nothing happened, but now in the inspector for this node, we can define a mesh. And there are quite a few options in terms of what kind of object you want to create. For example, a really simple object could be a box mesh. And with that, we are getting a simple 3D box. Looks really good. On top of that, if you click on this box, you can update the dimensions. For example, you can change the X size, the Y size, or the Z size. Fairly straightforward. And you can also update the subdivisions for each of the dimensions. Although if you're doing that, nothing is going to happen, at least on the surface. So what's happening here? And to understand that, you want to look at perspective once again. If I click on that, and then instead of display normal, click on display wireframe. Then you can see all of the vertices and the edges of this object. And this is what I talked about earlier. When you have a 3D object, you are defining it via 3 parameters. The vertices are all of the individual points. This would be one vertex, this would be another one, then we have another one here, here as well. This one would be one, this one would be one. All of these individual points are a vertex. And these vertices are connected by edges, which are all of these lines. And then via these edges, we are creating actual faces that the user can see. And what we are doing with these subdivisions, if I now update them, you can see what's going on. you can tell that we are adding more or less vertices. If I set this to 0, 0, and 0, we have the lowest amount of vertices possible to define this space. But we can add more, which the user wouldn't see right now. But later on, for example, when we are creating the water, what we want to do is create a shader that updates all of these individual points and moves some of them a bit further up and others a bit further down. That way, we can create a wave. But this can only work when we have lots of vertices to work with. Although at the moment, that's not really something I care about. So we can leave this at 0, 0, and 0. And to make sure we can see stuff again, let's go back to display normal. And well, with that, we have a very basic object. Besides that, the next parameter is material. If you click on that, you are getting 3 options: standard material, ORM material, and shader material. Standard material is what we are going to use the most. This is a basic material to define colors, reflections, transparency, and things like that. Besides that, we have an ORM material, which is slightly more advanced and a bit more powerful. For this entire tutorial, we're not going to use it at all, so don't worry too much about it. Finally, we have a shader material, and this one is, well, to create a shader, something we are going to look at later. For now though, I simply want to create a standard material 3D. And in there, we're getting lots of options. The one that you probably want to use the most is called albedo. For all practical purposes, this is color. And there we have a color picker field, and I can simply update the color, and then we're getting a different color for this object. That's basically it. Inside of this field, you can also define a texture, although for that, you have to be careful. For example, if I take the Godot icon and drag it in there, you can also simply drag it on the object itself. Then you can see, and let me remove the color or reset it to white again. You can see we have applied the texture, but this doesn't look great. That is because we are currently trying to apply a 2D image to a 3D object. And Godot doesn't know how to place different parts of this image onto these various faces, which is why all of this looks really weird. Although, if you're looking at graphics, there we have a folder called Grid with lots of subfolders, simply for different colors. And those are really nice because they're super flexible. For example, if I take texture 7 and apply it for the texture, then we're getting something that looks a lot better. And if I made this a bit darker, it would look even better. Something like this. There you go. Now we have a texture that looks a bit better for this object. And alright, besides that, if you look at the material again, so just click on it, there are loads more options that you could be working with. A couple of really common ones are metallic and roughness. Those basically define how metallic the object is going to look, which at the moment isn't really something we can tell because there isn't really a light in our scene. But what we can do on the level is add a light node. And in 3D, we have a directional light, an omni-light, and a spotlight. I'll talk about those in much more detail later on. But for now, we want to have an omni-light, which is an omnidirectional light, like a candle or a light bulb. If you create that and move the thing up by just a bit, there you can see that we're getting some light. And one thing you want to make sure here is that if you can only move this thing in larger increments, you want to hold Shift. I think by default, Godot wants to move to increments of 1, but we want to move at smaller spaces. So if this thing doesn't move, hold down Shift, and you're going to move it in the right space. Anyway, now we have some light. And now, if I go back to the material, and I set the roughness down to 0, then if we have the right angle, you can see that we have a light reflection. And if I make this object more metallic, you can see that, well, we're only getting this one part of the light and the rest doesn't reflect anything. But we can make all of this more specular, then we get a bit more light. And if we set the roughness to a greater value, then this light is diffused more and more. If we change the color of the light, which you can do inside of the light, then you can also tell that this light is being reflected. So that way, you can create fairly realistic scenes quite easily. Although at the moment this is getting a bit more advanced, so I want to get rid of this OmniLight and focus on the mesh instance 3D. I want to reset all of these attributes, and then we are good to go. There's one more attribute I do want to look at, and that is called UV. UV is how a 2D texture is applied to a 3D object. And in there, we can specify a scale and an offset. And if I simply update these values, you can tell what's going on. We are basically moving all of these coordinates to effectively animate this texture. This also works with scale, and then you can do some funky stuff. But that's basically it for materials. If you want to get a specific effect, you effectively look through all of these options, and then you, well, create what you need. And with that, we can create a very basic object. So I can minimize the mesh, and besides that, we can look at transform and then work with the position. So let me zoom out just a bit. If I now increase or decrease X, we're moving left or right. If I increase Y, we are going up, and if I decrease Y, we are going down. And then on the Z-axis, if I increase it, we're going this direction. And this also works the other way. Besides that, we have a rotation. This one also works as expected. And finally, we have a scale, which you can link or not. It's entirely up to you. I think all of those are fairly straightforward. However, what is not straightforward is that now we have a rotation edit mode and a rotation order. So rotation order lets us define in which order we are rotating. And for the rotation mode, we have Euler, coordination, and basis. If I click on basis, we are getting some weird stuff. And if I change any of these values, we are effectively sharing the object. Basically, inside of the 3D space, you have different ways to define a rotation. You could either go with different angles for each axis, or you could, like for basis, define a vector for every single axis. This would be called a matrix, which is a better way of working with rotations, but it's also a bit more complex. For now, I would say don't worry too much about it. I suppose at this point, simply be aware that there are different ways to rotate in a 3D space. Also on the Godot docs, you can find an article called Using 3D Transforms. In this article, you get a lot of information about the different ways to transform and their upsides and downsides, which can be incredibly helpful. And this one also includes quite a bit of math and code examples. Let's reset all of this. Then we have a very basic object, and that's all we need for now. Now, besides using a mesh instance, you can also use other nodes. Or I suppose, first of all, if you want to create different kinds of 3D objects, you can simply create one of those, and there are quite a few options you could play around with. Besides that, if you add another node, you can look for CSG nodes. This CSG stands for Constructive Solid Geometry, effectively a 3D object. And there you can get a box 3D, a cylinder, a mesh, a polygon, a sphere, and a torus. Let's go with a sphere for now, something simple, create. And if I hide the object we have created so far, you're getting a sphere. On the sphere, you can also set the radius and the amount of radial segments you're getting. The more you define here, the rounder this thing is going to become. Also in there, you can right away tell how many vertices and edges and faces we have. And you can activate and deactivate smooth faces. So this would be another way to create a 3D object. Finally, something that you see occasionally is a sprite 3D. Also, there's an animated sprite 3D, but they work in basically the same way. If you create that, at the moment, you cannot see anything because we have to define a texture. And for that, let's use the Godot logo, drag it in there. And it should be a child of the level. And now if I hide the sphere, you can see the Godot logo. This works reasonably well. Although in practice, you don't really see a 3D sprite because in an actual 3D game, you don't ever really need this kind of object. It's just an easy way to get started. But effectively, those would be very easy 3D objects that you can get started with. And if I move them next to each other, you can also see everything just a bit better. There we go. This would be a very easy start. And just to make sure you could follow along, let's do an exercise. I want you guys to create a new 3D object. This could be any kind of shape. Simply choose something that you like. Then rotate this object around the y-axis and move it up. Finally, give it a new material and make it red. Should be fairly straightforward. The end result should look something like this. Pause the video now and see how far you get. Let me get rid of everything we have done so far and instead create another node. I suppose I can go with a mesh instance 3D and then create a new mesh, something that we haven't seen yet. Let's go with a torus mesh. If you now click on the mesh, you can define an inner radius and an outer radius. Let's make a really nice donut-y shape. That looks about right. And then, I guess while we are here, we can assign a new standard material and then give it an albedo color. I said red in the exercise, let's go with that. Something like so. That looks about right. That's all we need for the material. And finally, inside of transform, we can rotate the thing around the y-axis. Although for this object, that doesn't make too much sense because it's, well, perfectly round. So for this one, I'm going to rotate it around the z-axis so you can see a bit better what's going on. And finally, we want to move it up, so increase the y position. And then we can place a 3D object inside of the game. So I think so far this has been fairly straightforward. But next up, we have another issue. Let's say I want to actually run this scene, which I can do by clicking on the play icon and then select the current scene. If I do that, we are not able to see anything. And that is for a couple of reasons that I talked about earlier. That in a 3D scene, there are a couple of things that you always need to get any kind of output. The most important one is a 3D camera. In a 2D game, you can simply get the starting position, and this would be what you see by default. But in 3D, Godot doesn't know what to point at. But that we can fix quite easily. So this level is going to get another child node called camera 3D. And now we get another icon that we can move around. Let me move it like so. And a bit up, so we have the donut right in the view. Also at this point, we get a camera preview. If you click on that, you can get a preview of what you're going to see in the game. Let me rotate the donut just a bit more around the y-axis. So it's going to be a bit more visible from the camera. That looks about right. And if I now run the scene again, we do get the donut, but it doesn't look anything like what we are seeing in the editor. So what's happening here? The reason why that is happening is because inside of this preview, we have some light, but this light is not being used inside of the actual scene when we are running it. And to understand a bit better what's going on, let me add a bit more space. In fact, I want to maximize all of this. If you look at the top of the inspector, there we have these two icons, and you can toggle them, and then you can kind of see what we can actually see in the scene. If you then re-enable them, you get an output that you would rather want. And to get all of this into the actual scene, you want to click on these three dots, and there you can customize the entire thing. For example, you can change the sun energy, you can change the altitude, so the angle of the sun, and the azimuth. You can tell what's going on here. You can also change the sky color. This one can make quite a big difference. And finally, we have the ground color, which is also making a difference. And this is something you really have to understand inside of a 3D scene, that you have the color of the actual material. For the donut, this is red right now. But depending on what else is going on with the light, this color changes. And that is important because, for example, this object might be inside of a shade. And this is then going to determine what the color actually looks like. I guess the best way to visualize this is if we change the sun color, which is this attribute, and we make this very, very different. Let's go with a bluish color. If we are maxing out all of this, we're getting almost a purplish color. If I make this full blue, then you can see it better. This is a really important thing for any kind of 3D object. You always have to combine the textures with the light and the shadows and the environment. If one of these factors don't work out, the entire scene is going to look pretty bad. Now, generally, for sunlight, you want this thing to be fairly white. That is mostly neutral, although for some scenes, you can change this quite a lot for another kind of effect. The sun energy, I want to keep at 1 for now as well. And for the sky color, I want to go with, let's go with a bluish color. It should also be fairly light. Something like this, and the ground color doesn't really matter. Sky energy 1. Then we get something fairly neutral. Once you're happy with the result, you can add the sun to the scene and click on the 3 dots again, and then add the environment to the scene. If I now show the scene tree again, we have gotten 2 more nodes, world environment and directional light 3D. Now you can still update all of these values. For example, in directional light 3D, we still have the light, the energy, the shadows, and so on. And inside of world environment, we are now actually getting a lot more options. If you click on the environment, there you have a ton of stuff you could be changing. I will go over all of this later in more detail. Just keep in mind, for a 3D game, light and environment are incredibly important. And especially inside of the environment, you can really fine-tune how the game is going to look. Although this I do not want to do at the moment. If I now run the scene again, we can actually see a colorful donut. So this is much better. The last part that I want to work on for this section of the tutorial is how can we animate this donut. And for that, we have to add a script to it. Now this script I do not want to keep around later on. So let's store it inside of the main folder, because later on we are going to get rid of it anyway. And then we can keep all of the other default options. So create, and now we have a very basic script with the default functions. Although I don't want any of this. Instead, I want to create a function underscore physics process. Most of the time when you're moving a 3D object, you want to use this function, simply because it is much more accurate in terms of physics. I suppose that also applies to the 2D space. Anyway, in there, we can target the various attributes of the 3D object. For example, we have rotate, rotate X, Y, and Z, rotation, rotation degrees, and so on. For now, I simply want to rotate Y. Let's go with 0.1. That might be a little bit too fast, but let's try. And this looks alright. So now we are rotating this object. This is going to continue forever, and this works fairly well. Alternatively, what you could be doing is rotation degrees and increase this value by a vector 3. Because remember, we have an X, Y, and a Z axis. Now to get the same result for Y-axis rotation, I want to rotate 0 for X, 0.1 for Y, and 0 for Z. If I now run all of this again, we are getting a very, very slow rotation. But it does rotate nonetheless. Let's change this 0.1 to a 10, and then we're getting a rotation that is visible again. Cool, this works. Besides that, we could also update the position or the global position, which once again is going to be a vector 3. So for example, if I wanted to move this donut to the right, I would need to get a vector 3 with X, Y, and Z. To only move it to the right, I want to only add X values. Let's go with 10, 0, and 0. If I now run all of this again, the movement is a little bit too fast. And that is because when you're updating anything, you should always multiply it by delta. And now we're getting much better movement. And that's basically it. So via that, you can change the position, rotation, scale of basically any kind of object. On top of that, you could also get the material. So at the moment, if I go back to the 3D scene and select the donut, we have a mesh, and inside of this mesh, we have a material in which we are setting the color. And this we can access via the material. Let's do all of this inside of the ready function. So func underscore ready. We have to get the material, which happens inside of the mesh that we have created. And there, if you type material, we have surface get material and surface set material. We want to get the current material. And in there, we have an ID, which by default is going to be 0. If we have that, and let me print the result, I can run the entire thing, and in the output, we're getting a standard material 3D. On this standard material, we can, for example, change the albedo color. For that, I want to store it inside of a variable. Let's call it var material. And then we can get this material once again and update the albedo color and simply assign it a new value. Since we want to create a color, we can use the inbuilt color value in Godot and then get rebuild one. Let's go with green. If I now run the entire thing again, we're getting a green donut. Via this system, you can update any value inside of the material fairly easily. And once you have the mesh, you can also update the inner radius and the rings and stuff like that. So the main thing you want to think about is that inside of this mesh instance, we are creating a mesh. And this mesh is defined by an inner radius, an outer radius, rings, and ring segments. On top of that, inside of the mesh, we have a material, which is giving us the color. So the main thing that you want to take away at this point is to create a basic 3D object, you get a fairly complex thing that you have to work on. In the 2D space, you basically create a node and you assign it a texture. And that's all you really do. In the 3D space, for an object, you usually have a node, this node has a mesh, and then you can give it a material. You can also give it multiple materials. So if you go to geometry, there you have material override and material overlay. So a lot of things that you could be working with. And I think with that, we have a really solid basic start. And to finish up all of this, let's do another exercise. I want you guys to, number one, slowly scale the donut via code, meaning it should become larger and larger as time goes on. Number two, change the outer radius of the mesh. And I suppose if you have a different mesh, simply try to update one of the attributes of the mesh via code. Either way, pause the video now and see how far you get. Righty, back inside of the code. I want to work inside of the script and first of all work on the scale. This we can access fairly simply via the scale property, to which we want to add a small value, which once again has to be a vector 3. And I think we should work with fairly small values. Let's go with 0.1, 0.1, and 0.1. Also, I want to multiply all of this with delta, although that might be a very small number. Let's try, and this isn't really visible. But if I change this to, let's say, 5, 5, and 5, and try the thing again, then we're getting a donut that's growing. So this is working, although the result is getting a bit silly. I guess we can go with 2, so it looks a little bit less weird. That works about alright, but I think going with 0.5 still noticeable, but now it doesn't overwhelm the entire scene. Cool, so that covers the scaling. Next up, we also want to update the mesh itself, which I want to do once again inside of the ready function, because in there we already have the material, but besides that, I want to work with the mesh, which we can access via the mesh. And just as a reminder, I am talking about the mesh that we have created all the way in the beginning to create the donut. And in there, we have the properties inner radius, outer radius, rings, and ring segments. I want to update the outer radius. If you hover over it, you can see we have outer radius, which means inside of the mesh, we are getting an outer underscore radius. Just to make sure this is working, let's print the result. We should be getting 2.6. And we get the same result. So that looks pretty good. That means next up, we can update this value and set it to a value of, let's say, 5. Then I can run the scene again, and we're getting a differently shaped donut. I suppose the one thing that's getting a bit confusing is that if you simply type mesh and then .outer, you would expect Godot's autocomplete to give you outer underscore radius as a suggestion, which it unfortunately does not. For this part, you do have to have a bit of practice to see what's available inside of these options. The autocomplete feature here isn't entirely reliable, but if you practice all of this a bit and you look at the inspector, you can overcome this quite easily. With that, we can move around 3D objects. Next up, I want to work on the player movement. That way, we can actually capture user input and explore a level. Now, for this section, there are 2 super important things that I really want to work on. Number 1, is going to be 3D movement. And for that, at the moment, we have the issue that our controller or mouse and keyboard will only give us 2D input. Or in other words, we can move up, down, left, and right, which for a 2D game would be sufficient, which means if this is the player, we can go up, down, left, and right. In other words, if the player presses up, then we are moving the player up by a certain amount. But this isn't actually what we want to do, because in our case, moving forward should be relative to the player rotation. If the player is rotated by, let's say, 30 degrees, then forward should be this way. Or in other words, if the player presses up, we want to go in this direction. So effectively, up isn't really up, it's more of a forward motion that is relative to the player rotation. Besides that, the other important concept that we have to work on is going to be 3D physics. And for that, if you know 2D physics, you should feel right at home, because all of the familiar physics nodes from 2D are also available in 3D. Here are all of them, and you can tell we have a static body, we have a character body, we have a rigid body, and we have an area 3D. All of those work basically in a similar way compared to the 2D equivalents. The only difference now is that they are in 3D instead of 2D. Although on top of that, we're getting a few more physics bodies. Most importantly, there's vehicle body 3D and physical bone 3D. There's also animated body 3D, but that one isn't too important. I think all of these make a reasonable amount of sense. A vehicle body is if you want to have a racing game, so cars have special physical properties. A physical bone is if you want to have physical forces on a skeleton. Something super cool, but a bit too advanced for this tutorial. So for this section, we are only going to focus on 2 physical bodies. The character body 3D for the main player, and then we have a static body for some basic obstacles. Just like in 2D, you have to create a node, and then you have to give it a collision shape. Also for the character body 3D, we still have move and slide, and we have to define a velocity. This one works just as before. Back inside of Godot, first of all, I want to get rid of the donut we made in the last section. I can simply delete it, and I also want to get rid of the mesh instance GD script. We don't need any of this anymore. Instead, I want to create an entirely new scene. And in there, the root node is going to be a character body, and make sure this is 3D. If you're doing that, you can't really see anything. And on the left side, we get character body 3D with a warning that this node has no shape. This we're going to fix in a second, but first of all, I want to rename it to player. And then save the scene. Inside of scenes, I want to create a new folder for entities, and in there, another folder for the player. Then click on save, and now we have a scene. So, first of all, for the player, I want to create some kind of shape so we can actually see it, which I'm going to do via a mesh instance 3D. And usually to get started for a player, you're using a capsule mesh. The default values here are totally fine, although I do want to move it up by 1 unit so that it's right on the bottom. I guess if I look from the front, you can see that we are right on the 0 point on the y-axis for the bottom of the player, which makes it a bit easier to see what's going on. Once we have that, for this character body 3D, we want to create a collision shape 3D. And for that, once again, you can get a collision shape or a collision polygon. We want to go with a shape. And then inside of this node, we can define a shape, which can be a capsule shape that by default has the same dimension as the mesh we have just created. Although we have to move it up by 1 unit on the y-axis, and that looks about right. If you wanted to change the shape, you can use the red dots and do something like this, or you could go to the capsule shape itself and then update these values. This works just like it does in 2D. And with that, we have a very basic player character that arguably doesn't do very much. For something to happen, I want to go back to the level and then add another node that is going to be a node 3D that I will rename to entities. In there, we are going to attach the player scene that we have just created. There we go. This looks all right. If I now try to run the scene, nothing should happen. Or well, you can see the player, but it doesn't do anything. That is totally fine though. Now besides this player, I also want to create a very basic environment. For that, inside of the level, I'm going to add another node 3D and call it environment. Maybe not the best name because we already have a world environment, but you get the idea. In there, we're going to have all of the obstacles. And right now, I want to create a static body 3D, which once again is going to be just a node that is going to give us a warning that this node has no shape. And this we can approach like we have done the player. We can add a mesh instance 3D, or rather to do something else, let's go with a CSG box 3D. Although you can choose either, it really doesn't matter. For the size of this one, I want to go with 40, 0.5, and 40. That way, we are getting a platform that the player can stand on. Next up, we want to add another collision shape that should have a shape of a box shape, and then we can use the same numbers. 40, 0.5, and 40. And just to make sure that these numbers line up, that looks about right. Perfect. And we can also tell the player is standing on top, although for that, let's say I want to move this thing just a bit down. More. There we go. I suppose we know that this platoon is 0.5 units tall, which means instead of transform, we can remove half of that, minus 0.25. And then we should be perfectly below the player. All right, so with that, I can run the game and we can see the player. Although at the moment, nothing happens. Now to make something happen, the player is going to need a script. And if you have a character body 3D and you add a script, Godot has a default template for basic movement of a character, which I suppose is something that we can start with. So I want to save the script inside of the player folder and then create. And then we already have some code. And now the player can move around just fine. This isn't ideal and we're going to change a lot, but it's still a pretty good start. And when you're looking at this code, most of it should feel relatively familiar. So for example, there we have the velocity, and this we are simply increasing by some gravity multiplied with delta. Then we have a jump. I didn't actually show this one, so I think if you press enter, the player jumps. Not a great jump once again, but certainly a start. The most important part, and let me expand this, is first of all, we're getting input. And for that, we are using the UI buttons, so left, right, up, and down on the keyboard. This we are then turning into a direction. And for that, we are using transform basis, the value I talked about in the last section that represents a rotation in the 3D space. This we are then multiplying with the vector 3. Pay close attention to what numbers we are using. On this vector, we have an X movement, we have a Y movement, and we have a Z movement. Y in this part is going to be entirely ignored, because for this direction, we only want to move forward and backwards and left and right, meaning up and down should be entirely ignored, which happens because this value is 0. After that, if we have a direction, we are updating the velocity for these two numbers, and if that is not the case, we're moving both of these values back to 0 with a move toward function, and finally, we're calling move and slide, and that way we're moving the character body 3D while also respecting physics. That's really all that's happening here, so I hope it's not completely confusing, but if it is, don't worry too much about it, because I want to get rid of all of this anyway, because we are here to learn, not to follow some template. Now, before we can get properly started, if you look at project and project settings under the input map, we already have quite a few different inputs. For this game, you can either use a game controller or a mouse and keyboard. Both is totally fine. In my case, for the gamepad, I am using an Xbox controller. If you have something like a PlayStation controller or some kind of third-party thing, it should also work, but the buttons might be slightly different. So it might be worth going through this list and then reassign, for example, the jump button, just to have something that you really like. And if you don't have a controller, mouse and keyboard are totally fine. Now, first of all, I want to create an export variable that is going to be the base speed of the player, which I have set to 4.0. And it's also a good idea to specify what kind of data type you want. In this case, I want a float. And to make this a bit more elegant, you could write it like that. That way Godot is inferring the data type and always keeps it like that. That would be our basic speed. Next up, I want to have a variable with the movement input, which by default is going to be a vector2.0. And it always has to be a vector2. After that, I'm going to call the function underscore physics process. And then first of all, override the movement input, which we can do via input and then get the vector, for which we want to get the left, right, forward, and backward movement. And I guess I should have specified inside of the input map. I have left and right. Those are straightforward, I think. But then instead of up and down, I have forward and backward, which are effectively just up and down. But I think in 3D space, it makes more sense to think of it as forward and backwards instead of up and down. Because in our case, up would be the jump. So don't get confused. For get vector, first of all, we want to have the negative x, which in our case is going to be left. Then we want to have the positive x, which in this project is going to be right. Next up, we have the negative y, which should be forward. And then we have the negative y, which is going to be backward. With that, if I print the movement input and run the entire game, you can see in the output, I can now move on the gamepad left, right, up, and down. Or instead of up and down, forwards and backwards. And this is giving us pretty good numbers. Now, if you don't have a gamepad, you can also use the WASD keys, and then you're getting similar values. That looks pretty alright. After we have that, we want to update the velocity of the player, which is actually going to define in which way the player is going. For example, if I set this to a vector3.right and then call move and slide, the player should be moving very slowly to the right. And that is looking pretty good. Cool. Which means we just have to override this vector3 with the value we are getting from movement input, and we should have a pretty solid start. But this we couldn't do right away, because if I add movement input in there, we are assigning a vector2 to a vector3, which obviously isn't allowed. Instead, we have to create a vector3 from scratch, and in there specify x, y, and z. Now at the moment, we only want to move the player forward, backwards, left, and right, which means y, which is up and down, should always be 0. However, for the x part, we can get movement input.x, and for z, we want to have movement input.y. That way, if I run the entire thing now, I can use the keyboard WASD keys and move the player around just fine. Now it's a bit slow because we're not multiplying all of this with the base speed. But if we are doing that, then the player is moving a little bit faster. So this is working quite nicely. Definitely an improvement. And I really want to emphasize this vector3 is necessary because the movement input is in 2D. And this 2D value, we have to translate into 3D movement, which we are effectively doing by ignoring the up and down part, or the y-axis in this particular instance. But other than that, this is effectively the most basic kind of 3D movement that you can get. Also, we are not going to need delta, at least for now, and the debugger is annoying me just a bit. If you had an underscore, Godot is going to stop complaining. That, I can run the entire thing again, we can still move around, and the debugger is happy. Perfect. Now, this is a good start, but I don't actually want this kind of movement specifically. Instead, I want the camera to follow this player instead of being in a static position inside of the level. So this camera here, I want to get rid of. And instead, inside of the player, I want to add the camera. Now, you could simply add the camera right away to the player. and then move it a bit to the side. Let's say here, we can rotate it down and do something like this. If I now run the entire thing again, now we have a camera following the player. Bit of an improvement, but this still isn't ideal. And the camera is going to be really important and a bit more complex. As a consequence, it should be in its own scene. Let's create a new scene, and for now, I want to create a 3D scene, which I am going to rename to Camera Controller. This I want to save inside of the player folder. Click on Save. Then we have a camera controller that is going to get a camera 3D as a child. And this camera, we are then going to move to an offset somewhere here. The exact position for now doesn't matter so much. What you also want to do inside of the player scene, add this camera controller as a child. And this is definitely a bit too close, so let's move the camera a bit further up. You may have to experiment a bit, but now you should be getting a roughly similar result compared to what you have done before. And that looks alright. This camera, we now want to be able to rotate, which we do by adding a script to the camera controller. This can stay inside of the player folder, so this is totally fine. And I want to get rid of all of the functions in there. For now, to keep it simple, I want to work on the horizontal movement, which means if this is the player from a top-down view, at the moment the camera is roughly here. Now the player should be able to rotate the camera either in this way or in this way. Also, while doing that, the camera should always point at the player, so the player effectively is never able to go outside of the view of the camera. This we can already do fairly easily, because if you look at the 2D scene, if we simply rotate this camera controller node 3D via transform and rotation on the y-axis, we can rotate the camera, and the camera is always going to point at this center position. Which means effectively all that we have to do is update the Y rotation of this point, and then we are good to go. Although in practice this gets a little bit more difficult. I suppose to get started, we can work on the mouse input, which I want to capture via the input function that is inbuilt into Godot. In there, I want to check if the event that is being triggered is an input event mouse motion. And if that is the case, I want to print event.relative. This would give me the relative movement of the mouse, which means if I run the entire thing again, I can move the mouse, and we're getting the relative mouse movement. This we could use right away on the rotation.y of the camera controller node 3D, which we do by simply adding event.x. That way, if we're moving left or right with the mouse, we are updating the Y rotation of the camera controller point, which is rotating the entire camera while pointing at the player. Although in practice, this doesn't work yet because I forgot event.relative. Next attempt. There we go. And now if I move the mouse very slightly, we're getting a massive rotation. And that is simply because the mouse relative movement is way too large. But if you multiply this with 0.05 or some other very small number, this should be much better. So now we're getting much smoother rotation around the player. That feels pretty good. We can also still move, but now we have a really weird behavior. So the rotation of the camera and the player movement are entirely unrelated, which means if I look at the player from this angle and move forward on the keyboard, so W to ideally go forward, we are now going towards the camera. And if I look at this angle, we are still moving in the same direction. For an actual game, this would be super confusing and something we are going to fix in just a bit. First of all though, I want to make this a bit more flexible and also get gamepad input. For that, I want to create another function that I called rotate from vector, which wants to have a vector as an input, and this always needs to be a vector 2. In there, we want to first of all check if the vector has any length at all. And the easiest way of doing that is to check if the length of this vector is 0, and if that is the case, we're ending the function via the return statement right away. If that is not the case, however, then we want to update rotation dot y and add vector dot x. That way, if we have input event mouse motion, we can simply call rotate from vector with event dot relative. The other line we don't need anymore, but make sure you are multiplying the relative vector with 0.05, and then the result should be the same. And that looks about alright. Although there's one thing I forgot to mention. When it comes to camera movement, people have different preferences. Some people want, if you're moving to the right, the camera to rotate in this direction. However, other people really like to invert the camera, which in practice means that you want to subtract the value. And that way, we're moving in the exact other way, which at the moment is really hard to see. But in the game, this gives you a very different camera behavior that some people will like or will hate. Ideally, you want to make this flexible so people can use whatever they like. I'm going to keep it with minus equal vector.x, but in your case, you can go with plus equal. I suppose for now, just keep it as it is, and later on, if you don't like the movement, simply change it. That covers the mouse input for the horizontal rotation. Next up, I also want to get the controller input, which I'm doing via the process function. In there, I want to declare a variable, let's call it joy direction. First of all, like for the player movement, I want to get input and then get vector. If you look at the project settings in the input map, besides left, right, forward, and backwards, we also have pan left, pan right, pan up, and pan down. Those are the right joystick on the gamepad, which is usually what you use to control the camera. And to capture all these values, for negative x, for example, I want to have pan left, and for positive x, I want to have pan right. Then for the negative y, I want to have pan up, and for positive y, I want to have pan down. And simply printing those values via print joy direction. If you now run the game and you have a gamepad, if you use the right joystick, you can get quite a few different inputs inside of a vector too. That looks pretty alright. And these values we want to use inside the rotate from vector function. So in there, I want to add the joy direction. Although now, if you're running the entire thing and I rotate to the right, this is a little bit too fast. I suppose to control this value a bit better, first of all, we want to multiply it with delta time. On top of that, I want to multiply it with another vector too, in which we are going to have a horizontal acceleration and a vertical acceleration. These two values don't exist at the moment. So all the way at the top, I want to have an export var horizontal acceleration, which should be a floating point value with a default of 0.2. Then we can duplicate this. And next up, I want to have a vertical acceleration. Also a floating point value, although with a default value of 1.0. With that, I can move the camera around via the joystick, and this looks alright. Now, once again, this doesn't actually influence the player movement. So if I simply move in the same direction and rotate the camera, this is going to feel really, really weird. But something we can work on. And just to make sure that you haven't fallen asleep, let's do an exercise. I want you guys to implement the vertical rotation for the camera. So effectively that the camera can rotate up and down by a small amount. And I really want to emphasize this should only be a small amount, otherwise this is going to look a bit weird. Which in practice means limit this rotation. Simply play around with what numbers you like. Pause the video now and see how far you get. First of all, how to think about this problem. And well, effectively, we want to rotate one of two things. We could either rotate this X value, and then we're moving the camera up or down. This would be one approach. Alternatively, you could also get the camera itself, and in there, go to transform and then rotate this X value. I think both would be acceptable. Let's keep this at -30. But I want to keep it at the camera controller so that we are moving this point. Although targeting the camera wouldn't be much more difficult, so both would be perfectly acceptable. To implement all of that back in the code, I want to target rotation.x and from that subtract vector.y. This is already going to work, but it's going to be a bit strong, I think. So if I move the mouse, you can see that this is a little bit of a weird effect. But if I use the gamepad, and we can make all of this a bit more gradual, you can see it's definitely coming together. We just have to limit this amount, and then we should be good to go. To get that limitation, we have to get rotation.x and spell it correctly, and then clamp the value. We still want to get rotation.x and then set a minimum and a maximum value. Since at the moment we are working with radians, you want to choose fairly small values. Let's say -0.1 and 0.1. I can go up and down by a bit, and I can go left and right. This also works with the gamepad, and perfect. Now this we do have to fine-tune just a bit later on. But since we do want to make a few more changes, I think for now this is fine. We definitely have the basic mechanic in place, so this would be a fairly simple camera mechanic. Although we don't actually use this one. Or in other words, if I run the game, if I simply move forward, then we are moving forward. But if I now move the camera to the side and press forward, the player is still moving in the same direction. Which means we have to implement a rotation mechanic. And that is going to happen inside of the player. Fortunately, we don't need very much. First of all, I want to get the camera that we are working with inside of the player script. Because at the moment, we only have it inside of the camera controller as a child of another node. For that, I want to create a new variable, camera, and the actual value of the camera we can get for the camera controller and then camera 3D. But Godot is complaining that we can only do this once the scene tree is ready, which means all of this needs to be on ready. Then Godot should be happy, and it is. With that in place, what we are able to do is get the Y rotation of this camera. Once we have that, we can choose this camera and then get the global rotation.y. And let me just print the value, just so you have an idea of what we are getting. We start with 0, but if I go to the right, we're getting a radian rotation. And then we slowly go back to 0. Now this value is incredibly useful because it tells us where we are looking, or where the player is looking to be a bit more specific. And to actually use that value, let me cut it out. We want to get the movement input and then rotate this vector by this view angle, for which we have a nice rotated method that every single vector has. And in there, I want to pass in the camera global rotation.y. If I now run the entire thing again, I can go forward, and right now this doesn't do anything. But if I go to the side and I press forward again, we are now moving in a different direction, although not the right one. So to make this effect a bit stronger, I can simply go forward, and if I rotate the camera, we're going in a circle. Something is happening, but it's not ideal. And to get the proper amount, we want this value to be negative. If I now run this again, I can go forward, and if I rotate the camera, I can go forward again, and now we get the right amount. This looks much better. So I keep on pressing forward and nothing else, I only rotate the camera. And with that, we have much nicer movement. And I believe this negative was needed because the camera in my case at the moment is inverted. But other than that, we now have a basic movement that is influenced by a camera. That's a really good start, although this I want to fine-tune just a bit. And to illustrate what I want to do, let me add another static body 2D, which is going to be some kind of wall. So static body 2D, and to this thing, I want to add a CSG box. For the size, for X, let's go with 10. For Y, I want to have 10 as well. And for Z, we can leave 1, doesn't really matter. Next up, as a child, I want to add a collision shape 3D. That is also going to be a box shape. And then we get 10, 10, and 1. So this is totally fine, except that I want to move this thing a bit further to the right so the player doesn't spawn right in the middle of it. If I now run all of this again, I can still move around and the player can collide with the wall. That is a really good sign. However, if I rotate more, we cannot see the player anymore. And that's, well, a bit of a problem. So ideally, I want the camera to zoom in and respect the wall. So effectively, the camera should be a physical part of the world. And for that, Godot has a special node that is super useful. Which means, in this case, I want to get the camera controller 2D and then change the type. The node that we are looking for is called a spring arm 3D. For all practical purposes, this spring arm is a flexible arm that starts at the center position and then tries to push the camera by a certain distance. However, if there's some kind of wall in between, let's say in our case we have a wall here, then the camera is only going to be pushed up to this point while still facing the player, which is really all that we want. The values that you mostly want to change are shape and spring length. For the shape, I want to have a sphere shape 3D. And then for the spring length, I want to go with a value of 6.5. And now, if we are running all of this again, things have broken just a bit, so we have to fine-tune things. But if you go up a bit and you go to a wall, you can already see parts of this system working. So if I rotate next to the wall, the camera is going to zoom in. We just have to update the position a bit. And for that, for the camera 3D, I want to reset all of the transforms, meaning we have no position change and no rotation change. Let's try it again now. And now we're on the same level as the player, definitely an improvement. And if I go to the wall, we are zooming in. So this is a good sign. And now we have to change the camera position and angle. That I want to do inside of the player scene. There, we can offset the camera controller itself. For this one, we can go to transform, and for the Y position, I wanted an offset of 1.4, so we're going a bit up, and then for the X rotation, negative 25 degrees, then we're looking down just a bit. Let's now try all of this again, and this is looking significantly better. Although, if I rotate the camera, the vertical rotation is clipped, so that we have to work on. But first of all, we are now getting the camera that is respecting the wall and zooms into the player once we get close to it. Now, this system can break down. If I get too close and zoom in, then the camera clips into the player, which isn't ideal and something you have to keep in mind. I suppose for now, it's not too much of an issue, but something that can become a bit annoying. Anyway, one thing that we have to fix for the camera controller, I want to add export var min limit underscore x, which has to be a floating point value. The same thing we want to do for a max value, so maximum limit x. And finally, while we are here, at the moment for the mouse acceleration, this value, we just have a random value. This should also be a variable that we are declaring in the beginning. Export var, let's call it mouse acceleration, with a floating point value of 0.005. That value we want to paste in there. And then we have to set a minimum limit x and a maximum limit x. These values we're going to use down here, where we have a minimum limit x and a maximum limit x. Getting the right value here is going to require you a bit of fine-tuning, which is why we are exporting these values. That way, inside of the player, you can work with all of this in quite some detail. And to get just the right camera behavior, you want to play around a lot. The values for this game that seem to be working best are negative 0.8 and negative 0.2. If we now try all of this again, that looks about right. I can go up and down, and that is much nicer. Perfect. Now that is a really good start. However, inside of this script, when we are looking at the camera controller, we kind of have a minor issue, and that is that the controller and the mouse are sometimes fighting with each other. You notice that in particular, if I run all of this again, if I try to rotate the camera via the joystick on the gamepad and I move the mouse, then we are getting some really weird behavior. And if I just move the mouse a bit or have it even in the screen, we are getting some weird stuff that shouldn't happen. So ideally, you would want to make sure that you only ever use one at a time of these two inputs. You could create a variable that says something like mouse active, or in my case, I'm just going to comment out the mouse input, and then we don't have to worry about it. But if you want to keep on using a mouse and keyboard, that is totally fine. In that case, you can simply comment out the process function, and then you are good to go. You can also keep on using both. Just keep in mind, sometimes the camera is going to be a bit choppy because you might have a very minor mouse movement. Anyway, with that, we have the camera controller. So this was another major part of the game. With that, we can close this part and focus on the player jumping. And in the most basic sense, this one isn't going to be too difficult. For all of that, we have to work with velocity, specifically velocity.y. The value that currently is always 0. To get a jump, or rather to get up in a jump, we simply have to set some kind of positive y value. And once again, as a reminder, in a 3D space, going up is a positive y. After that, to come down again, we want to slowly decrease this value, which is effectively gravity. Now, this system you can make really fancy with a bit of math. But just to get started, I want to keep it simple, which means I first of all want to get if input is action just pressed, and then we have a jump action, which on the keyboard is going to be space and on the gamepad is the A button. If that is the case, I want to set velocity.y to, let's say, 40. An arbitrary value, we're going to change this in just a second. For now, I just want to test if this is working. If I now press space, the player is, well, kind of jumping. The issue at the moment is, when we are pressing the jump button, we are setting velocity to 40. But the next time physics process is running, we are setting velocity.y back to 0 because of this line. As a consequence, the player floats. However, if we comment out this velocity line, run all of this again, I can jump, and now the player jumps forever. Not really a jump because we don't have gravity. To get that, basically what we have to do is velocity.y minus equal some very small value. Let's say 0.5, just to test things. Now I can jump, and eventually we should come down again. So this would be the most basic kind of jump. Doesn't work great yet, but you get the idea. This is what you need for the basics. Ideally for the player, I would like to define how fast we are jumping and how fast we are falling. And for most games, the fall speed is a bit faster than the jump speed. It just feels better. That's the entire reason for it. Now, for all of that, one YouTuber has made a really good video to go over the math, and I am basically going to copy his code. Check out the original video and the YouTube channel. It's really good, can recommend. But the code that I want to add, let me do it all the way at the top. There I want to have a jump section. We want to have all of this. Let me expand it. There you can see we are setting a jump height, a jump time to peak, and a jump time to descent, which are all some floating point values. And from that, once the scene is ready, we are getting a jump velocity, a jump gravity, and a fall gravity. And once again, I get all of this from this YouTube video. Now, if you want to copy all of the formulas, they are not too long or complicated. I suppose what I can do, inside of the file system, I can create a new folder with pre-made stuff. and then copy the jump template in there. That way, when you're opening all of this, you can simply copy these lines and you are good to go. That should be all right. So next up, we can actually use all of this. If the jump action is pressed, I still want to update velocity.y. But now I want to set this value to negative jump velocity. And then for the gravity down here, I want to create a new variable called gravity, for which we want to either get the jump gravity if velocity.y is greater than 0.0, meaning we are jumping. If that is not the case, else I want to get the fall gravity. And then this gravity we want to subtract from velocity.y, and we also want to multiply it with delta time, which we can't do at the moment because earlier I have added an underscore, which I now want to remove. And with that, we have a pretty fancy jump mechanic. So I can run the game, and now we're getting a really nice jump that should be pretty consistent and really precise. So for example, you could fine tune these values and for example, make the player fall much faster, although that's going to look a bit weird. There you can see a bit too much, so 0.3 is totally fine. And once again, this video has been incredibly useful. Definitely check it out. So with that, we have our basic jump mechanic. But now that we have commented out this velocity, the player cannot move around anymore. However, if we just uncomment it, then the jump is going to be broken. So this doesn't really work. That is totally fine though. I did want to update all of this anyway, because we can refine this quite a bit. Although, first of all, I want to keep this physics process function more organized, which means this jumping should be inside of a separate function. Let's do that first. I want to create func jump logic. No need for custom parameters. And if you want to be a bit more consistent, this function is going to return nothing. So arrow void. And then we can copy all of this stuff in there and then call the jump logic. Although inside of this function, we need delta time. So we have to pass delta through there and then capture it via a parameter. That keeps the entire thing much more organized. Also, while we're here, I realized there's another problem. If I run the game again and I need to comment out this velocity line, I can jump once and that works totally fine. But if I'm in the air and I jump again, we are getting multiple jumps that shouldn't be possible. To avoid that, we want to add another if statement. So I want to indent all of this, and then if is on floor, and only then the player should be able to jump. Let's try this one again, and now I can only jump if I am on the floor. So that is working pretty well. If you want to have fancier jump logic, for example, if you want to have a coyote jump or a double jump, check out another tutorial of mine where I made a Metroidvania game. This one goes over a lot of movement mechanics, which would be quite nice to get better movement. But for this tutorial, we don't really need it. So next up, I want to create another function. Let's call this one the move logic. Oh, and once again, just to be consistent, this function is not going to return anything. And in there, first of all, we want to get the movement input, all of this stuff we have done here. We can simply cut it out and then paste it in there. Also make sure to call move logic. That way we're actually calling the code. Once we have that, after the movement logic, I want to create a new variable. Let's call it velocity2d. This velocity2d is simply going to be a vector2 with our current velocity on the floor. So velocity.x and velocity.z. Remember, we do not want to work with velocity.y at all for the movement because all of that is handled by the jump. After we have that, I want to check if we have any kind of movement input. So just to be super precise, I want to check if this movement input is different from a vector2.0. And if that is the case, I want to get my current velocity 2D and then add the movement input multiplied with the base speed multiplied with delta time. And for that, once again, we are going to need delta. This we can get via a parameter, and then we have to pass delta in there. So Godot should stop complaining, and we're good to go. Perfect. So with that, our speed is going to slowly increase, but this at the moment is never going to stop. So our player needs some kind of limit, which we can get with velocity 2D. Once again, is going to be velocity 2D, and then we can use limit underscore length, which is a method that every vector in Godot has. The maximum length that I want to go for is the base speed. And then finally, I want to get velocity.x and set it to velocity 2d.x. Then we can duplicate all of this and update velocity.z and set it to velocity 2d.y. Once again, for this line, keep in mind that we are assigning a 2D vector to a 3D vector. Meaning for a 2D vector, we only have x and y, but for a 3D vector, we have x, y, and z. But for this one, we want to ignore y. That, once again, is only for the jump mechanic to influence. Let's try all of this. And now if I move in one direction, we are slowly accelerating. Although the issue now is that once I stop moving, then the player keeps on sliding forever. That is because we don't have an else statement, which we can fix fairly easily. Else, if we do not have movement input, we slowly want to set the velocity x and z back to 0. Or in other words, I want to get velocity 2d and then assign a new value with velocity 2d and move toward. This is moving a vector 2 from a starting position to an end position over time. The end position we want to go to is vector 2.0. For the duration, I simply went with base speed multiplied with 4.0 multiplied with delta. And finally, once again, I want to get velocity.x and set it to velocity 2d.x. And then for velocity.z, we want to get velocity 2d.y. With that, I should be able to run around, and the player stops, and we are slowly accelerating and decelerating, and we can also jump, and that is a pretty nice movement mechanic. We can also use the camera and roll around. So with that, we have a basic moving player. That is working really well. Now, just as a reminder, let's go over these lines in a bit more detail. We start, number 1, by getting the current velocity 2D. This is simply the current movement speed of the player. Next up, number 2, we are checking if there's any kind of movement input, the thing we have captured up here. If that is the case, we are getting our current velocity of the player, and we are changing it depending on what kind of input we have. That way, we are slowly accelerating from our current speed. Next up on this line, we are setting a maximum speed, and if that wasn't the case, the player would simply keep on accelerating forever, which would look really weird. Once we have that, we are updating velocity.x and velocity.z to get a new movement speed, which we're then using again on the next line, and so on. If, however, we do not get any kind of movement input, then we are going to else, number 3, and in there, we're getting our current velocity, and we're moving that value to 0 by a certain kind of speed. And then, once again, we are overwriting the current velocity of the player, and that way we are decelerating. And that is basically it. Now, there's one more minor thing that I want to do. At the moment, we only have a base speed. But besides that, I also want to have a run speed. This could be another export variable, so export var run underscore speed, which should be some kind of floating point value. I went with 6.0. And also, if you look at project settings, input map, somewhere in there, I believe we have run. Yeah, on the keyboard, it's control. On the joypad, it's axis 4, so the left trigger. That, by the way, is the shoulder button. Now, if this button is pressed, I want to get a different kind of speed. So I want to change this value. And that we only want to do if the run button is pressed. Implementing all of that is going to be your exercise. If the run button is pressed, move the player faster. Pause the video now and see how far you get. I want to keep on working inside of move logic. In there, I want to create a new variable. Let's call it is_running. This value is going to be a Boolean. So let's be clear here. This should be a Boolean. And all I really want to get is input, is action, and really important, is action pressed, not is action just pressed. We want to continuously monitor this button. And in there somewhere we should have run. Just to test if this is working, let me print is running and run the game. If I hold control, we're getting true. If I don't hold control, we're getting false. The same works with a gamepad. If I hold the left shoulder trigger, we are getting true. If I don't, we're getting false. Now we have to use that value, and that happens inside of movement input. Let's do it before we're updating the actual speed. I want to create a new variable called speed. And this is going to be the run speed if is running is true, and if it is not the case, else we want to get the base speed. Once we have that, we can simply use the speed instead of this base speed. Oh, actually, I forgot. For limit length, this should also be the speed. That way, if I run the game, I can move around like normal. That looks good. But now if I hold the left trigger, we are moving a bit faster. So that is looking pretty good. A bit hard to see because we don't have too many graphics. But if I change the run speed to something much larger, let's say 20, I can move around and the player is moving significantly faster. And we are still getting acceleration and deceleration. Although I want the run speed to be 6. Cool. And with that, we have two functions for the player movement and for the player jumping mechanic. We don't need this comment anymore, and things look fairly clean. Perfect. With that, we have covered another really important part of 3D game development. Now we can move a player around. Unfortunately, this still doesn't look amazing because, well, we are simply moving a random object around. So in the next section, I want to work on the actual player graphics. So at this point, we can get user input, and we can use that input to move an object around the screen inside of our game, which is a good start, but the entire thing still looks really basic. A massive step towards making all of this look presentable is to add characters and animations, which is what we are going to do in this section. By the end of this part, we are going to have a basic player that can run, idle, attack, jump, cast a spell, and be hit, and defend, and I think that's all of the animations we are going to manage. So we are going to focus on importing objects with animations and then managing them inside of our game, which, if you understand the basics of how to do it, is actually really straightforward. But anyway, we do have to cover a few basic things. Most importantly, we have to talk about 3D skeleton animations. That is what we are going to work with the most. Now, in 2D, if you want to have any kind of animation, you basically play a sequence of images and then call it a day. This, unfortunately, does not work in 3D. Instead, what you have to do for any more complex animation is to animate a skeleton. On top of that, what can be really frustrating is that you couldn't just play one animation and then another animation. You need to have a transition between the two. Otherwise, the entire thing is going to look really bad. I am actually going to demonstrate that very soon. Now, fortunately, Godot has one node, the animation tree, to manage all of this really easily. And I think, especially for beginners, this node can be super confusing. But, well, we're going to create a whole bunch of characters and use the animation tree a lot. The other thing that we have to talk about is creating 3D animations. And in there, we have already one pretty substantial problem. And that is that you cannot create 3D skeleton animations in Godot. Or at the very least, you cannot do it in any kind of efficient way. Instead, the workflow is supposed to be that you are creating them in Blender or a similar kind of app and then import all of these animations. In future versions of Godot, this might change, but at the moment, if you want to create new animations, you have to do it in Blender. Luckily, Blender is free, but it's still a bit annoying. Here we are back inside of Godot, and to get started with graphics, let's first look at what we even have. Inside of the graphics folder, there are a whole bunch of subfolders, and most of them contain some kind of 3D object. A really simple one inside of weapons would be bone gltf.glb. If you double click on that one, you can see a bone. And specifically, when you're looking on the left side, there you can see scene. And effectively what Godot is doing is it creates a new scene for every 3D object. Inside of the scene, you have a mesh instance and then the actual mesh. On top of that, when you go to the meshes tab, there you can see the mesh and the assigned material. And if you look at materials, there you have the material by itself. That's kind of all you need for the basics. And you might have already noticed, if you simply open a new scene via Ctrl, Shift, and O, then you can see all of the scenes inside of Godot that we currently have. And basically, for all of the 3D imports, Godot already created a scene. There's, for example, Godot. And if I find the bone I just talked about, I guess I can simply look for bone gltf, glb. If I open this one, Godot is giving us the option to create a new inherited scene, open anyway, or cancel. If you open anyway, then you're getting the scene by itself. So here we have a node 3D, and we have a mesh instance 3D, which has a mesh, and this mesh has a, if I expand this mesh has a surface 0 with a material. And this material we could even change. So for example, inside of albedo, you could make whatever change you like, although not something that I want to do. However, there we have a big warning that changes may be lost. If you click on that, you get this scene was imported, so changes to it won't be kept. Now there's a whole bunch of documentation that you could be reading, but effectively, when you're importing this bone, you're getting it directly from the file. And because of that, we cannot really overwrite what we are doing in there. So generally, you should avoid doing this kind of thing. Instead, if I try to open the bone scene again, I want to go with new inherited. And then we are getting a node 3D and a mesh instance that has yellow text. So we know it's inherited. But now Godot doesn't complain anymore that changes won't be saved. So we can do pretty much whatever we want to it. For example, what we could be doing is a surface material override, where we are giving it a new standard material, and then we could change the color once again to, I don't know, let's go with a bluish color. And this now will be saved, because now we have created a new scene that starts with the imported object, but then adds stuff towards it. So I hope that makes sense. Essentially, whenever you're working with imported objects, you're working with inheritance, where you don't manipulate the object itself. Instead, you're creating a child of it, and that is what you change. Although this I don't actually want to do for the bone, so let me not save it and close the thing. Then we can look at more interesting parts. Besides the weapons, we also have rupees and objects. Those are very simple. Then we have the environment and the characters. I guess the environment is kind of interesting because in there we have the castle and the overworld environment. This overworld environment is an entire Blender file, which you can tell because the file ending is .blend. If you double click on this one, Godot is going to load for a second, and then you can see a really large map. This is the thing we are going to import later on. But if you look on the left side, you can see lots of familiar things. So we are creating still a new scene. And inside of this scene, we have a couple of mesh instances with a few meshes. This would be one, this would be another one, and so on. However, we do have a few more things. One is a sun, or in other words, inside of Blender, you can define a sun, and Godot is happy to import it. Besides that, for the floor, Godot is automatically creating a static body 3D. That is something you can set inside of Blender for the import, which can be super handy. So via the system, when we are getting the floor, Godot is automatically creating a mesh for the collisions. And this is that collision shape. But other than that, we have meshes with a few more textures and their materials, but they don't matter too much. So this we can close. And next up, we can look at what we want to work on the most in this section, the characters. There are 4 characters: Godot, Naganford, Skeleton Mage, and Skeleton Warrior. You could start with any of them, but since we want to start with Godot, let's open that one. Inside of that folder, we have Godot itself, and then we have 2 textures. One for the face, and one for basically the rest of the body. And if you open godot.glb, you can see the actual model. And that looks pretty nice. This model is also a lot more complex. There are 2 parts, or 2 major parts, that we are importing in this new scene. The first one is the rig, and this rig is a skeleton 3D, which otherwise contains a whole bunch of meshes. For example, we have the arms, the body, the head, and the 2 legs. And since this is a skeleton, all of those will be connected so we can animate them. And these animations have been created in Blender. Inside of Godot, we are importing them via an animation player. Or this is where we are going to store all of them. For example, in there, we have a melee attack chop, and if I play that, we're getting 1 attack. And well, this is basically what we are going to manage for the rest of the game. For example, there we have an idle animation that we want to play if the player is not doing anything. If you have an animation selected, you can look on the right side and then select a couple of options. The first one is the loop mode. So by default, this animation will only be played once. But you can set it to linear, then it plays forever. So if I play it now, Godot is going to idle forever. You can also get ping pong, then it's going to play backwards and forwards. Now let me stop the animation. Most of the time, you want to stick either with none or with linear, but it really depends on your project. Besides the loop mode, you also get save to file and slices. Slices simply means that you can slice animation apart and get only certain frames. Not something I'm going to do at all in this tutorial, but it's fairly easily done. Finally, we have save to file. And if you enable that, you can save this animation in a separate file inside of your project. Now, why would you want to do that? And well, remember, we are importing all of these animations from a file, meaning we cannot change them. But sometimes you do want to add things to an animation. For example, in the middle of an attack animation, you might want to call a method. And for that, we would have to add a custom track to the animation. And for that to work, we have to enable save to file and then save the animation in a custom file in Godot. And make sure you activate keep custom track. That way you can add stuff to animations. Although for now, this is not what I want to do. So let's keep it like this. And then we can close all of this. And instead, I want to right click on godot.glb and then create a new inherited scene. With that, we are getting Godot. It's very blue tinted because of the light. Don't worry too much about it. And for this inherited scene, I want to change the name to, let's call it Godot Skin. That way we are indicating that this is only a character model. This I now want to save inside of Scenes, Entities, and Player. In there, we have Godot Skin. Once we have that, back inside of the player, I want to get rid of the mesh instance and then replace it with Godot Skin. And make sure you're getting the tscn file, not the glb file. Can be a bit confusing sometimes. This is what I want to open, and then we have the Godot model. Let's run the game now, and we can see the Godot model. Obviously, we don't have animations, so this isn't great yet, but definitely a starting point. Now, to actually animate it, you want to look inside of Godot Skin, and then look at the animation player. In there, you can play all of the animations we have just seen in the import menu. Let's say for now, by default, I want to play the idle animation. At the moment, I can only play it once, but that's definitely a start. If I run the game again, at the very least, Godot doesn't have the T-pose anymore, so it looks a bit better, but still not ideal. So just to get started, inside of the animation, I want to set the idle animation to autoplay. And then, when we are importing Godot, I want to find the idle animation, this one here, and then set the loop mode to linear. That way, when we are playing the animation, it keeps on playing more than once. After you have done that, you need to make sure that you are re-importing the model. Only then do we get the actual update. And now, when we are playing the idle animation, it is going to play forever. And since it's auto-playing on load, it should also work inside of the scene. And there we go. Godot is being animated. It's a bit hard to see because the animation is quite subtle, but you get the idea. If Godot is moving, I want to play a run animation. For that, we have to look at the import again and then find a run animation in here somewhere. There are actually multiple. We have run A, run B, and run C. Choose whatever you like. I'm going to go with running B simply because I think this one looks best. But this is really subjective. Since this one should be playing continuously, it should also be linear. Once we have that, click on re-import. We can look at the animation player and look at running B, and I can play it. And we are getting a run animation. This we want to play as soon as Godot is moving. The way we would be doing that is inside of the code. We would be working inside of move logic, and we already know when the player is moving and when the player is idling. That means we can get Godot skin. Let me select the player scene. So we are getting the autocomplete, and I want to get Godot skin and the animation player. If Godot is not moving, so we are in the else statement, on this animation player, we want to update the current animation, which for idle is simply called idle. And then, if the player is moving, so in this if statement, we want to do the same thing, except the animation we want to play is called running underscore capital B. And make sure you get the capitalization right. Let's try the entire thing now. And you can see Godot by default is playing the idle animation. That's a good start. And if I start moving, then we're getting the run animation. And if I stop moving, we are going back to idling. So that part is definitely working. Although you can tell this still isn't great because the transition between these two animations doesn't exist, which really is not looking good. Besides that, Godot is not facing the right direction when we are moving. So Godot right now should be facing towards this edge, which she doesn't, which is another thing we have to work on. And let's start with that. Let's do it at the bottom when the player is moving. Only then do we want to rotate the character to point in the direction that we are moving. Or in other words, let's create a new variable. I want to have a target underscore angle. This is basically going to be the movement input dot angle. Or in other words, we are getting the current angle of our movement input, and this is the way we want to rotate the Godot model. I want to get Godot skin and then change rotation.y. The value is going to be the target angle. Now this might not work yet, but if I start moving, Godot is rotating, but in the wrong way. So not ideal yet. And that can be for a couple of reasons. First of all, when you're looking at Godot or the Godot skin model, you can see that by default, we are pointing down the Z direction. And we have to account for the starting direction. So Godot could have also pointed in this direction or in this direction and so on. On top of that, inside of the camera controller, we are deciding if we have a positive or a negative rotation. which does influence the movement input because we are rotating this vector by the camera rotation. Now, in practice, all that this really means is when you're getting the target angle, you want to play around with the numbers to get the right kind of rotation, which basically comes down to experimentation. For example, in my case, if I make this value negative, it's already going to be quite a bit better. Now Godot is almost pointing the right way, except with a 90-degree offset. That we can fix by simply adding pi divided by 2. Remember, for this rotation, we are working in radians, and the full radian rotation is 2 pi. And pi divided by 2 would be a quarter of that. That way, we are rotating Godot a quarter more. Now she's pointing in the right direction. This still doesn't look ideal because we can rotate immediately to the right point. So we want to do all of this more gradually. Instead of assigning the target angle right away, I want to use rotate toward, for which we are going to need a starting position, a target position, and a duration. Now for that, we want to start with the Godot current rotation. After that, we want to get the target angle and then set some kind of duration. 6 multiplied with delta seems like a good value, but just play around with this. And now, if we're trying all of this again, I can move in a direction, and now Godot is moving much more naturally. We might have to update the movement just a bit because this is quite gooey, but it's definitely coming together. So now we can actually move around, and we can also use the camera. And they can see we have a semi-functioning model. Does need some adjustments, but I think it's a good start. The next major thing we have to work on is the transition between the animations. So if we are running and going to idle, we are snapping between these two animations. For that, I want to work inside of Godot's skin and then add an animation tree. Now, in case this is the first time you see an animation tree, the main point of this node is to manage an animation player. In fact, if you look on the right side, the main options for this node are 3 things. We have a tree root, advanced expression, and an animation player. Which basically means for this node to work properly, we have to assign an existing animation player. And then via this node, we're going to manage all of these animations. In our case, we only have a single animation player. And this you want to drag in there. Once you have that, you can define a tree root. And in this drop-down menu, you have quite a few options. The one that I want to get started with is a node state machine. So click on that, and then nothing is going to happen. But if you now look at the bottom, we have an animation tree and then a new field. So what does this mean? Basically, this is going to be the starting point. And after that, we can add a couple of animations that we want to transition to. In our case, there are 2 animations that we want to transition between. We have idle, and then I want to right-click again and add the running bee animation. There's walking bee, but I want to go with running bee. And by the way, make sure you have this mouse symbol selected. If you have something else selected, you can't really right-click. This icon should be selected at the moment. So with that, we have 2 states that we could be transitioning between. You can also rename them if that's more convenient to you. I think idle works just fine, but for running bee, we can simply call this one running. Makes typing a bit easier, you don't have to do it. Now that we have the different states, we have to manage how to transition between them. And this you do via this connect nodes symbol. If you have this one selected, you can set the transition, and I want to keep this at immediate for now. And then if you go from start to idle, we are automatically going to this animation. And if you went further to running, then the animation would go immediately to running, which isn't exactly what we want to do. Also, if you added another transition from running to idle, we would get some really weird behavior. So, not the greatest idea. Select this arrow again, and then delete one of the two. And especially for this kind of thing, make sure that you have the right tool selected. It can be a bit confusing. At the moment, we're going from the start node to the idle node, and that's basically all that's happening. Since we can only go from running to idle, we basically never get to the running state. However, if we ever manage to get there, we would go immediately to the idle state. I suppose this also isn't something that I want to do. Instead, I want to go back to this state. And now, when you click with this cursor selected on the transition, you can specify a whole bunch of things. Most importantly, you have a switch. There you can set immediate, sync, or add end. Not something we want to do right now. And then we have advanced. At the moment, this is set to auto, but this you mostly want to set to enabled. That way this transition can be controlled via code, which is actually what we want to do. For that, we have to write a bit of code. And since we want to add quite a bit of logic to Godot's skin, I want to give it a script, which you can do fairly easily. I want to add another script, Godot's skin, inside of the player folder. That's totally fine, create, and we do not need the default functions. Inside of this animation tree, we currently have a state machine, and this we want to influence. If you have the animation tree selected, you can see some parameters. So at the moment, we have playback, and in there, we have an animation node state machine playback. This I want to store in a separate variable, just to make it a bit more accessible. So already, var, let's call it the move state machine. This we can get via the animation tree and then the get method. And to get this tree, you basically want to right click on playback and then get the property path and paste it in there. Make sure it is a string, so add quotation marks, and then you should be good to go. And let me expand all of this so we can see what's going on. Just to make sure that this is working, let's add func ready and then print the move state machine. I can now run the entire game and we get an animation node state machine. Quite a long word, so instead of the output, this is what we want to work with. And effectively, if the player is idling, we want to go to this state, and if the player is running, we want to go to this state. And we don't need the ready function. To manage these different states, I want to create another function that I call setMoveState. As a parameter, I want to have a state name, which needs to be a string. And this function is not going to return anything, so arrow void. And inside of this function, we only really want to do a single thing. We want to get the move state machine and then revel to the state that we are getting from the parameters, so the state name. For example, inside of the animation tree, we can travel to idle and to running. And at the moment, we can only go from idle to running because of this single arrow, which means we want to add another arrow that we can go from running to idle and from idle back to running. And make sure that both of these have the advanced condition enabled and not auto. That way, you only go from one state to the other if you are specifically asking for it in code. The one automatic one that you do want to have is from start to idle. That way, we're getting to our first animation. So with that, we have two animations that we can go between. And to manage all of that, I want to go back to player.gd. And in there, at the moment, we are simply targeting the animation player and changing the current animation, which isn't something we want to do anymore. Instead, I want to get Godot skin and then call, I believe I call this one the setMoveState method, which is going to need one argument, the state that we want to go to. If Godot is not moving, we want to go to the idle state. And if Godot is moving, then we want to play the running animation. With that, I can run the entire thing again. And now we still get the animations, except the entire thing is a lot cleaner. Inside of the player script, we have a fairly simple logic, and the actual work is happening inside of Godot's skin. We are simply calling move state machine, and then we are traveling to a state, which is what we're getting down here. However, if I run the game again, you can see that we still snapping between two different animations, which is what we actually wanted to avoid. And now we get to the actually interesting part of animation trees, because if I go outside of the full screen mode, if you click on either of these two arrows with the cursor selected, once again, really important, you get an X fade time. And this I want to set to 0.2 for both of these arrows, from idle to running and from running to idle. These should be 0.2. And now I can run this again. And if I now start running, we are getting a smooth transition between these animations, which is looking significantly better. So this is making a massive change. And all of this, I want you guys to practice a lot, meaning we are going to do an exercise. I want you to make Godot play the jump animation when the player is jumping, or to be a bit more specific, when the player is in the air. This animation should play forever, and if Godot is on the floor, then we should go back to either the idle or the run animation. Pause the video now and try to figure this one out on your own. Inside of Godot.glb, we have a whole bunch of jumping animations. I just have to find them. There we have jump full long, jump full short, jump idle, jump land, and jump start. I want to work with jump idle, which is a very basic jumping and falling animation. This we want to play forever. So linear and then re-import. With that, we have the jumping animation that will play forever. Next up then, we have to work inside of the animation tree and add a new animation, which is going to be jump idle. And I want to rename this one to jump right away. Now we can get to this state either from idle or from running. And the other way around, we can go from jumping to running and from jumping to idling. And there you can see this is already not looking great. So make sure for the advanced conditions on the arrows, advanced should always only be enabled. And this should apply to all of them. So with that, we can travel between these three different states via the move state machine. That means, next up, inside of the player, we already have the logic for jumping and falling. This happens inside of these few lines. All we have to do in here is check if the player is not on the floor, which we can do via an else statement, and then once again get Godot and use set move state, I believe I called it. Set move state along with the state. So let me copy it. And the state we want to go to is jump or jumping, one of the two, jump. Also, this should be Godot skin. And I think calling Godot skin multiple times is a bit annoying. So all the way at the top, I want to, on ready, create a variable of the skin that we are working with. And this is simply going to be, if we are inside of the player scene, Godot skin. Makes my life a lot easier. That way, I can simply replace Godot skin with skin all the time, and we don't have to write that much. Not a necessary step, but I think it makes the entire thing just a bit cleaner. If we now run the game again, I can jump, and we're getting to the jump animation. And it's also playing forever. So for example, if I jumped off the cliff, then we would get the fall or jump animation forever. That's a good start. However, one thing I haven't done yet inside of the animation tree is to set a transition time, or an X-fade time to be a bit more specific. This should always be 0.2. I think that's generally a good value. But once again, if another number looks better in your case, that's also totally fine. These numbers are really subjective. Anyway, let's try again. And now we can transition to a jump animation, and it looks really nice. And if we're on the floor, Godot is either idling or running. This is working quite nicely. Perfect. So with that, we can transition between different animations, but that's still very basic. Next up, I want to play an attack animation, or to be a bit more visual, I want to play one-hand melee attack chop, which looks like this. And this animation should only play once, so loop mode none is totally fine. We can just close it, we don't have to re-import things, since we didn't make a change. What we do have to figure out, however, is how to play this animation only once. So effectively, when the player attacks, I want to play the attack animation once, not forever. For that, you could look at the animation tree and add the attack animation here, for example. So I want to get one-hand melee attack chop, and then connect it to all of these states, which would be possible. And what we could also do is if I connect it to, let's say, running, that we want to switch not immediately, but at the end of the animation. That way, you could only play it once. But still not ideal, because the more states you're adding to all of this, the more complex it's going to become. So in this case, I would have to connect this state to running, idle, and jump, and then also go the other way, which would add a whole bunch of extra stuff, which really does not make it worth it. As a consequence, I really do not want to do that. And fortunately, we don't have to. Instead, with the animation tree selected, I want to remove the tree root. That means we will have to recreate the state machine in just a bit, but that we can work on later. Instead, I want to create an animation node blend tree. This one is going to look like this. If you worked with visual shaders, this should look somewhat familiar. We effectively have a couple of nodes, and then we can add new ones by right-clicking or clicking on Add Node. And there are a whole bunch of options we could be working with. The easiest one is animation. And in there, we have an animation, we could change the name, and we can pick another animation. Let's go with running B for now, and if I connect this to the output, then Godot is running again, and this animation is also playing forever, because during the import, we have set the loop mode to linear. If we went with another animation, let's say one-hand melee attack chop, we're playing it once, and that's it. The reason why this blend tree is super useful is because you can connect it with a state machine. Meaning, if you right-click, you can add a state machine, and then click on Open Editor, and now we are back in a state machine. But at the top, if you click on root, we can go back. And that way, if you connect this state machine to the output, and then we should probably rename it to move state machine, and then open the editor, and now we have to recreate the animation we have just worked with, which could be another nice exercise to make sure you remember. But in case you don't, I want to add 3 animations. We have the idle animation, we have running B, and finally, we have jump idle, which was a bit further up. Jump idle, there we go. And those I have renamed to make it a bit easier. We have jump idle, and we have running. From the starting node, we go automatically to idle. And then from idle, we can go to the other states. And from jump, we can go to running. From running, we can go to jump. From jump, we can go to idle. And from running, we can go to idle. So we can go from one state to any other state and backwards. For the advanced condition, we always want to only set this to enabled, but not automatic. which once again is a bit annoying, but it's not too bad. Also, I forgot, you want to set an X fade time of 0.2 for all of them, so we actually get a transition. And sorry you had to redo all of this, but I think it's good practice so you remember what you have to do. And by the way, for the transition, you can also set a curve, but that usually is a bit overkill. We have a basic state machine once again. So now, if we go to root, whatever animation we are ending up with inside of the state machine, we are going to use for this output node. Although for all of this to work, back inside of the code, the path for this state machine has changed. Since the state machine now is just one parameter of the animation tree, we have to go to parameters, move state machine, and then we have playback. So we have parameters, and in there we have the move state machine, the name that we have specified inside of this node. With that, we should go back to what we had earlier. So Godot can jump, she can idle, and she can run, and we are getting transitions between these animations. That's a really good start. Cool. So with that, we have the same functionality as before. But what we are now able to do inside of the animation tree, we can add another node. And the node I want to add is called one-shot. What one-shot is doing is it takes one continuous animation. In our case, that is going to be the walk animation. And as an output, we are still playing an animation. But besides that, we can connect another animation. So in my case, I want to create a new animation that I am going to call the attack animation. Although the name here doesn't really matter. If I now choose an animation, we can go with one hand melee attack chop and connect it to the shot. And for the name, let's call this one the attack one shot. That way we can tell Godot to play this animation once and then go back to this continuous animation. And to make that work, if you have the node selected inside of the inspector, you are getting a bunch of options, but those don't really matter for our purposes, but they will become important later on. Now, instead, for the attack, I want to create another function inside of the Godot skin scene. Let's call it function attack without any parameters for now. And we basically want to get the animation tree and then set this one shot, which we can get if you have the animation tree selected under parameters. This is where you find all of these nodes. We have the move state machine. This one we don't have to worry about, but now we also have attack one shot. And in there, you can request a couple of different things. If you set this thing to fire, the animation is going to play once because of this node, and then it goes back to the state machine. And to target this entire property, you want to go to, and then Godot is giving you the right option. You want to go to parameters, attack one shot, and request. That way, we're getting to this field. You can also just right-click and copy property path, same thing. This wants to have one argument, which can be nothing, fire, abort, and fade out. Most of the time, and for this tutorial, we are only ever going to use fire. But to get to all of them, you need to get the class animation node one shot. And if you now add a dot, you can get things like on, shot, request, abort, fade out, fire, and none. We want to go with fire, and that's going to play the animation once. Alternatively, what you see online a lot, and let me maximize this, what you see online a lot is people using simply through in there, then you would get the same result, although it's less expressive. I want to go with one shot request fire. That way we are firing this one shot once. Now we have to figure out when to call this attack function. That happens inside of the player. And let me expand all of this so we can see what's going on. I can minimize jump logic and move logic. And instead, I want to create a third function. I call this one the ability logic. No need for custom parameters, but I do want to add the arrow and void to keep things a bit more consistent. And for now, let me add pass in here, because I think inside of Godot skin for the attack function, we should add this one as well. Not necessary, but it just annoyed me. Anyway, now inside of this ability logic, we want to get the skin of this model and then call the attack method, the one that we have just created. Although to trigger this one, we have to get some kind of user input, which I'm going to do via if input is action just pressed, and I'm looking for the ability key. If that is the case, I want to call the attack animation. And if you look at project settings, input map, somewhere in there we have ability quite far down. It's either the left mouse button or joypad axis 5, which is the right trigger, so the shoulder button. Before we can start, we have to make sure that we are calling this function, which happens inside of physics process before move and slide. I want to call ability logic. And then, if I press the bottom right shoulder button, we are getting one attack animation. I can also press the left mouse button, and same thing. This works pretty well. Although if I click a couple of times, you can see that we don't have a perfect transition between these animations. That is happening because inside of the animation tree, inside of one shot, we have not set a fade in time and a fade out time. Once again, I'm going to set this to 0.2, which is my default number. And with that, we should be getting a bit of a smoother animation. It's a bit hard to see, but it's definitely there. Now we still have to refine things quite a bit, but this is definitely getting better. Now, at the moment, this attack animation doesn't really feel satisfying, simply because Godot doesn't have any kind of weapons. So let's fix that. To make that work, we have to look at the Godot skin, or more specifically, the skeleton. So the scene we have imported, we have a Godot skin. In there we have a node 3D called rig, and then we have a skeleton 3D. And then if you look on the right side, we have all of the bones. And if you look a bit closer at the model, you can see these are animated. And this is what I talked about earlier. Creating these bones from scratch isn't really possible in Godot at the moment. Or in other words, you could create a skeleton 3D, but then you couldn't add any kind of bone 3D to it. You do have bone attachments or a physical bone or some kind of bone simulator, but you do not have a simple bone 3D that you could be adding. So effectively, we can only work with a skeleton and manipulate it, but we cannot create a new one. For that, you have to work inside of Blender. That being said, what you could be doing, if you, for example, have the head bone, so the head of Godot right now, for example, you could change the position, and then Godot has a floating head. Now, in my case, I don't really want to touch the skeleton itself. Instead, I want to take one part of it and then attach the sword and the shield to it. Specifically, I want to get arm left and arm right. Although, if I simply select them, you can tell you couldn't simply add a child to it. For example, if I looked at the weapons, at the moment, I want to work with sword 1, this one here. It doesn't have a texture at the moment, that we can fix in just a second. But this sword, I want to attach to the right hand of Godot. And effectively that means we want to add it as a child to the right arm. But if you're doing it like that, it, well, doesn't work at all. So that's no good. Instead, the way you're supposed to attach things to these bones is via another node. With the skeleton 3D selected, we want to attach another child node. And that node is called a bone attachment 3D. I think the name is self-explanatory. We want to attach something to a bone and it's 3D. Make sense? So let's rename it right away. This should be the right hand slot. At the moment, this doesn't do anything. For it to work, you have to look at the inspector, and there we have the bone name that we want to attach something to. And in there, we have a hand slot right. This is what we want to work with. And there you can see right away, we have a nice position that we could be working with. Now, Godot is complaining right now that this node is not bound to any bones. That I think right now is an issue because we have assigned a bone to it. If you simply go outside of the scene and come back, this one disappears. I think it's just a bug. Anyway, now that we have that, we can attach a sword to this right-hand slot as a child, and then this is looking significantly better. All of the animations are also still going to work, which means I can run the game, I can attack, and we are getting something that looks much better. So this feels significantly nicer. Perfect. And while we are here, at the moment, the sword for some reason doesn't have the texture applied to it. And we want to apply this barbarian texture.png file. For that, we can simply right-click on the sword and then select Editable Children. Then we can target the mesh right away. And in there, you want to go to Surface Material Override, and there we can override the material. At the moment, it doesn't have any. But we can drag the barbarian texture in there, and then we have a texture. That's all that we needed. And to practice all of this as an exercise, I want you guys to give Godot a shield. You can find it in the same folder where you have found the sword. So pause the video now and implement this one. Once again, I want to add another child to the skeleton 3D, and I want to attach a bone attachment 3D, which I want to rename to left hand slot. After that, we want to go to bone name and then find the left hand slot in here somewhere. You might have to scroll around a bit, there are quite a few bones, but there we have hand slot left. If you select this one, you can see there we have the left hand of Godot. And to that, we want to attach the shield.gltf.gld, so simply drag it in there, and then we are almost good to go. The position of this shield isn't ideal right now. And if you simply drag this arrow, you can fix that fairly easily. Now, if the movement right now is a bit annoying, you can simply go to the animation tree and then deactivate active. That way, Godot is not animated anymore. And then we can update the position just a bit better. Something like this. Play around and see what looks good. Working in 3D always is a bit finicky, so do take some time for these kind of things. Anyway, once we have that, I want to go back to the animation tree, and right now I cannot activate it anymore. And you can see we have lots of keys on the right. That means at the moment Godot thinks we want to animate all of this. If you simply click outside of it and back into it, now this should be working, active, and now Godot has a shield. Let's try this inside of the game, and that is looking pretty good. Cool. So with that, we can attach things to the skeleton. And also we can animate all of this. That is working really well. That means we can work a bit more inside of the animation tree. And there are two really important things that I want to cover. One is that inside of the one-shot for the attack, we don't always want to play the entirety of the animation. And to illustrate what I mean, let's run the entire thing again. So I can walk around, but if I attack, then Godot stops moving her legs, which makes the attack feel a bit weird. So ideally, I only want to play the upper body animation and leave the legs as they are. And that we can do fairly easily, because inside of the animation tree, when you have the one shot, you can edit filters and then only play the animation of certain bones. So in my case, I want to do all of these nodes for the upper body. I want to get upper arm, lower arm, wrist, hand slot, and head. But I do not want to get the upper leg, or left and right, or the knees, or any of this other stuff. That way, we are only playing part of the animation. Now, for all of this to work, really important, in the top left, you have to enable filtering. And now, if I run the game again, I can attack, and Godot keeps on running with her legs, but for the upper body, we are playing the attack animation, which is pretty neat. So that would be the first part, that for a lot of these nodes, you can edit filters, that he only play part of an animation. Besides that, I want to add another node, and that is called a blend 2. This one is somewhat similar to a one-shot, except that now we are blending between two animations depending on this number. So if this number is 0, we are playing the first animation. If this number is 1, we are playing the second animation. And if it is 0.5, then we are playing a mix of the two. In my case, I'm going to call this the shield blend, because effectively, when I look at Godot, somewhere in there, we have a defend animation. I believe it is called block. If I play this one, Godot is defending at least with our upper body. And this we want to loop, so linear, then re-import the entire thing. After we have that, I want to recreate the blend 2D node because for some reason it disappeared, but that's totally fine. And then connect the move state machine to the in node for the blend 2 node. And then connect the blend 2 output to the one shot. Also, this should be shield blend. Now, Godot is complaining that we do not have an input for the blend part. For that, I simply want to get an animation that we want to connect, which doesn't have anything in there at the moment, but for that, we have just imported block. So now we can blend between the move state and the animation for blocking. At the moment, this value is 0, so we only get the move state machine. But if I set this value to a 1, then Godot is going to transition to the shield block. Now, right now, because the animation is running, this is a bit awkward, but you get the idea. Let's keep this at 0 for now, so it doesn't look too weird. Although generally keep in mind, when you're animating and blending between two different animations, things can get a bit weird. Anyway, now we have to figure out how to target this blend node inside of code. And for that, let me minimize things so we have a bit more space. Inside of Godot skin, I want to create another function that I'm going to call defend. This value should not return anything, but we are going to need one parameter that I called forward, which is going to be a Boolean. When we have the animation tree and the player presses the defend button, then I want to go from 0 all the way to 1 via a tween. However, if the player then holds the button, I want to stay at this value, and if the player then releases the button, I want to transition back to 0. In other words, I want to create a var tween, which is simply going to be a create tween. And then I want to get a tween method, which I can create right away. Function defend underscore change. And I guess we could add an underscore at the beginning. So we know that this is only supposed to be part of this function. And for this defend change, we will need one parameter for a value, which is going to be a float. And we're not returning anything. All we really want to do in there is we want to get the animation tree and then set the blend 2D node. And to get that one, you want to get to animation tree, make sure you have it selected properly in the inspector, and then we have a shield blend, where we can set the blend amount. And to get this value, simply copy the property path, and then make sure you have plenty of space. Besides that, we want to set a value, and I want to go with the value that we are getting from the parameter. With that, for the tween, we want to call this method multiple times over a certain duration, which means I want to get defend change, make sure you're not calling it, and then we have to set a start value, a target value, and a duration. The values I went with is 1.0 minus float forward, and then for the target value, float forward. After that, we will need a duration, let's say 0.25. So what happened here? Forward is a Boolean value, which means it can either be true or false. And these two values, I want to convert to a floating point value, which means true becomes 1 and false becomes 0. And this value I want to subtract from 1.0, which means if forward is true, our starting value is going to be 0. However, if forward is false, then our starting value is going to be 1.0. Besides that, for the other value, we are simply converting a boolean to a float, so this is either going to be 0 or 1. If forward is true, we are starting from 0 and going to 1, and if forward is false, then we are starting at 1 and going to 0. Exactly what we want for the shield blending. Now we just have to call this defend method, and this needs to happen from inside of the player. Specifically, I want to work inside of ability logic. Although, first of all, I want to create another variable. Let's do it below movement input var defend, which has to be a boolean value that by default is going to be false. And this value we want to override from user input. I want to get defend, then assign it input is action rest, and in there somewhere we have defend. Oh, actually I called it block, I believe. Yeah, there we go, block. If you look once again at the project settings, input map, somewhere in there should be block. There we go. Right mouse button or joypad 10, the right shoulder button on top. Let me print what we are getting. If I now run the entire thing, we get false by default, and if I hold the top shoulder button, we're getting true. If I hold the left mouse button, this also works. And effectively now, whenever this value changes, we want to go to Godot skin and then call this defend method, for which we want to work inside of defend and then assign it a set method. Whenever we are assigning a new value to it, we can specify in a bit more detail what is supposed to happen. So in case you don't know what's happening here, fundamentally all that we want to do is assign defend and then get the new value. That way, when Godot is assigning a new value to this variable, we are running this code. Let me just print stuff is happening. And then, since we're overwriting defend here, we should be calling this line. So now we're getting stuff is happening. That means we know that these lines are working. And essentially what I want to do in here is I want to check if we are currently not defending and we have a value. Or in other words, we are currently not defending, but we want to. And if that is the case, I want to get the skin of the character and then call defend and add in true. So we know we are going forward. If on the other hand, we are currently defending and we are changing the value to not defend anymore, then we want to do skin and defend with false. And that should be it. If I now run the entire thing again, I can hold the button and we are transitioning to the shield animation, although this doesn't work perfectly yet. And I think I actually know why. And maybe you can tell as well. This shield animation should only play once, but we are playing it continuously. Because of that, Godot isn't just holding the shield, she is continuously playing the animation. So I messed this one up. Inside of block, we do not want to play this linearly. This should be none. And if we now re-import all of this, I can run this again. And now this is looking much better. Although, once again, if we are defending, then we do not have a walk animation. But if we stop doing that, it does work. So definitely progress. To fix that part, I want to get to the animation tree and then inside of Blend 2, edit the filters. And I want to work, for example, with the chest. And if you click on Fill Selected Children, you are only targeting the upper body. Makes it a bit easier than manually selecting all of them individually. Although I also want to target the spine, the hips, and the root. Although all the other stuff for the knees shouldn't be targeted. And once again, make sure you enable filtering. Very easy thing to forget, and then nothing is working. If we now try all of this again, Godot can walk and defend at the same time, and we can also still attack. So this is working really well. And while looking at this, I realized the sword doesn't have a texture anymore. Let's investigate that one. So inside of weapons, we have a barbarian texture. And we want to look at sword one-handed. And I think the mistake I made is we do not want to work inside of surface material override. So in there, I cannot really drag it in, but instead I want to work inside of geometry. This one does seem to stick to it. So in there, we can assign a new material. Once again, for 3D objects, you can assign multiple textures, and sometimes it can be a bit confusing. Anyway, if we are trying all of this again, now our sword has a texture again, and everything else still works just fine. Just one more thing that I want to do, and that is while we are defending, I want to have a slower movement speed. Below the run speed, I want to have an export var, let's call it shield, or I guess defend speed. I have set this value to 2.0, but once again, play around to see what feels good. And now, we want to work inside of the move logic, and let me minimize everything else so it's not getting confusing. There we go. So currently, we are assigning the movement speed inside of this variable. And basically all we have to do is get the speed again and set it to the defend speed if defend is the case. If that is not the case, else, then we want to keep the current speed. That should be all we need. Let's try again. If I now defend, we are walking much more slowly. Other than that, we can still run. We can attack. That means there's just one more really important topic that I do want to cover. And let me visualize the problem that we have right now. Godot can attack once. That is totally fine. But what if I press the attack button really often? Then the animation is kind of falling apart. Which means I want to implement some kind of logic that while the animation is running, we cannot attack again. Or in other words, inside of the Godot skin. Let me open it. In the animation layer, for one-hand melee attack chop, we want to add some kind of method that while this animation is running, we can't do anything else. Now, usually you have some kind of button here to add something else, which doesn't exist right now. And if you click on imported scene, Godot tells you what's happening. We have an animation from an imported scene, so we cannot really change anything. However, we can modify this by adding a custom track. And that happens if you go to the Godot GLB model that we are importing. I want to select one-hand melee attack chop, or whatever attack animation you want to work with, and then save the file, enable this one. After that, we have to specify a path. I want to go to graphics, characters, Godot, and then add another folder, animations. I want to, let's call it just the chop animation, doesn't really matter. After that, really make sure that you are activating keep custom track. If I now re-import the entire thing, Godot is going to load for a second, and inside of the Godot folder, we have one animation. However, much more important, inside of one-hand melee attack chop, we can now add a track. And then we have all of the usual options. This, however, is only going to work for this one animation. If we go to any other animation, this doesn't exist anymore. So effectively, if you want to add something to an animation, you have to import it and save it as a separate file. So in my case, I want to work with one-hand melee attack chop. And then add a call method track, which I want to connect to Godot skin. And then at the bottom, we can call a function or a method while the animation is running. And just to make sure we see what's happening, let me expand this thing a bit, like so. And now that we have that, when Godot is attacking, I only want to call this line if Godot is not currently attacking. For that, I want to create another variable all the way at the top, var, let's call it attacking. This needs to be a Boolean value that by default is going to be false. And besides that, I want to create right below attack another function attack toggle, which takes one argument, and that we can call value for now, which needs to be a Boolean as well. For now, all that we want to do in here is update attacking, the variable we have just created, and then assign the value to it. Now make sure you are saving the script, and then inside of this functions track in the animation player, I want to add a key, so insert key, and then we have attack toggle. Open this one, and now this method is called somewhere in this animation. When the animation is starting, I want to call this function, and the one argument I want to pass in there is a Boolean value that should be true. After that, at the end of the animation, I want to add another key that is going to call the same attack toggle function. And now for the argument, this value should be false, just to make sure I got the values right. So for the first key, we want to set attack to true. And for the second one, it should be false, like so. The animation player, I feel, sometimes can be a bit finicky, but you want it to look something like this, where when the attack is starting, it says attack toggle true, and when the attack is finishing on the very last frame, attack toggle should be false. Once we have that, when we are calling attack, I only want to do this line if not attacking. Or in other words, if we're not attacking, then we can attack again. Let's trial off this now, and it doesn't really work. So what's the issue here? And that can be one of the very annoying things inside of the animation tree. Basically, when you have the animation tree and you have a filter selected. So in my case, I want to look at the attack animation with one shot. Inside of Edit Filters, once you add a custom track, you have to make sure that you are activating this one as well. Otherwise, the function will not be called. Not noticing this one can be a really common cause of errors. So make sure you always double check it. Let's try this one again now. And I try to attack as often as I can, but Godot is only ever attacking once. That is looking much nicer. So next up, I want to expand the attack animation just a bit. If the player is attacking once, then I want to play the attack chop animation. But if the player then attacks right away, I want to play a different attack animation. I think it's called attack melee slice horizontal. That way we get a bit more variation in terms of our attacks. For that, inside of the animation tree, at the moment, we only have an attack animation. But that I want to change. I guess we can get rid of this one entirely. And instead, I want to have a state machine that I want to rename to attack state machine. And this I want to connect to one shot. So now inside of this state machine, we can define a couple of attacks. The one that we always want to use is attack chop, which I want to rename right away to chop. And I guess, just to be consistent, I always want to capitalize the first letter. Besides that, other animation I want to play is one-hand melee attack slice horizontal that I want to rename right away, slice. And by default, I always want to go to the chop animation. But I do want to be able to transition between these two. And by the way, I forgot to mention earlier, if you simply connect them like that, you get an auto transition, or in other words, advance is set to auto, which you usually don't want. And if you deactivate this button, then you do not get it. You get the advanced condition to simply being enabled. And that is what you usually want to do. We are getting to one animation, and then we can travel to slice or chop depending on what we want to do. To implement the logic for this one, I want to add to Godot skin a timer, which I'm going to rename to second attack timer. Once we have that, inside of the animation for one-hand melee attack chop, I want to add another track that is going to call a method, and this should be attached to second attack timer. Then we can target the second attack timer, and all the way at the end of the timeline, or when the animation is finishing, I want to insert another key and then start a timer. For the argument, you can set a custom value, although if you leave it at -1, Godot keeps the value that you are specifying inside of the wait time, which is usually what you want to do. In my case, I want this value to be half a second, and it should be one shot. So effectively, when this animation is finishing, we are starting the timer, and the timer is going to run for half a second. That we can use inside of a tag. If this timer has some time left, we want to travel inside of the animation tree in the attack state machine from chop to slice. And if there's no time left, then we want to travel back to chop. For that, first of all, we have to get the attack animation machine. So I guess I can just copy this line and then change the name to attack state machine. For the name, I want to have attack state machine. Next up, if we are attacking and we are not currently attacking, then I want to get the attack state machine and travel to another animation. I want to play slice if the second attack timer has time left. However, if that is not the case, else, then I want to play the chop animation. Let's try all of this now. And if I attack multiple times, quickly one after another, this does not work. And once again, I can tell you why. Inside of the animation tree, when we are working with one shot, edit filters, now we have to activate this second function as well. So make sure you always keep it in mind. It's very easy to forget, and then one function doesn't work, and then you get very, very angry. Anyway, if I now attack once and I attack twice, we're getting different attack animations. If I now attack again, I can do this multiple times. And if I attack once, wait more than half a second, attack again, this is working really nicely. Although there's one thing that you generally want to do inside of a state machine. When you have an animation that you only want to play once, you want to connect them to this end node. So in my case, I want to do something like this, then get the connection node, and this should be automatic, and at the end. I want to connect this node and this node to the end node. And let me this one up just a bit. That looks about right. So the way you want to think about it, when you have one of these two animations, you stick to them. So let's say, for example, we are inside of the chop animation. And if we then play one shot, sometimes Godot keeps on playing this one shot animation. And that is because we keep on the animation and we keep on playing the chop animation without going to an end state where we don't have an animation anymore. This is not necessary inside of the move state machine because we want to play these animations continuously. But for attack, this should be different. Now, sometimes this prevents an error, but in my case, it wasn't really necessary. So the animation still works just fine. But now we prevent a potential error. That looks really good. However, there's one thing I just realized that I forgot. If I run the game again, I can attack once. On the second attack, I can attack right away again. Or in other words, for the first attack, we do make sure that the player cannot attack again while the attack is running, but that we are not doing for the second attack. And fixing that is going to be your exercise. I want you to make sure that Godot cannot attack during an active attack, either the first one or the second one. We already have the first one, the second one is very similar. Pause the video now and try to figure this one out. Alright, so to make sure that the second animation cannot be interrupted, inside of the animation player, we want to look at one hand melee attack slice horizontal. And then at the end, add a method so that we can toggle if the player is attacking or not. For that, I want to go to Godot and then look at one hand melee attack slice horizontal and enable save to file. Then we will need a file path. I want to go to graphics. In there we have characters, Godot, and animations. I'm going to save this animation as slice. After that, make sure keep custom track is also enabled and then re-import the entire thing. With that, inside of one hand melee attack slice horizontal, we can add a custom track. And I want to add a call method track that we connect to Godot skin all the way at the bottom. And then let me zoom in just a bit so we can see what's happening. I want to add a key that is connecting to a tag toggle. And this should happen on the first frame of the animation. And make sure for the value, we are inserting a true Boolean value. After that, we want to go to the end of the animation and add another key for a tag toggle. And this time, a tagging should be false, which is the default value. So in the beginning, we have a tag toggle true, and then we have a tag toggle false. That should be enough. If I now run the entire thing, I can basically press attack as fast as I can. We only ever get a single attack. That is working really good. Perfect. And that finishes the sword part. Next up, I want to work on the magic attacks, which basically means inside of weapons, we have a wand. And this wand we want to display when Godot is in the spell mode, which basically means inside of the player, I want to have another variable. We can do it right below defend, var weapon underscore active. Another Boolean value that by default is going to be false. I can also minimize defend. We don't have to worry about this one. And then inside of the ability logic, I want to, I guess, first of all, add a couple of comments so we know what's happening in here. The first section that we worked on was the, let's call it actual attack. Besides that, we had a section for defend. And besides that, I want to have a section on switch between weapon and magic. Basically, all that means is I want to, if input is action just rest, and look for a switch weapon input. Also make me expand all of this so we have a bit more space. On top of that, the player should only be able to switch the weapon if we are not currently attacking. So and skin dot attacking should not be the case. If those two conditions are met, I simply want to get weapon active and change it to what it currently is not. So is equal to not weapon active. On top of that, I want to get the skin and then switch weapon. And then we can pass in weapon active and use that to determine if you want to show a sword or a wand. For that though, first of all, inside of Godot skin, we need to have another function, switch underscore weapon. That is accepting one parameter, weapon active, which is going to be a Boolean, and this function doesn't return anything. And now the way this logic is going to work. Inside of the Godot skeleton, we have a right-hand weapon. And when we are calling this method, I want to hide this weapon and instead show the wand. Since we don't have a wand in the scene right now, we can only do the weapon part. So if this value is true, I want to show the weapon. If it is false, I want to hide the weapon, which is actually super easily done. You simply have to drag in the sword in there and then show it. And this you only want to do if weapon active. If that is not the case, else you want to get the same node and hide the sword. That's basically it. Besides that, inside of the input map, somewhere at the bottom, we have switch weapon, which is either the middle mouse button or joypad button 1. On my controller, that's the B button. With that, if I run the game again, I can press B, and the sword appears and disappears. So that is working already pretty well. Next up, I want to add the wand. And for that, let me show the 3D scene. I want to add the wand to the right-hand slot as a child. It's a bit hard to see right now, but if I hide the sword, this is looking pretty good. Although once again, we don't have a texture. That though we can fix fairly easily. Editable children, wand, geometry, and you want to override the material with barbarian texture. And there we go. Now we have color. After that, when we are calling switch weapon, I want to, if the weapon is active, I want to get the wand and hide it. Besides that, if weapon active is false, then I want to get the wand and show it. That should basically be it. I can now switch between these two weapons. Doesn't look amazing, but later on, we're going to add some minor effects to make this a bit more compelling. But for now, I am quite happy with it. Next up then, I actually want the player to be able to attack with a spell, which is going to be another animation that we want to use. Inside of Godot, we want to import one more animation, which is a bit further down. There somewhere we have spellcasting. There we have a couple of those. And I want to get spellcasting shoot, which is going to look like this. For now, I just want to have the animation. So I'm not going to re-import it. Instead, I want to work inside of the animation tree right away. And now we want to think about where to put this animation. You could hypothetically put it inside of the state machine. That would be possible. There isn't too much in there yet, so you could do it. In my case though, I want to do it in another way, just so I show you a different way of approaching animation switching. At the moment, when we have multiple animations that we want to switch between, we are using a state machine. This happens for the attack and for the movement. But you can also simply get an animation and then pick the animation that you want to use. So in this case, I want to get spellcasting shoot. This assigned animation you can change in GDScript fairly easily. As a consequence, I'm going to call this the extra animation. And this we're going to trigger via a one-shot that I'm going to call extra one-shot, which is then going to connect to the output. We're getting all of the earlier stuff, and then we're getting the extra animation as a one-shot in there. And while we are here, inside of the inspector, make sure you have a transition time. For now, the extra animation is just going to be for spellcasting, but in just a bit, we are also going to use it to trigger an animation when the player gets hit. But step by step. First of all, I want to get some player input if we are casting a spell. And for that, once again, I want to work inside of the player script in ability logic. We already have an actual attack, and if I spelled this correctly, I would also look much more professional. We are already checking for an ability, but now I want to check if weapon active, then we are triggering an attack, and if it is not the case, else we want to get the skin once again, and then let's call it cast spell. For the moment, without any kind of argument, that's going to come later. To make all of that work, inside of Godot skin, I want to have another function. I believe I called this cast spell without any parameter for now, and we want to return nothing. First of all, we want to check if not attacking. Thereby making sure that we are not currently attacking, and if that is the case, we want to get the animation tree once again, and then set the one-shot parameter that we have just gotten. I think I called it extra one-shot, and then we want to get request. On this thing, like we have done earlier, we want to get an animation node one-shot, quite a long one, and then a one-shot request fire. So effectively, we want to trigger the one-shot to play the animation. That should already work. If I now get to the wand, I attack, we are playing the spellcasting animation. If I go back to the sword, we are getting the basic attack. That looks pretty good. Cool. Besides that, I also want to be able to hit the player and then play the hit A animation. And this one you can find inside of Godot. Once again, we have a whole bunch of animations in there. I want to get hit A. If I play this one, very basic hit animation. You can also use hit B if you prefer that one. It's actually a bit more expressive, so choose whatever you like. I'm going to go with hit A. We don't have to re-import anything right now. That's going to come later. For now, I simply want to get function hit, not returning anything as always. And then once again, let me expand all of this so you can see what's going on. I basically want to get this entire line and trigger it again. But before I'm doing that, I want to change the extra animation to hit underscore A. And for spellcasting, I want to change the extra animation to whatever we call this one, spell, cast, shooting, or something like that. So to be a bit more specific, we want to get this animation node and change the animation for it via GD script. For that, first of all the way at the top, I want to get on ready var the extra animation node, which we can get via the animation tree. Then you want to get tree underscore root, and in there get underscore node with the name of the node, which in my case is called extra animation. The name we have set inside of this field. Getting all of this is a bit cumbersome, but well, it is what it is. With that, we have access to this animation. And the way we would be using it, for example, for a hit, we would simply get extra animation and then set the animation property. If you open the animation tree and you click on this node, you can actually see it in the inspector. There we have the animation property. At the moment, it's at spellcasting, but you could change it. You can also change the play mode and use custom. It's quite flexible, although animation is the one you actually want to use. If Godot gets hit, I want to assign the animation hit underscore A. And be really careful about capitalization. If that one is wrong, Godot is not going to find the animation. Always make sure inside of the import, you are getting the right name. And besides that, for spellcasting, I want to get, let's double check the name here actually. This one is called spellcast shoot. So spellcast underscore shoot. Then we don't need the comment anymore. And now we just have to figure out a way to trigger this hidden method, which I want to do from inside of the player. I guess we can work inside of physics process for now. And I, before move and slide, simply want to check if input is action just pressed UI accept. That's simply the enter key, which we can use for now. Later on, obviously, we are going to change that, but if that is the case, I want to get skin and play the hit animation. With that, if I press enter, Godot gets hit. Godot is working really nicely. And if I switch the weapons and attack with a spell, we are getting spell casting. And once again, if I press enter, Godot gets hit. So that part is working very good. Cool. Now that is a really good start, but we're not entirely done yet, because if I run the entire thing again, and let me switch to the sword, and I attack, and while I attack, I press the enter key, so Godot gets hit. So let me attack, and then do these things at the same time. You can see that the hit is going to interrupt the attack. But for some reason, if I now click on attack, Godot does not attack anymore. What happened here? Inside of the animation tree for Godot, we are playing the attack state machine, or the animation we are getting from there. And then when we are playing the extra animation for the hit, we are interrupting this attack animation. And that is a problem because, for example, for the one attack animation, for the chop, we are toggling the attack in the beginning and then setting it to false in the end. So if we stop the animation somewhere in the middle, then this variable will never be set back to false, which obviously isn't ideal. And also generally, inside of animation trees, when you're interrupting one animation with another, in my case via the one-shot nodes, you want to be explicit about it, which you can do. And all that really means, inside of Godot skin, when we are getting the hit function, besides triggering the one-shot request, I also want to interrupt any kind of attack we are currently firing, which we can do fairly easily. I want to get the animation tree once again, and then get the parameters with attack one-shot request. Except what we are now going to request is, once again, an animation node one shot. But on this thing, we want to get a one shot abort. That way, when we are playing this function, we want to trigger this one shot animation and also cancel the attack one shot, which we're doing via this line. On top of that, what I also want to do is set attacking to false. That way, if we get hit while attacking, our attack gets interrupted and we can attack in the future. Let's try all of this. And now I can still attack. Let's do it with the sword. And if I attack, get hit, it gets interrupted, but I can still attack. So let me do it at the same time. I can always keep on attacking. Although the one thing you might have noticed here, if I attack and get hit, then we are interrupting the animation without a transition. And that is because, let me go back to the animation tree. We're getting one shot here and another one shot here, and we can't really transition between the two, which in this case is totally fine. Now, if you really wanted to have a transition between hit and attack, you could use something like a blend 2D node. But in my case, I think this is totally fine. So with that, we are good to go with the animation tree. That means now we have to add a couple of minor things, and then we are done with this section. First of all, there's one thing that I forgot to do. If I go back to the game and we have the one selected, I can attack multiple times while the animation is running. This is something we have fixed already, so it shouldn't be too difficult. I want to go, once again, to Godot, and then scroll down to Spellcast Shoot. Then click on Save to File, and create a new path to Graphics, Characters, Godot, Animations, and then there, Spell Cast. Click on Save, make sure you have Custom Track enabled, and then re-import. Now we need to wait for a little bit, and then we should be good to go. Once we have that, back inside of the animation in Godot, we want to go a bit further down, and somewhere here we have Spellcast Shoot. And because now we have a custom track, we can add another track to it. And I want to add a call method track with Godot skin, and then at the bottom, we can call a method. Also, I want to zoom in a bit, so this is easier to see, like so. And I want to simply add a key at the beginning that is getting attack toggle. For this key, we want to set the one argument to true. And when this thing is over, we want to add another key with the same function, except now the value we are passing in there is going to be false. That way, if I run the entire thing again, I cannot interrupt the attack while it's running. I am pressing attack as fast as I can, but Godot is only ever attacking once the attack is done. Perfect. Next up, when the player gets hit, or when we are casting a spell, I want the movement to stop for a very short amount of time. Inside of the player, I want to add another variable for the speed. This one doesn't need to be exported, it's simply going to be a speed underscore modifier. This needs to be a floating point value with a default value of 1.0. This we then want to use inside of the move logic, and when we are getting the velocity 2D down here, I want to multiply this value with the speed modifier. At the moment, this is not going to do anything because the value is 1, and if we're multiplying a value with 1, it stays the same. However, what we can do is create another function. Let's call it func stop movement, where we have a start duration, which needs to be a floating point value, and we have an end duration, which also has to be a float. All I want to do in here is create a tween, which we do with create tween. And then I want to tween a property. I want to stay inside of this class and then get the speed modifier. The target value should be 0.0, and the duration should be the start duration. After this tween is done, I want to get another tween property where we are setting this value back to 1, and for the duration, we want to have an end duration. And that is all we needed. This we can now use, for example, inside of the ability logic, when we are casting a spell. I want to stop the movement for a short amount of time. For the start duration, I went with 0.3, and for the end duration, 0.8. If I now run all of this again, I can cast a spell, and Godot is going to stand for a short amount of time, and then can walk again. So this is looking really good. Although, another issue is that the movement is generally a bit slow and weird. So let's fix this one really quickly. All we have to do, inside of the move logic, when we are getting the velocity 2D, this value needs to be much larger. So I'm going to multiply it by 8.0, and then this entire thing should feel much better. If I now run around, this is significantly better. And the speed modifier also still works. So this is looking really good. With that, I can minimize all of the functions. And the one additional thing that I do want to do is when Godot gets hit, or in other words, when we are playing the hit function inside of Godot skin, we want to also stop the movement, or in other words, call the stop movement function. Since later on, we are going to need a hit function inside of the player class anyway, we can simply create hit in here. And once we have that, I want to call skin.hit, so the function we have created earlier, this one. And on top of that, I can call stop movement with the same values, 0.3 and 0.8, although you can play around with that. And then, when we are capturing the input, I simply want to call the hit function inside of the player class. That way, I can run around, get hit, and Godot is going to stop for a second. Now, I think returning to movement takes a bit long, so we can adapt the value to, let's say, 0.3 as well. Next attempt, and now this feels much better. Once again, play around with the values and see what looks good. In my case, I think this is good enough, so that leaves me with two more minor things that are entirely cosmetic. The first one is when Godot is moving around, and let me play the game for that. For example, when we are jumping, right now the entire thing feels a bit static. So what animators tend to do, when you want to imply stronger movement, they are stretching the model in certain ways. For example, when Godot is jumping, I want her to stretch in this way and a bit in this way. So Godot becomes longer and thinner, which is something we can do fairly easily. For that, inside of the Godot skin, I want to create another variable. Let's do it below attacking. This one is called var squash and stretch, and it's getting a default value of 1.0. Also, this always needs to be a floating point value. On top of that, whenever this value changes, I want to do something, which I can do via the set functionality, where we are getting a value. And this value we want to use to override squash and stretch. So far, this is not going to do anything. However, what we are now able to do is affect the scale of the model, which needs to be a vector 3, where we get x, y, and z. X and z, for now, are going to remain 1. Because I don't really care about them, what I want to do is stretch the height of the model, which is going to be y. For this, I want to use squash and stretch. That way, whenever we are changing this value, we are also scaling the model, at least on the y-axis. And that we can use inside of the player. All the way at the bottom, I want to create another function. Let's call this one do squash and stretch with two parameters. We want to have a value, which needs to be a float, and we want to have, let's call it duration, which also needs to be a float with a default value of 0.1. And let me expand the window so you can see what's going on. In there, we simply want to create another tween like we have done before. So create tween, and then tween a property, tween property. We want to target the skin, so the Godot skin. And in there, we have squash and stretch. The value we want to go for is the value we are getting from the parameters. And for the duration, we're getting the duration parameter as well. This is already a good start because now when the player is jumping, so inside of this if statement, we can call do squash and stretch with a target value, let's say 1.2, and a duration, let's say 0.15. If I now run the game again, Godot can jump, and we are stretching the entire model. That is a pretty solid start, but it looks a bit weird. Now Godot is simply stretched out. Once the first tween property is done, I want to do another one. Tween property, we're once again targeting skin and squash and stretch. However, now the target value is going to be 1.0. We are going back to the default value. Besides that, I want to have the duration, and this one should be a bit longer. Let's multiply this with 1.8. You could customize this a bit more, like we have done with stop movement, where we have a start duration and an end duration. It's entirely up to you, both approaches would be totally fine. Now for the second tween property, I also want to set an ease curve, which is going to be tween and ease out. With that, I can jump, and Godot feels much more animated. So this feels quite a bit nicer. And we can make this effect even stronger. Inside of Godot's skin, when we are scaling the model, we are only affecting the Y scale. X and Z are unrelated. But if we are squashing those, then the stretching is going to look even better. But these values should become smaller. So for this part, I want to create a negative value, which we can get with 1.0 plus, in parentheses, 1.0 minus squash and stretch. For example, at the moment, squash and stretch has a value of 1.2. As a consequence, this entire value is going to be negative 0.2. And this we are adding to 1.0, so the overall value here is going to be 0.8. And the closer squash and stretch gets to 1, the closer this value goes back to 1 again. That way, we can use negative for x and z. So on there, I want to have negative. And then we are squashing the Godot model. Let's try all of this. And now if I jump, this feels really good. And this, by the way, we can do in a couple of places. For example, when the player changes the weapon inside of ability logic, I want to copy do squash and stretch from jump logic. And then when we are switching the weapon, I want to do the same thing. If I now run the game and I switch the weapon, we are getting a short animation. You could also put this inside of the hit function, for example, just play around and see what looks good. Anyway, with that, we are nearly done. There's just one more thing that I do want to cover, and that is, once again, inside of the Godot model. At the moment, this feels a bit static. So ideally, I want her to blink once in a while. And to make that work, we have to update the texture on this model. Now, if you look inside of the Godot folder, there we have two textures. The first one has a couple of faces, and the second one has the actual colors. And if you look at Godot head, inside of the actual mesh, we have a couple of surfaces. And there you can see we have the head, and there are the different faces that we can work with. So how can we get to these faces? And for that, if you click on it and go down, somewhere we have UV1. And if we added an offset here, we could get to different faces. So the top left, you can kind of see it up there, is the default face we have at the moment. But since the imported model is, well, imported, we cannot change these values. But what we can do, we have surface material override. If I click on that, we have two textures that we can override. And in there, I want to drag the Godot faces in. And this right now doesn't change anything. But since this is a new texture instead of UV, we can update the offset. And if I increase this value, you can see that we are getting different faces. This we can also do on the y-axis. There somewhere we have angry Godot, and we can go to blinking Godot like so. In total, there are 4 different faces. And by changing the UV of the surface material override, we can toggle between them. And this I want to do via a function. Although first of all, we have to get a couple of default values. which also has to happen inside of Godot skin. Let me expand all of this. We don't need squash and stretch anymore. Instead, I want to have a constant faces, which is going to be a dictionary where we only really care about two values. We have default, and this is going to be a vector 3 with all values being 0. And by the way, this is a vector 3 because inside of the UV, we have 3 values, x, y, and z. The only other value I care about in here is blink, which is going to be a vector 3 with the values 0, 0.5, and 0. And I think I should explain, here is the entire texture. And the origin point is in the top left. So this value up here is 0.04x, and then we have 0.04y. The bottom left point, so this value down here, is 1 and 1. And the face texture is designed to only ever take a quarter of the image, something like this, which means our default value of 0 and 0 is going to give us all of this. And if we set the value to the origin point here, which is 0.04x, we are on the left side, and 0.5 for y, meaning we are going down half of the image. From that, we are getting this entire image. You could also make Godot extra happy or extra angry. It's entirely up to you. I don't really need those faces though. If you wanted to use them, simply add 2 more values in here, and then you can access them. Although, before we can do that, we have to get the actual texture. So at the moment, we are overwriting the surface material, but we don't really have easy access to this standard material 3D. Although that we can change. And let me add a bit more space, something like this. Once the scene is ready, meaning on ready, I want to get the face material of Godot, which needs to be a standard material 3D at all times. And I simply want to get the Godot head, so I can drag it in. And let me expand all of this. On this mesh, we have a function called getSurfaceOverwriteMaterial. And in there, we have to add 1 argument. A bit hard to see, but this has to be an index. And we can tell right now, we have 2 surface material overwrites, 0 and 1. We want to get 0, which means in there, 0, and we are good to go. Now we have the face material. And on this face material, we want to overwrite the UVs using these values. For that, I want to create another function. So function change underscore face. As an argument, we want to insert an expression. Once we have that, I want to get the face material and set UV1 underscore offset. The value we are going to assign to it is what we're getting from the faces dictionary, and the key will be the expression from the parameter. Now we have to figure out when to call this function. And since I want Godot to blink in certain intervals, I need a timer. Which means inside of Godot skin, I want to add a timer node, which I can rename to blink timer. The wait time I have set to 2.1 seconds, and this should auto start. On top of that, I want to connect this signal to Godot skin. That way, we can call a function every time this timer times out. And I want to call change face and change the face to blink, or whatever value you have inside of faces for the blink texture. Which means if this timer runs out, Godot's face should be changed to blink. Let's try. And after about 2 seconds, we're getting a different face. That looks really good. Although I don't want her eyes to be closed permanently. Which means I want to create another timer in here and await that timer. Which means await get re.create timer. The duration of this timer should be 0.2 seconds, and we are waiting for the timeout of this timer. So practically, this line says that we want to wait 0.2 seconds. Once the timer is over, I want Godot to return to the default face, or the face we have assigned here. That way, If I run the game again, Godot should blink at some point, and there we go. This should happen multiple times, and it looks pretty good. Now you could be a bit fancier here and randomize the duration of the blink timer. I suppose we can do that right now, it's not too difficult. I want to create another variable, RNG, which we can create with random number generator.new. And after we have that, every time the timer times out, I want to update the blink timer wait time and set an RNG random floating point range with, let's say, a value between 1.5 seconds and 3.0 seconds. This is going to be a bit hard to see, but now the blinking should be a bit more random. That looks about right. So with that, we have a pretty good looking character animation that can change weapons, attack, move around, is squashed and stretched, and quite a few more things. At this point, you should have a pretty good idea of how to work with 3D models. Now, before we finish, there's one more thing that I do want to do. Because for the entire duration of this part, the Godot model has looked a bit blue. And that is because the sky at the moment is really, really blue, which changes the entirety of the scene. Now, later on, we are going to change the light quite a bit. But for now, I want to make this a bit less blue, which we can do by going to the world environment. And there we have the sky. There we have the sky material, this one. And in there, you have a procedural sky. And in this one, we have the top color, which is the top sky color. If you make this a bit less blue, then the scene becomes much more neutral. I think something like this is going to look better. But once again, play around with the values. If I now run the game again, this is feeling significantly more neutral and less blue. And once again, later on, we're going to work with this node quite a bit to make the game look much nicer. But for now, I think this part has gotten quite long, so next up, we're going to work on the boss and the other enemies, which is going to be a lot more practice for character animations. With the main character finished, we have learned about the basics of importing and animating a character. But we need more than one character for a game, so we will add 3 enemies: a boss, a skeleton warrior, and a mage. They are going to work in a similar way compared to the player, so technically, you should already be able to create them yourself. So if you really want to challenge yourself, here are the details you need for the enemies. You could pause the video now and try to do the entire part on your own. There's just one additional animation tree node that I have not covered yet. For the boss enemy, I want to scale up the model and slow down the animation, so it feels bigger and heavier. Since the animation tree is taking over the animations, we cannot set the animation speed in the animation player node anymore. But in the blend tree, we have a node called timescale. This one can slow down or speed up an animation and is super easy to use. Now you have everything you need to get started with this part, and you will get extra points if you use inheritance to make all of this more efficient. But if this becomes too much, don't worry, I will cover everything in detail. So either pause the video now or keep on watching. Here we are back in Godot, and I want to create a new scene. The parent node should be a character body 3D, which I want to rename to enemy right away, and then save the scene. Inside of scenes, there we have entities, and I want to create a new folder for the enemies. Then click on save, and now we have a scene. Now this enemy is going to become the parent scene for all the enemies, meaning for this scene, we want to add the nodes that are going to be in all of the other scenes. And for now, that is only going to be a collision shape 3D. Without any actual shape, we are only adding the node. That is because the boss enemy is going to be much larger than the other 2 enemies. And that we have to account for. But that is totally fine. So with that, I want to save the entire thing. And now click on Scene and New Inherited Scene, where we have to select the enemy scene. And now we have a child scene that I want to rename right away to boss. Also make sure you are saving the entire thing as boss.tscn. And now we can work on the first enemy and switch between the enemy and the boss depending on what we need. I suppose first of all, we want to add the actual skin of the boss. And for that, you want to go to Graphics, Characters, and there we have Nagon Ford, which contains a texture and then the scene with all of the animations, this looks very similar compared to what we have seen for the player. The major difference now is that this model already has a weapon. But other than that, we have the skeleton 3D and then a whole bunch of animations. All of this we have to work with, but for now, this is totally fine. So first of all, we have to get this model into the scene, which we can do by simply adding the nagonfort.glb scene to the scene, and there we have the model. We can also look around, and that is working pretty well. Although we have a bit of an issue, the origin point. So this point here of the model should be in the center. Also, if I save the entire thing and go to the level and simply to entities add the boss scene now, you can see that the boss is basically as large as the player, which doesn't really feel threatening. So before we are recentering this model, I want to go to transform and then scale the skin up by a factor of 3. If we now save the entire thing, go back to the level, this feels much better. And now we can fix the origin point, which means I want to go to the front view and then move this model to this origin point. It's not perfectly aligned. And if you hold shift and move it, then you can go without going in increments. So I want to move him just a bit further this way, and that looks good enough. It doesn't have to be perfect. I just want him to be roughly in this position. Now that we have that, we can go to the collision shape and then create a shape, and I want to go with a capsule shape 3D that we now have to scale to account for this model. And for that, once again, I would start with the front view and then align this thing so we capture the entire body, something like this. And I guess the player cannot really reach this top part anyway, so it doesn't matter too much. But you do want to make sure that we have the bottom bit down here so the model doesn't float in the air. And you can see, it might be hard to see, but there we have the blue line with the collision shape. And this bottom part has to be on the same line as the bottom of the feet, which I think looks about right. So this is good enough, but for a real game, you want to invest a bit more time into it. Also, before we continue, I want to rename this Naganfort animated to skin. That way, it's a bit easier to understand what's going on. If I now save the entire thing, we can move the model somewhere a bit further away from the player, and that works about okay. That is going to give us a model, and this we now have to animate. And for that, if you right-click on the skin and select Editable Children, then you can see the skeleton we have imported, and we also get the animation player. And in there, you could play the animation. Although in our case, we don't want to do this directly. Instead, inside of the enemy, I want to add an animation tree. If I now save the entire thing, I can go back to the boss scene, and then we have an animation tree, which first of all needs to have an animation player. And for that, we can use the one from the imported model. Then we are good to go. Next up, I want to create a node blend tree. This is going to be very similar compared to what we have seen with the player. So for now, I simply want to add one animation. Let's go with melee idle. And if I connect it to the output, the model is going to animate. Although it's only going to play this animation once, which happens because when I click on the import tab for melee idle, we have to make sure that the loop mode is set to linear. If I now re-import the entire thing, it should play continuously. That looks pretty good. Let's look at the level. And if I play the scene, we get the boss character and we have the animation. So that is a really good start. Also at this point, there's one thing that I don't think I have covered yet. If you go to project settings, and then scroll down to 3D physics, there you can see we have a whole bunch of physics-based layers. Terrain, player, enemies, projectiles, and items. So what we should be doing at this point, before we continue, inside of the player, or the character body 3D, I want to go to the collision layers and make sure the player is not on terrain, but on player. And the player can see the terrain, and we can see the enemies from this node. You could also select the player mask, but since we only have a single player, it's not going to matter. Besides that, for the enemies inside of the character body 3D, for the collisions, we do want to be on the enemies layer, and these objects can see the terrain, they can see the player, and they can see other enemies. Oh, and also I forgot, they can see projectiles, which the player should also be able to see. So once again, inside of the player for collisions, the player can see projectiles and items. All right, and then finally, for the level, we have the environment with a couple of static bodies. Those are all on the first layer, which is for the environment. So this doesn't need to change. Alrighty, so with that, we have collision layers. Next up, we can make the enemy walk towards the player. And since this function is going to be the same for all of the enemies, we can create this inside of the parent class, which means I want to add a script in the same folder. Although for the template, I want to go with object empty. Then click on create, and now we can write some code. First of all, once the scene is ready, we want to know where the player is, which means variable player is going to be something. And well, in my case, I want to get the tree and then get first node in group layer. That way we can get the player anywhere inside of the code. But this at the moment is not going to work because the player isn't inside of this group. That we can change. If you click on the player, then go to node and groups and add a new group called layer. Click on OK, and now we have a player group that we can use inside of the enemy class to determine where to go. Also, just to make things a bit easier to write, once the scene is ready, I want to get the skin, so the character model, simply with get underscore node and the name skin. So this would be a reasonable starting point. But I want to have a system where we have some functions inside of the enemy, but then inside of the boss character, we have a separate script. That we can do fairly easily. Inside of the enemy script, all the way at the top, I want to add a class underscore name and call this one enemy. With that, we can look at the boss scene, remove the script, add a new script called boss, then create. And now this scene should extend the enemy scene. That way we're getting all of the character body 3D plus anything we are adding to it. So for example, what we could now do is func ready and print the player. Let's try that one now, and nothing happened. That sometimes happens because if you look at the level, the boss node does have the icon for the scene, but not for the script. I'm not sure why that is happening, but if you delete the boss and add him again, now we can see the script. So it should be working now. And there we go. The player has collisions, and also in the output, we're getting the player character node. That is a really good sign. To use that functionality, I want to use, once again, the physics process function, like so, and then create a function called move to layer, which is going to accept delta time. This function doesn't exist yet, and I do not want to create it inside of the boss GD script. Instead, this should be inside of enemy.gd. So in there, move to layer, with the one parameter being delta. And for now, let's simply print move to layer. If I now save the scene, Godot is going to stop complaining inside of the boss. And if I run the scene, we're getting move to player continuously. Also, before we continue, I want to move the boss a bit to the front so the player doesn't start right on top of it. That's a bit better. With that logic, we can move the enemy towards the player and then reuse that function inside of all of the enemies. For that, first of all, we're going to need a new variable. Let's call it target direction. This is simply going to be the player.position minus the position of the current enemy. And this we also want to normalize so the enemy doesn't move faster if the player is further away. Normalized. Just to show what this is doing, let's print the target direction. If I now run the entire scene, right now we have a Z offset of -1. But if I move around, this value changes. And this effectively is the direction from the player to the enemy. Or rather, from the enemy to the player, but same thing really. This vector 2, we want to turn into a 2D vector right away. So let's call it target vector 2. This needs to be a vector 2 in which we are getting target direction.x and target direction.z. Once again, remember, we do not care about the y part because this one is up and down, and the boss should only really go forward, backwards, left, and right. Once we have that, all we really have to do is give this character a velocity, which needs to be a vector 3 just to get started, and in there, we want to get the target vector 2.x, then 0 for y, and target vector 2.y. Also, this we want to modify by some kind of speed. For now, let's go with 10. We have to call move and slide to actually use the velocity. If I now run all of this, the enemy should move towards us. And that is working pretty well, although maybe a bit fast. Let's change the speed to something like 3. Run the entire thing again. And now we can actually run away from the enemy, but this otherwise works the same. Perfect. I suppose changing this to 2 would be even better. And what would be even better is to have an export variable for the walk speed, which always needs to be a floating point value. And for the boss, by default, this should be 2.0. And this value I want to use here. That way, it's a bit clearer what's going on. But right now, the issue is that, well, the model itself doesn't change. We simply move it towards the player. I want to rotate the boss using this target value. For that, first of all, we need to get a target underscore angle, which is simply going to be the target vector 2 dot angle. Don't forget to call this one. And now we should be getting something. So this is not doing anything because I can tell you right away, we are only creating a variable, we are not using it. For that, like for the player, we want to get rotation.y and then rotate toward, where we want to get the current rotation.y. We want to rotate towards the target angle and do it by some kind of speed. I want with delta time times 6.0. Let's try this again. It's not going to work perfectly, but it should do something. If I move around the boss, we're getting some kind of rotation. Just the wrong kind of rotation. Meaning we have to manipulate this value just a bit, and then we are good to go. And the same thing we have already seen for the player. So somewhere, I think inside of the move logic, we are rotating the skin, and for that we have a target angle, which we set to negative and then plus half pi. The same thing I want to do for the boss, which happens inside of the enemy, negative rotation, and then plus pi over 2. Next attempt, now the boss should be facing us, and he does. That is working pretty well. Cool. That means next up, we can work on the actual animation. So the boss can either walk or idle at the moment. For that, in my approach, I created first of all a few more export variables. The first one is going to be a notice underscore radius, which is going to get a default value of 30.0. Then I want to duplicate the entire line because next up, I also want to have an attack radius, which gets a default value of 3.0. Those values we are going to use inside of move to player. I only want to move the enemy if position.distance to the player dot position is smaller than the notice radius. Only if that is the case is the boss going to do anything. Which means if I move the player to this corner and the boss to the other corner, he might not do anything. I'm not sure if it's going to be far enough. Let's see. And right now, the boss isn't doing anything. But if I get close enough, at some point, should approach. There we go. Now the boss is coming towards us. Next up, I always want to do this first bit so that we are rotating the model. But for the movement, I want to add another if statement. If position dot distance 2, once again to the player dot position, if that value is greater than the attack radius, then we want to move towards the player. And if that is not the case, else, then we want to set velocity to vector 3.0. If the player is quite far away from the enemy, we want the enemy to walk towards the player, and if the two are close to each other, the enemy should not be moving anymore. While that is happening, I also want to get a move state machine and then travel to various states. And let me fix my typo. This should be a move state machine that travels to the walk state. Whereas if the enemy is close by, we want to move to the idle state. Now, this move state machine doesn't exist at the moment. For that, we have to look at the boss and specifically at the animation tree. At the moment, we only have a single animation. And that we can actually delete. Instead, I want to create a state machine that has to be called move state machine. Because inside of enemy, so the parent class, all the way at the top, once the scene is ready, I want to get the move state machine, and this should be a variable with the value coming from the animation tree.get. And if you have the enemy selected, this is also going to work much more easily. All we really want to have in there is parameters. Then we want to have the move state machine. And don't forget, we want to have playback. And ideally spell it correctly as well. I hope all of this wasn't too fast. Let me go over it again. Inside of the boss character, this one here, we have an animation tree. And inside of this animation tree, we have a state machine. Then inside of the parent scene, the enemy, we are capturing this state machine with this line. And then when the enemy is supposed to walk towards the player, we are traveling to the walk state. And if the enemy is close to the player, we are traveling to the idle state. This still doesn't work because inside of the state machine, first of all, we have to connect it to the output and we have to add the actual states, which are going to be the animation for melee idle. And then we also need to have a walk animation. And once again, we have a couple of different walk animations. I'm going with walking A. Also, I want to rename both of them to idle and walk. After that, I want to go immediately and automatically to the idle state and then be able to travel between idle and walk, like so. Also, before we continue, something I always forget is that you want to have an X-fade time for both of these transitions. And that should be it. If I now run the entire thing, I can run towards the boss, and at some point he should start walking towards us. And this kind of works, but not yet. And if I get close enough, we're getting to the idle state. So that's a good sign. And he can walk for a bit, go back to idle. That is working fairly well. And you might have guessed what the issue here is. If we go back to the import screen and look at walking A, this one only plays once at the moment, but we want it to be linear so it loops. If I now re-import the entire thing, and inside of the level, I want to move the player a bit closer to the boss, and the boss a bit closer to the player. Let's try all of this again. And now the boss is going to walk towards the player. And if we get far enough away, he should stop doing that. Okay, a bit difficult to get far enough away, but I think this is all right. So with that, we have the basic movement mechanic. That's pretty much all we need. Although, obviously, simply moving isn't very fun, so inside of the boss, we want to have quite a bit of attack logic. And this one has to be inside of the boss itself, because his attack pattern is going to be very different compared to the other enemies. First of all, though, we have to figure out when to trigger an attack. And for that, we want to stay inside of the parent class for just a bit and add a couple more nodes. I want to add a very plain node and rename it to timer. Actually, this should be timers, because later on we're going to add a few more, but for now I want to have a single one that I will rename to attack timer. If I now save the scene and go to the boss, we don't need the skin at the moment, and we can see attack timer. For this value, I want to set a wait time of 5 seconds and auto start it. Besides that, I want to go to node, signals, and then connect the timeout signal to the boss scene. If I now click on connect, we're getting the timer timeout, and if that triggers, we can do something. For the boss, we have 4 animations in total that we have to control. There are 2, let's call them melee attacks, and we have 2 range attacks. And I think starting with the melee attacks is going to be the easier part. For that, first of all, I want to check if the player is very close to the boss, which means if position and distance to the player dot position, we have seen this a couple of times. If this value is low enough, then we want to trigger a melee attack. And for that value, I simply went with something below 5.0. You could turn this into a variable as well, or work with the attack radius. They all kind of work. For this boss, we don't really need it because the axe is so large and reaches really far, which means a greater radius here is totally fine. But once again, play around and see what works best for you. If that is the case, I want to trigger a melee attack animation. Then we don't need the pass statement anymore, but we do have to create the melee attack animation. So func, melee attack animation. No need for any custom parameters. And now we can add some logic in here. Although for now, I do want to add pass, because inside of the animation tree for the boss, we have to add a few more things. Besides the state machine for the movement, I want to add another animation that I'm going to call the attack animation. And this one for now is going to get all the way at the top. One hand melee attack slice horizontal. And this I want to trigger via a one-shot node, which means the in node is going to be the move state machine, the attack is going to be the animation we just created, and the entire thing we are connecting to the output. Also, with one shot selected, you want to set a fade in time and a fade out time. Finally, we want to rename the attack one shot to attack one shot, just to keep the naming a bit more descriptive. Perfect, this looks good. So now, whenever the attack timer triggers and we are calling the melee attack animation, I want to play this animation, which means I want to get the animation tree and then set the attack one shot request, and let me expand all of this to an animation node one shot and one shot request fire. Let's try all of this, and we do have to make sure that we are close to the boss. So after a couple of seconds, we should get one attack. That looks good, although all of this was quite fast. To account for that, inside of the animation tree, we can add another node, and this is what I talked about in the beginning. So when you are looking at an animation player, most of the time, When you want to control the animation speed, you would simply go to speed scale and change this number to whatever value you need. However, if you have an animation tree, this value does not do anything. Instead, what you are supposed to do inside of the animation tree, you need to add another node called timescale. And this one is super simple. You simply have to connect an animation in and you get an animation out that right now doesn't do anything, but via this one, you can either increase or decrease the animation speed. In my case, I want to change it to 0.5, meaning the animation is going to play half as fast. Let's try all of this again, and now the boss is going to move significantly slower. And that is still looking good. Perfect. And while we are here, we can also randomize the attack. Although for that, inside of the enemy, I want to create a new variable called RNG. And this is going to be a random number generator.new. Once we have that, inside of the boss, I want to create a dictionary which can be a constant called simple attacks. And for this one, we're going to get 3 values. The one that we have already seen for the attack animation, this one is called slice. And the actual name of the animation is two-hand melee attack underscore slice. And make sure that you are capitalizing the first letter every single time. Besides that, I want to work with 2 more animations. The first one is called spin, and this one is simply going to be two-hand melee attack and not slice, but spin. Finally, something that we are going to use later, range. Range, and for this one, we want to have one-hand melee attack stab. And I hope this part still makes sense, the way you want to approach it, if you open the import tab for Nagonfort and look in there, we have a whole bunch of two-hand melee attack animations. The ones that I want to use are two-hand melee attack slice, this one. Then we have two-hand melee attack spin, that's a spin. And finally later on, for the ranged attack, I want to play this one. And the way we are going to use them inside of the animation tree. At the moment, we simply have the attack animation. And we already know how to change this animation using GD script. Which means inside of the parent class, let's do it below move state machine, on ready var attack animation. I want to get the animation tree, and if you select the enemy scene, the autocomplete is also going to work. I want to get the tree root and then get node. The node that I want to get is the attack animation. So with that, we can update the animation node. And this has to happen inside of the boss. And in here, before we are playing the animation, I want to get the attack animation and update the animation that we are actually playing. For that, I want to get the simple attacks dictionary, use indexing. I want to get slice if rng.rand integer is an even value. So mod 2, and then we are good to go. If that is not the case, else I want to play the spin animation. After that, since for the timer we haven't activated one shot, this should play multiple times. Let's try. I have to get close to the boss, and now just wait a bit. We are getting the spin animation. That looks good. And besides that, there should also be another one. And that didn't work, but it's randomized, so it didn't work again. Sometimes random values can be a bit annoying, but there we go. Now we have the other attack animation. And it keeps on working. That looks good. With that, we have the 2 melee attack animations. That's basically it. That means next up, we can work on the ranged attacks, which we want to trigger if the player is further away than this radius. For now, I want to get a range attack function. I suppose, to keep things a bit more consistent, range attack animation. This one doesn't exist at the moment, so Godot is going to complain. Let's create a func range attack animation without any parameters, and for now, I want to add pass in here. And I think, just to keep everything consistent, the two functions we have created don't return anything. So you should be adding void to it, but it's not mandatory. It just feels a bit cleaner, entirely up to you. Now, for this range attack, I want to do something fairly similar compared to what we have done for the melee attack animation. In fact, I can simply copy these two lines and then make some updates to them. The attack animation that we want to pick is not going to be slice or spin, but instead it's going to be range. Or in other words, we want to play this animation. After that, we still want to trigger the one shot, so that's basically all we need. Let's try. And once again, the boss is walking towards us, and now I have to stay a bit further away. And after a few seconds, we're getting an attack range animation that later on is going to spawn a particle, but for now we just need the animation. This kind of works, but I would want the boss to stop while doing this attack and then continue walking after the attack is finished. That is something we have already done for the player. So if you look at the player functions, we have stop movement, which I want to copy and paste into the enemy class. Now, generally copying code is not a great solution, and for a real game, a really good idea would have been to rename this enemy to something like entity, and then it would be the parent class for all of the enemies and for the player. That way, you could reuse this function quite a bit better. But in our case, this isn't too much of an issue. Just keep in mind, this isn't ideal practice. Now to continue, we have to create a speed modifier, which we can do right below the walk speed bar speed underscore modifier. The default value is going to be 1.0, and this should always be a floating point value. After that, when we are moving towards the player on this line for the velocity, we want to multiply the walk speed with the speed modifier. That way, this function is going to actually do something, because remember, we are targeting self and then the speed modifier. After that, inside of the boss, when we are triggering the range attack, we want to get the stop movement function and set a start and an end duration. For both of those values, I have set 1.5 and 1.5. That way, if I try all of this again and make sure I'm far enough from the boss, we get the range attack, the boss stops moving, and then starts moving again. And this works multiple times, so this looks pretty good. Although this is not ideal, because when you look at the actual animations, so inside of skin, there we have the animation player, and somewhere in there we have one hand melee attack stab. We can see that this animation has some kind of duration, and that is what we are working with. So if you had a professional game, you would want to add an extra track in here, and then stop the movement at the beginning of the animation and restart it once it's done. So for example, the boss could start moving here already, and he would only stop maybe somewhere here. I hope that makes sense. Basically what I'm saying is that when you work with the animation player, you can have much more control over when the enemy stops and starts moving again. But in my case, for tutorial, having something like this is totally fine. Anyway, with that, we have the first range attack. Next up, I want to have a spin attack during which the boss is moving much faster. And I want to randomly select either range attack or the spin attack if the player is far enough away. Although I suppose while we are testing all of this, I only want to have the spin attack to make testing a bit easier. I want to create a spin attack animation, which once again doesn't exist at the moment. We have to create it, func spin attack animation. No need for parameters, and we don't want to return anything. However, now this spin attack is going to be a bit different than the other attack animations. So let me add pass in here and then explain. I guess we can work inside of the level. If the boss is moving towards the player and triggers the spin attack, then we want to increase the movement speed by quite a bit and play the spin attack animation continuously until the boss reaches the player. Or in other words, if you look at Naganford animated in the import, there we have two-hand melee attack spin. This one plays once. But there's also two-hand melee attack spinning. This one plays continuously. Which means we want to make sure that this animation is looping. Righty, that was quite a bit of theory, so let's get started and work through this slowly. When we are playing the attack spin animation, first of all, I want to increase the actual movement speed via a tween. I want to create a tween and then tween.tween property. I want to target self and then the speed property. This value I want to increase to spin_speed, which doesn't exist yet, but we'll fix that in just a bit. For the duration, I want to have 0.5 seconds. To make sure Godot stops complaining, I want to have a var spin speed, and for this value, let's go with 6. And I guess this could be an export variable. Let's try all of this now, and I have to run away from the boss, and after the attack triggers, the boss should move quite a bit faster. And he doesn't. Instead, we're getting a debugger error. That speed does not exist inside of boss. Let's double check. Inside of the enemy, we don't have a speed. Instead, we have a walk speed. Like we have done for the player, I want to have var speed, and this by default should be the walk_speed, which we also want to do once the scene is ready. And then when we are actually moving the enemy, we want to only use speed. And that way also, inside of the boss, when we're updating the speed, we can use other kinds of speed without overwriting the original walk speed. So next attempt, I have to run away from the boss, and after a bit, the boss should be moving much faster. And that is working really well. Perfect. While the boss is moving much faster, I want to play the spin animation continuously, which means inside of the animation tree, we have to make some minor changes. Most importantly, I want to add a blend 2D node that gets the stuff that we have done so far, and we use the same output, but now we're adding another animation that we are connecting to this blending. The animation that I want to play is two-hand melee attack spinning, and make sure it's spinning, not just spin, because this one is supposed to play continuously. Once we have that, if I increase this value, we are rotating. And once again, this is looking a bit weird because we are playing this animation continuously and then blending between two animations, which always looks a bit weird. So let's keep it at 0, and instead, inside of the code, I want to control this value via the tween. Or to be a bit more specific, I want to tween a method. The method that I want to work with is _spin transition. This one doesn't exist yet, but we'll fix that in just a second. Our start value will be 0.0 and our end value will be 1.0. Finally, for the duration, I went with 0.3, simply because it looked good. After that, we have to create the function spin transition, where we need to have one parameter that is going to be the value, which needs to be a float at all times. Also, this function is not going to return anything. All we really want to do in here is once again get the animation tree and then set the blend amount to a certain value. And before we are doing that, I want to rename blend 2, so the animation node, to spin blend. I think that makes a bit more sense. So now in there, I can get the spin blend amount and then use the value from the tween to control this value. Let's try all of this, and once again, I have to run away from the boss. And after a while, the boss should move faster and play the spin animation. That looks really good. This also keeps on running. Perfect. That's a really good start, but we have to make some changes. So, while this spin attack is running, we do not want to run the attack timer, because while the boss is spinning, there shouldn't be any other attacks. That is very easily done. I want to get the attack timer and stop it. Besides that, I want to set a variable called spinning to true. Since this variable doesn't exist at the top, I want to have var spinning, which needs to be a Boolean value that by default is false. After that, if the boss gets close to the player, or in other words, if we are roughly in this area and the boss is spinning, then I want to stop spinning after a short amount of time. To make that work, I want to add an area 3D, which we haven't used yet, but it works like it does in 2D, which means we have to add a collision shape 3D with a certain kind of shape. In my case, I went with a sphere shape and scaled it out to something like this. Also make sure for the area 3D, inside of collisions, this thing should not be on any layer, so nothing else can see it. And it itself should only be able to see the player. Besides that, I want to go to node and body entered, and then connect it to the boss scene. If that is the case, for now, let's simply print the body. We can try all of this once again. If the boss is spinning, he's going to go much faster. Now, if he gets close to the player, we are triggering the function. This part is working pretty well. I suppose I forgot to rename this function, but we are only going to have a single area 3D in here. It's not too bad. In this function, I want to check if we are currently spinning, and if that is the case, I want to create another tween via create tween, and let me expand all of this. Via that tween, we want to do basically the opposite that we have done up here. In fact, let me copy all of this, and first of all, we want to set the speed back to the walk speed. Or in other words, I want to have speed and walk speed. After that, for the spin transition, I want to have a start value of 1.0 and a target value of 0.0. Finally, spinning should be set to false, and we also have to restart the attack timer, which means attack timer.start. With that, we can try all of this, and let me run away from the boss, wait for the attack. He starts to rotate. Now he stops rotating, and now we should be getting a different attack animation. That looks pretty good. And if I run away from the boss, we should be getting this spin attack once again. That is working really well. And if it gets close, then we are going to get a different attack animation now. Perfect. Now, to make all of this a bit more interesting, there are a couple of things you could be doing. First of all, once the boss is spinning and gets close to the player, we are immediately stopping this spin animation. But that is kind of easy on the player. So instead, you could add a wait get underscore 3 and create a timer with some random duration, which we can do via RNG, rand f range, and then wait between, let's say, 1 and 2 seconds. Also make sure that you are waiting for the timeout of this node, meaning the player has to dodge these attacks for just a bit. Also, what we can do, once the attack timer times out, set a random value for these attacks, which means I want to get the attack timer and then update the wait time every single time this timer triggers, which we once again can do via RNG, rand f range. And let's go with a value between 4 seconds and 5.5. Also, I forgot, we want to switch between the range attack and the spin attack randomly. All we really need is if RNG rand I mod 2, and if that is the case, we want to play the range attack animation. If that is not the case, else, then we are playing the spin attack animation. With that, we don't need this comment anymore. And we should be getting 4 different animations. So let's try all of this. Once again, the boss is quite slow. And now we're getting the spin attack. That one is working pretty good. We have to wait a bit for him to stop. Then let's wait for the melee attacks. There's one. And let's hope we're getting the other one right away. We don't. There we go. This one is working. And there's just one more to test. That is the range attack, which we have to get a bit lucky for. So let's hope he does it now. And there we go. This worked really well. So with that, we have the boss animations. Now, obviously, the boss doesn't actually attack the player yet. That we are going to work on later. Before we get to that, I want to cover the other 2 enemies. Also, there's one more thing that I want to do for the boss right away. If you look at these animations, I suppose, let me go to the import and then look, for example, at one-hand melee attack slice and play it. It's a bit hard to see, but if we look from the front and play it again, the axe is really high and the player is only really here. Which means if the attack goes in a radius like this, the player is never going to get hit. To account for that, what you can do inside of the skeleton 3D, there we have the weapon for the boss, and this you can transform. And what I have done to keep it simple is simply increase the rotation X by a certain value, and that way the X is quite a bit lower. You could increase this value even more, but at some point it starts to look a bit silly. I think I went with a value of 30. That keeps the X nice and low. So if I now run the game again, we get an animation where the X is on the player height. And with that, we have the basics of the boss. Next up, we have the other 2 enemies. That part is going to be your exercise. Number 1, create a skeleton that walks towards the player and then attacks. Number 2, create a skeleton mage that stays further away and then casts a magic spell. For now, only play the spellcasting animation. The actual magic particle we are going to cover later. And for all of this, make sure to rely on inheritance, meaning you should be reusing the code we have written for the boss. Pause the video now and see how far you get. Back in Godot, I want to create a new inherited scene, or Control Shift and N. And then we want to create a new entity, enemy, and the parent scene should be enemy.tscn. Click on open, and then we have the same thing we have used for the boss. Although the name should be, let's start with the skeleton warrior. We want to look at the skeleton warrior folder, and in there we have this little guy. That's going to be our enemy. To use him, simply drag him into the scene, and then we have him ready. Besides that, we will also need a collision shape 3D. That can also be a capsule shape 3D that we have to move up by 1 meter. Like so. And then we have roughly the right shape. Doesn't need to be perfect. I think this is fine. Also, while we are here, with the character body 3D selected, the collision layers, just to double check, they still look good. We are on the enemies layer, and we can see layer 1, 2, 4. That's fine. Besides that, I really have to rename Skeleton Warrior to Skin, like we have done for the boss. And also, while we are here, I want to select Editable Children, and then get the animation player and move it into the animation tree. So with the animation tree selected, drag the animation player in there, and then we have that step covered. And before we start animating, I want to give this guy a sword. Or actually, if you go to weapons, there we have a bone. And this is what I would rather want to use. Like we have done before, give the skeleton another child node, which is going to be a bone attachment 3D. The bone name that we want to target is hand slot right. Once we have that, we can attach bone GLTF to it. And then this didn't work. I think if we save the scene to Skeleton Warrior and go in and out, now this is working. Sometimes these things can be a bit buggy. Usually, when you go inside and outside of the scene, it works again. Anyway, this is a good start, but I do want the bone to be a bit further this way, like so. And this didn't work perfectly. Let's do it like this. Much better. Once we have done all of the enemies, we're going to create proper weapons. So this part isn't too important yet, but I think it's important to have at least a basic idea. Anyway, with that, we have the actual model, and we can work with the animation tree. Which means next up, I want to create a new animation node blend tree. And to get started, I want to create a state machine that has to be renamed to move state machine. Simply because when we have worked with the boss enemy all the way at the top, we're getting the move state machine. And this one has to be called move state machine. For the Skeleton Warrior, we are going to reuse that line. For walking, let's go with walking B, and then we want to automatically go to the idle state and then be able to switch between idling and walking. Although this should not be automatic. Also, I want to rename these states to idle and walk. Once again, these names are important because inside of this move to player function, I want to travel inside of the move state machine to either walk or idle. And for that to work, the names have to line up. So that's a good start. Next up, with the Skeleton Warrior selected, I want to remove the enemy script. So click on the icon and then add a new script to it. Skeleton Warrior, that's totally fine. And now we want to extend the enemy class. Like we have done for the boss, I want to create a physical process function in which we want to move to the player and pass in delta time. Once we have that, inside of the level, I can add this Skeleton Warrior and make sure the file ending is .tscn. You do not want to add simply the Skeleton Warrior GLB model. That wouldn't do anything because it doesn't have a script. It's just a model. So make sure Skeleton Warrior tscn, open, and then you have this guy. If we now try to run the game, we have him walking towards the player. The animation doesn't work yet, but at the very least, we have some movement. And while we are testing all of this, let's get rid of the boss enemy. That's going to be distracting. Now let's try all of this again. And there we have an idle animation, and we have a short walking animation. So I think once again, you can tell what the problem here is. When we are importing the model for the skeleton, or the Skeleton Warrior, we have to make sure that we have for melee idle, a linear loop mode, and for, I think I've used walking B, but I'm not entirely sure. So let's set both to linear, then re-import. And now let's try all of this again. Now we have a walking animation, and we have an idling animation. Although they transition, or well, they don't have a transition. That is easy to fix inside of the Skeleton Warrior. When we are working with the animation tree in the state machine, there should be an exfade time of 0.2 in both directions. Next attempt. And that is looking much better. Awesome. Good start, but Godot is complaining that we have one debugger error, that we are trying to find an animation that doesn't exist. If you click on it, this is the line that's causing the problem. And that should make sense, because right now we are trying to get one animation node with the name attack animation. However, inside of the animation tree for the skeleton, this one doesn't exist. Fortunately, that we can fix quite easily. We want to add an animation that should be called attack animation. So attack animation, and we can give it any of these attack animations. Doesn't really matter which, just choose one that you like. I'm going to go with one-hand melee attack slice diagonal. This we want to play via a one-shot node. So we are connecting the in to the move state machine, the attack to the shot part, and then we're getting the same output. Also make sure that you have a blend time of 0.2 seconds or whatever you think looks good. This one doesn't work yet, but I do want to make sure that we don't have an angry debugger. And that is looking much better. Cool. So next up, we have to implement some kind of attack mechanic. Inside of the Skeleton Warrior script, we want to capture the attack timer. This one should auto start and it should not be one shot. For the wait time, we can experiment with this, although 1 second might be a bit very short. Let's go with 2.5 seconds. After that, I want to check for the timeout, and if that is the case, I want to attack. For this part, we want to check if position.distance to the player.position, if that value is smaller than the attack radius, then we want to trigger the one-shot attack, which we're getting via the animation tree.set. And I want to get the attack one shot, and this shouldn't be active, this should be request. For the argument that we want to pass into, we want to have a animation node one shot and then one shot request fire. And I believe for this part, the attack radius is quite a bit too large because the Skeleton Warrior is a lot smaller. So what we could be doing with the Skeleton Warrior selected in the inspector, the attack radius should be something like 1.5. But other than that, I think we're good to go. Let's try. And now we are close, and he attacks. And he should do it again. That looks really good. At this point, you could also customize the attacks simply by setting a different kind of attack animation, like we have done for the boss enemy. So you would pretty much do what you have done here, and that's all you really need. You could also work with a state machine. I hope at this point this isn't too difficult. I suppose one additional thing that we could be doing is randomize the timer just a bit, which means I want to get the attack timer and set the wait time to RNG and randf range, with a range between, let's say, 2.5 seconds and 3.5 seconds. And alright, with that, we have the Skeleton Warrior. Although I guess he would look a bit better having a shield, which we can add very easily. I want to add another child node, which should be a bone attachment. For this bone attachment, I want to target the hand slot left, which is up here. And then we can add inside of weapons the shield. Simply attach it as a child. And then we are, well, not quite good to go. This needs to be rotated just a bit. And move outside. And I think now it's completely inverted. Okay. Should be rotated like this. And that is a bit better. Let's try it in the game. But this is just a very minor detail. I think that looks about alright. And the attack animation should still work. And it does. Cool. That covers the Skeleton Warrior. Next up, I want to create another new inherited scene with enemy being the parent class. This is going to be the Skeleton Mage. This I want to save as Skeleton Mage, new scene, that's totally fine. And for the model, I want to use the Skeleton Mage. Simply drag it in there, and then we have the mage character. Just as before, you want to have editable children, have the animation tree selected, and then drag the animation player in there. Besides that, I want to add another child into the skeleton, bone attachment 3D, in which I target the hand slot right, and give him a magic wand, which is this one here. Once again, Godot is a bit weird, so I want to save the scene, go to another scene and come back, and now this is working. Next issue, the texture isn't applied by default, but we do have the texture inside of the same folder. So with the wand selected, have editable children, go to the wand mesh, and in there we have surface material override. Drag it in there, and then we're good to go. That covers the model. Next up, we can work on the animations. Actually, I forgot, we need to have a collision shape. Like we have done before, I want to have a capsule shape that is moved up by 1 meter. Like for the skeleton. The collision layers, just double check them, also look good. Now we can work on the animation tree. For this one, we want to have an animation blend tree, just as before. And now for this animation tree, I want to have a state machine that should be called move state machine. Besides that, I want to have a single animation called attack animation. And those two are connected via a one-shot node that is called attack one-shot. Then connect them to this node and get an output that is giving us something. For the move state machine, I want to create an add animation for, let's go once again with melee idle. And then for the walking animation, I want to have walking C. We want to automatically and immediately go to idle and then be able to travel between idle and walk. Also, rename all of this to idle and walk, like we have done for the skeleton warrior. For the attack animation, I want to go with somewhere further down, spellcast shoot. That almost finishes this. The last thing we need are the transition times of 0.2 for everything. Don't forget, inside of the move state machine, you want to have the same amount. Now that we have this part, we can give the skeleton mage a separate script. So delete the current script, add a new one, skeleton mage, empty, that's fine. And we want to inherit from enemy. Then we want to have a func physical process and move to player with delta time. That is a fairly good start. Now inside of the level, I want to add the skeleton mage.tscn, move him a bit further over here, and for now, get rid of the skeleton warrior. Let's see if this one is working so far. And we are getting the skeleton walking and idling, although once again, the animations need to be re-imported because at some point they stop. Also, the debugger is unhappy with us because we didn't rename the model to skin. That is easily fixed. Skeleton mage should be skin. Besides that, for the skeleton mage, double click on it, and we want to get walking C. This one should be linear. And we also want to import two-hand melee idle with the loop mode being linear. All right, next attempt. And now we have the skeleton walking towards the player. And that is working quite well. Although this skeleton shouldn't walk as close to the player as the skeleton warrior. You could change that by selecting the skeleton mage and then change the attack radius to something like n. That way, the skeleton stays a bit further back, so now he walks towards us and at some point he stops. And stays quite a bit further away. That looks pretty solid. And later on, if you want to add more skeleton mages, if you don't want to change this attack radius for every single instance, what you could be doing, once the scene is ready, so func_ready, we can set the attack radius to 10.0. I guess we could do the same thing for the skeleton warrior, so he gets actually close to the player. This one had a radius of 1.5. Nearly done. The last thing we are going to need is to check for the attack timer. For that, once again, I want to have a wait time of, let's say, 2 seconds. This one should auto start. And we want to look for the timeout. Connected to skeleton mage. If this one triggers, we want to do the same thing we have done for the skeleton. We want to trigger, if the player is in the attack radius, the animation tree. Attack one shot. And I guess we can also randomize the timer every time this triggers. Except for this one, we can have slightly lower times. I guess 2 seconds and 3 seconds is about right. Just play around with these values and see what looks good. That should actually be it. Let's try. And the mage is far away, and we have an attack animation. Sometimes it takes longer, sometimes it comes faster. That is working really well. All right, with that, we have covered the 3 enemies, and they are animated and can move towards the player. That is a really good start, although they can't actually do anything. Or in other words, they do have animations, but these animations don't actually interact with the player or with literally anything else. That part we're going to fix in the next section. Now that we have the player and the enemies, we can make the game interactive, meaning that attacking and getting hit aren't just animations. Also, while we are here, we can work on the player UI, although that's going to be a fairly minor part since this isn't a tutorial about user interfaces. Most importantly for this section, we need to detect if a weapon hit an entity. This you could do in 2 ways. Number 1, you can create a mesh around the weapon and use it with an area 3D to check if it collided with an enemy or the player. This would kind of work, but isn't ideal. For example, for the boss enemy, the axe is so large that it might always intersect a bit with the player. As a consequence, using an area 3D signal like on body entered might not trigger reliably. This is not an insurmountable problem, and you could use an area 3D, but I would rather use something else. And that is going to be number 2, ray casting, meaning we are casting a ray through the weapon and check if it collides with any kind of entity. Once that is the case, we're going to trigger some kind of hit function. For all of that to get started, back in Godot, I want to look at the player, and to be a bit more specific, the Godot skin. In there, at the moment, inside of the model, we have a sword or a wand. I only care about the sword at the moment, so let's hide the wand. That's not too important for now. So, this sword, if it collides with an enemy and we are attacking, should trigger a hit function. And to make all of this a bit more modular, I want to create a new scene. It's going to be a 3D scene. Let's call it sword. And to the scene, I want to add the weapons sword one-handed. So simply drag it in there. We have the sword. And don't forget to add the texture, which means editable children. Look at surface material override, drag the texture in there. And now the sword is looking really nice again. Perfect. Now that we have that, we can talk about the hit detection. And there are 2 ways you could approach this. The first way that you could be going with, that I talked about in the beginning, you have an area 3D, and to this area 3D, you have to add a collision shape. And that you can create quite easily by having the sword one-handed, so the mesh selected, and then go to the top and click on mesh. In there, you can create a collision shape along with a few other things. If you click on collision shape, then you can create either a sibling or a child. We want to create a sibling, and then the collision shape type. These different options give you different kinds of meshes. Depending on the complexity of your model, you might want to experiment, but I'm going to keep it at try mesh. If I now click on create, we have created a mesh. Let me hide the sword. There you can see the collision shape of the sword. And this we could simply drag into the area 3D. And now we have an area 3D that is perfectly aligned with the sword. Once you have that, you could use inside of the area 3D something like body entered, and if that is the case, then you trigger some kind of hit function. That would be one way, but not the one that I want to use. So I'm going to get rid of this area 3D and instead make the sword visible again and add a raycast 3D. And this right now doesn't really do anything, although if I zoom out a bit, you can see at the bottom we have a blue liney thing. That is the raycast. At the moment, it's pointing down, and if I hide the sword, you can see this a bit better. So a raycast is simply a line that goes from one point to another point. At the moment, we are starting at the origin point and go down by 1 meter. For the sword, I want to go up by 1 meter, make the sword visible again, and then line all of this up a bit better. So that the line starts, I guess here is fine, we don't really need the handle, and then we want to end up at the top of the sword. So let me expand this line a bit more until we reach the end of the sword, roughly here. And now we have a raycast along the middle of the sword. And this line can check if we're intersecting with an enemy. For that though, we have to make sure the collision mask is working. At the moment, this raycast is only looking at the terrain, which for our purposes is irrelevant. For the player sword, I only want to look at enemies. And then to actually use all of this, I want to give the sword a script. Oh, actually, before we are doing that, I have to save the sword scene, which means I want to go to Scenes, create a new folder called Weapons, and in there we have sword.tscn. That's much better. Now I can create a script in the same folder with all the default options. We don't need the ready function, but I do want to keep the process function, like so. To get the raycast collisions, I want to create a new variable. Let's call it target, or rather collider, I guess is better. Because we want to get the raycast 3d.get underscore collider. And for now, simply print the result. That way, if the raycast collides with any kind of enemy, we should be getting that enemy object. Although for that to work, inside of Godot's skin, we have to actually use that sword. Which means, with the right hand slot selected, I want to add sword.tscn. Also, while we're here, I can get rid of the original sword. We don't need that one anymore. And that is looking quite a bit better. Although I think while we are here, we also have to update inside of Godot's skin the animation for switching the weapon. Because this one should now be called simply sword instead of sword one hand 2. Let's try all of this. And I should still be able to switch the weapon, and I can't. This is happening because Godot cannot find the node, and I think the reason is we have to capitalize the S. So I want to get sword with capital S, next attempt, and now I can switch weapons again. Although we do have to modify the start options, but that we can do later. For now, we have the weapon selected. If you look at the output, we're getting object null, and that is because the raycast is not colliding with anything. But if I go to the enemy, there you can see we're getting character body 3D, meaning we are getting the enemy. Perfect. Two things you want to be careful about here though. Number one, when you're working with raycasting, you are only creating a single line. In our case, this line here. All of the other parts of the model, for example, these bits of the sword, are entirely irrelevant as far as hit detection is concerned. In practice, this doesn't really make that much of a difference. However, for the boss enemy, if you simply draw a line through the center, you are missing out these massive parts, which could become an issue, but for our purposes, I think it's still manageable, but something you want to keep in mind. That's the first important thing. We are only working with a single ray. The second part is a raycast doesn't really use signals. Instead, on every single frame, we are checking if there is a collision or not. And then we're getting an output. As a consequence, while using this system, it's really easy to trigger multiple collisions, or in our case, hit functions, something we are going to work on in just a second. First of all though, inside of Godot skin, I want to fix the switch weapon mechanic so that we are always starting with the sword. That we can do inside of the player. Once the scene is ready, let's do it all the way at the top. I want to make sure that weapon active is true when we are starting, and then func underscore ready. I want to make sure that we are getting the skin and calling switch underscore weapon. So once again, we're getting Godot skin, and then we are calling switch weapon, the method I have just shown, this one. And then we pass in weapon active in there. And now, once the game is starting, we always start with the sword. That feels a bit cleaner. Righty, next up. I don't always want this sword to be able to damage opponents. Instead, if I look at the animations, for example, for one-hand melee attack chop. And while I'm doing this, I'm going to disable the animation tree so I can actually show the animation. Right now, inside of the animation, we are getting a proper attack animation. And that is totally fine. However, if you look a bit more closely, a realistic system would be that we only can damage from this point, where Godot starts to swing the sword, up to this point where the swing finishes. As a consequence, if we are on these frames, or on these frames at the end, the sword should not be able to detect opponents. And for that system, I want to go to the sword and add one variable, var can underscore damage, which by default is going to be false, and this always needs to be a boolean. Then inside of process, we want to check if can damage, and only if that is the case, do we want to check for a collider. And besides that, inside of Godot's skin, I want to add another function, and for that, let me minimize everything so we can see a bit better what's going on. I want to have a function, let's call it can underscore damage, where we have one value, which is going to be a boolean. And via this function, inside of Godot's skin, we are getting the sword that we have just added, like so, and then we toggle can damage via the value. And that's basically it. So via this function, we set can damage, and then inside of the sword, we are only checking for a collider if this can damage is true. Now we have to figure out when to call this can damage function. That's going to happen inside of the animation player. With one hand melee attack chop selected, I want to go to where I think the damaging part should start, which I think is, let's say here. I want to go all the way down because we already call a function inside of Godot's skin. We can simply add another key to get can damage. And make sure that the one argument you pass in there is a boolean with a value true. If we then go a bit further to the end, let's say this point here is good. We want to add another key, can damage again, and this time it should be false. And that is basically it. Make sure you're activating the animation tree again, so we're getting all of the animations, and now we are only checking for a collider if we are attacking, and the collisions with the enemy still work just fine. Perfect. Although we have a first attack and a second attack, and the second attack doesn't really do anything right now. For that, we have to disable the animation tree again, go to animation player, the animations, and I think the second attack was one-hand melee attack slice diagonal. Actually, it was, I think, one-hand melee slice attack horizontal. And there, we have to check where the attack reasonably starts. I guess here is a good point. It's something you want to play around with. Godot basically attacks from this point forward, which means in there, a new key, can damage. The value for this can damage should be true. Then go forward a few frames, I guess to this point, that's where the swing ends, and add another key, can damage, and this one should be false. Finally, go back to the animation tree, and if you're getting this key, simply select the animation player and the animation tree. Now it should work again. Can be a bit annoying. But now, if we run all of this again, I can attack once, we check for the collider, and if I do it a second time, we're checking for it again. That way, we can always check if we are attacking and if there's a collider. Next up then, inside of the sword. If there's a collider and the object we are getting as a consequence has the hit function, then we want to call that hit function, which we can do in Godot fairly easily. We want to check if hit is in the collider, and if that is the case, collider.hit. Although unfortunately, at the moment, I believe for the enemy, we don't really have a hit function. As a consequence, let's add a hit function without any parameter, and this one shouldn't return anything. For now, let's simply print enemy was hit. Let's try all of this now. And if I attack the enemy, we're getting enemy was hit twice. And if I attack multiple times, we are getting at least something. Now, there are two problems. One attack still triggers enemy was hit multiple times. And also the debugger is really unhappy. We're getting in the sword script, parameter I is null. I think that's because this collider by default is null when we're not doing anything. And then checking for hit is a bit weird. So what we can do is first check if collider exists in the first place, and then we want to check if hit is inside of the collider. That should fix it. Also, we don't need delta time, so add an underscore here. And next attempt, this should fix at least something. Let's attack again, and we're getting enemy was hit without the debugger complaining. Perfect. The issue we now have to fix is that we only want to have enemy was hit once for every attack. And I think the best way to approach that is inside of the enemy. I want to add another timer, which I'm going to rename to invul timer. Effectively, after an enemy gets hit, we want this enemy to be invulnerable for a short amount of time. I suppose we could go with 0.8 seconds, and this should be one shot. After that, inside of the hit function, I want to check if the invul timer has time left. If that is the case, the enemy was recently hit, which means in our case, we want to check if not time left. If that is the case, I want to start the timer. So invul timer and start. And now this should actually work. If I attack the mage, we're getting enemy was hit. We can do it multiple times, multiple attacks. We only have a once get enemy was hit. And that is looking really good. And also here you can see the problem that an area 3D would have. At the moment, the sword is always touching the mage. And if we then try to do something like on body entered, it would not really work. Or at the very least, it would be inconsistent. Now that we have that, we simply have to indicate that an enemy was hit, and then we should have a very basic system. For that, I want to go to the player and recreate the squash and stretch that we have done earlier. I think it was on Godot skin actually. In there, we have squash and stretch, in which we simply squash and stretch the model, which is a fairly nice effect. This I want to reuse. For that, once again, I want to copy the function, and again, let me stress, this isn't ideal practice. In a perfect world, we would have one parent class for the player and for the enemies, and then reuse this code. To keep it simple, I'm going to copy it, and then we have to make some minor updates. Now we have squash and stretch with a default value of 1, and whenever we are changing this value, we want to update a couple of things. Oh well, most importantly, we want to update the scale of the skin, which in our case, we are getting via this skin. So all we have to do is skin.scale, and then this should already do something. Although for the actual effect, we have to go to player, and somewhere in there we have do squash and stretch, in which we are using a tween to update this value. This I also want to copy, and once again, not perfect practice, but for our purposes, good enough. And let me put it at the bottom. There we have do squash and stretch. This function we actually want to call. Instead of printing enemy was hit, I want to do squash and stretch with a value of 1.2 and a duration of 0.15 seconds. Then I can minimize these functions, and this should be working. Let's try. If I now attack the mage, we're getting an error. And that is because we are calling this tween property on skin, but it should be on self, because squash and stretch is inside of the same script. Next attempt. If I now attack the enemy multiple times, we're getting squash and stretch. That looks really good. Perfect. Also, since all of the enemies inherit this script, this should work with the other enemies as well. Meaning inside of the level, I want to add this skeleton warrior.tscn, move him a bit to the side, and then I also want to add the boss. I guess we can move him over here. If we now try all of that, this might be a bit hard to see, but if I attack this guy, it works, and if I attack the boss, it almost works. The issue for the boss is that we are scaling up the entire model. And then if we are calling squash and stretch, it has an end value of 1 for the scaling. As a consequence, the boss is getting much, much smaller. Obviously not ideal. For that, inside of the boss script, and let me expand all of this, I want to override the hit function. Although at the bottom, function hit. For this one, I do want to keep most of the hit logic, which means we want to check invol timer. I can just copy all of this, except now I don't want to do squash and stretch. Instead, I simply want to print boss was hit. Later on, when we are creating shaders, there's going to be another indicator that the boss was hit. Which means at the moment, we simply have a print statement if the boss was hit, but other than that, this is going to work. So boss was hit, and the other stuff still works perfectly fine. Cool. That covers the player attacking the enemies. Next up, we have to go the other way, that the boss enemy and the skeleton warrior can actually attack and hit the player. For the mage, this is going to work slightly differently, so we're going to ignore him for now. But for the skeleton warrior and the boss, the system is going to be fairly similar, meaning this could be an exercise. And it's going to be a bit of a larger one. Number 1, create another weapon, this time with a bone, for the skeleton, and then implement a similar attack logic that you have seen for the player just now. Meaning during the attack animation for the skeleton warrior, at some point for a couple of frames, this enemy can damage the player, and then if there's a raycast collider with the player, then the player should get hit. So effectively do what we have done for the player, for the skeleton warrior. For the boss, simply add a raycast node to the axe, and then implement this same logic again. Except now we are not going to have a separate weapon scene, all of this is going to happen inside of the boss scene. Also inside of the boss scene, try to get the damage logic for the spinning attack. This one can work a bit differently, but if this one gets too complex, it's totally fine to focus on the simple attacks. Anyway, pause the video now and see how far you get. Back in Godot, I want to create a scene very similar compared to this sword. For that, I want to create a new scene, 3D scene, and this one is going to be a bone. For that, we will need the weapons and simply drag bone GLTF in there, and this one already has the right texture applied, although a bit hard to see. Next up, I want to add a raycast 3D that should now still go upwards, but it should start a bit further down so that we get the whole size of the bone starting somewhere here and then going up to here. Then we want to save the entire thing in the weapons folder, click on save. And that's a good start, although first of all, inside of the skeleton warrior, I want to make sure that this is actually large enough. For that, we can deactivate the animation tree, go to skin, and get rid of the bone, and instead add the bone scene we have just created. So make sure this is bone.tscn, not gltf.glb. Then we have to update the position just a bit, something like here, a bit further up. I guess this is okay, like so, a bit further forward. I guess that's okay. Let's reactivate the animation. So animation 3, make sure the animation player isn't open, click on active, and now this is kind of working, although I do worry that the bone is very, very short. For the player, the raycast has a length of 1.4. For the bone, it's 0.8, which might mean that the skeleton warrior has a really hard time hitting the player. And well, for this part, you could simply increase this value and make it a bit easier for the skeleton to hit the player. Although in practice this might be unfair because it doesn't look like the skeleton actually hit us. So what we could do instead is to simply transform this bone via the scale and make sure it's not linked, and then increase Y, and I guess also X so it doesn't look too stretched out. And then move it up a bit so we have a slightly larger bone. I suppose for X and Y we can go with 1.25 and for X with 1.2. That way, this model still looks roughly the same, and for the raycast, we can get a much longer thing. Let's go with 1.1. Then we have to readjust the skeleton warrior. Actually, this still looks fine. And now the bone is quite a bit larger. That's a good start. With that, we can reactivate the animation tree. And then this looks all right. Next up, for the bone, I want to add a script in the same folder. Bone.gd is fine. And for this part, we can simply copy what we have done for the sword. So all of this is still perfectly fine. And once again, the sword and the bone could be combined into one scene, because effectively, we simply have to adjust the raycast size and the model. But I really wanted you guys to practice the entire system, hence why I didn't do it. It's a really minor part. Anyway, now we have can damage, and actually there's one thing I forgot. For the raycast for this skeleton, we have to adjust the collision mask. At the moment, we are only getting terrain, but this one should target the player. Now we can work inside of the skeleton warrior. And for the attack, we're using one-hand melee attack slice diagonal. So for this attack animation, we want to add a custom track, which we can't do at the moment. For that, we have to go to Characters, Skeleton Warrior GLB, and find one-hand melee attack slice diagonal. Make sure we are saving this to a file, and then we can save it inside of the Characters, Skeleton Warrior. I guess we can simply call this one the skeleton attack. Also make sure that you keep custom track enabled and then re-import the entire thing. Then Godot is going to load for a second, and now we have a custom track. To this, we want to add a call method track with skeleton warrior. And now, if we play the animation, we have to check where the actual damaging part is going to start. And for that, I want to zoom out just a bit. I guess here is the first point, and we go up to this point. Although before we can actually implement this, we have to add something to the script. That we are going to do inside of the skeleton warrior. I want to create another function, can underscore damage, with a value that needs to be a bool. We are going to return anything. All I really want to do is get the skin and then get the bone and set can damage to the value that we are getting. The same thing that we have seen for the player script. Once again, using more inheritance would be really good here, but it's a fairly minor point. Now, inside of the animation player, I have to disable the animation tree so we can see the animation. And then in the animation player, we want to work with one-hand slice diagonal, start here, which means I want to add a key. And now I cannot see the function. That is because I didn't save this script that we have just created. If you save it, do the same thing again, then you should be able to see can damage. There we go. The first value should be true, and then once we finish the entire thing roughly here, we want to add another key with can damage, and for this one the value should be false, which it is by default. And that should be it, although there's one thing, and well, we want to reanimate the animation tree. If you have any kind of filter on this one shot, which at the moment we don't have, but if you had, you really have to make sure at this point that you want to enable this function as well, or this function track to be a bit more specific. Otherwise, the function wouldn't be called, and you don't really know why, which is super annoying. Anyway, now if we look inside of the script for the player, I believe there already is a hit function in there somewhere. There we go. We're calling skin.hit and stop movement. Which means if I go to the level and get rid of the boss for now, that one's going to come later, run the entire thing, we should now be able to get hit by the enemy, and it's actually doing something. If he attacks, we are getting an animation. And this works multiple times. And if you look closely, the enemy barely hits us. So the bone is quite small. You might want to scale it up a bit further. But for my purposes, I think this is still fine. That covers the skeleton warrior, which means we can delete him. Next up, I want to add the boss again, because this one is going to be a bit more involved. Also, let me clean up the scene tabs a bit, getting quite messy. Right, I want to work inside of the boss. And first of all, we have to add the raycast. Now for that, you could put the axe into a separate scene and then do the same thing we have done before. So you add the raycast and the script and then re-add the entire scene instead of simply having the mesh. Would be possible, but in my case, I want to do something slightly different and simply add the raycast right now, which actually works just as well. Although we have to make sure that we are getting in the right direction for the raycast and go up to roughly here. And that's really all we need, although the collision mask should only target the player. Next up then, for the boss, we have two melee attacks, Slice and Spin, and those should only do damage at certain points. I guess the best way to approach that is if we look at the Naganfort character, Naganfort animated, we have two-hand melee attack Slice, and this one obviously should only start roughly at this point and then finish when we are here. Which means for this, we have to enable save to file and then save it in a custom track, graphics, characters, Naganfort, and boss underscore slice, I guess is a good name. Make sure you enable custom track. And next up, we have to look at spin. But this one is going to spin around once and then finishes. We only want to enable damaging roughly here and finish it here-ish. The same thing as before, enable save to file, and for the path, go to graphics, characters, Naganfort. I guess boss underscore spin works for this one. Click on save, keep custom track, and then we can re-import the entire thing. That is going to give us two new animations. That's looking good. Next up, when we have the animation player. And while doing this, I want to disable the animation tree so we can actually see what's going on. Oh, and also for this boss, we want to have a function can underscore damage. It should not return anything, but we do want to have a value that is going to be a bool. For now, let's simply add pass in here, because now we have to rethink our logic. For the player and the skeleton warrior, we kept inside of the weapon, for example, for the player, we had sword, a can damage variable. But for the boss, we can't really do that because the weapon is already inside of the script. So instead, at the top, I want to have a can damage toggle, which by default is going to be false. And inside of the function, can damage, we are setting it to the value that we are getting. And that's all we really need in here. Next up then, for the animations, I want to look first of all at two-hand melee attack slice. Look for a starting point. Let's go with this point. Add the track, call method, connect it to the boss, and then all the way at the bottom, we want to insert a key with can damage. At this point, it should be true. And if we go to the endpoint roughly here, we want to get the same function, although now it should be false. There you can see it a bit better. That looks good. Next up, two-hand melee attack spin, similar system, call method track, connected to the boss, and then check for the starting point. I guess that should be roughly here. Add the insert key, can damage. The value should be true. And then wait for the animation to finish. That one's a bit longer, so we can go, let's say here. And then can damage with false. Afterwards, make sure the animation tree is active again. And now for the boss, we know if he should be able to damage or not. Now to actually implement the attack logic, I want to have another function. Let's call it attack underscore logic. No need for custom parameters. This also shouldn't return anything. And in here, we want to check if can damage toggle is activated. And then we want to once again get the collider, which we're getting from the Raycast 3D. This is going to be a bit of a longer path, but in there we have a Raycast, so we can simply call get collider. Afterwards, you want to check if the collider has any kind of value at all, and then if it is in the collider. If that is the case, collider.hit. That's pretty much it. Last thing to do is we have to call attack logic, which is going to happen inside of the physics process. Although I guess a slightly better approach would be to call this one inside of the normal process, because this one gets called as many times as possible, while physics process gets called 60 times a second. Attack logic, and then if we go back to the level and run the entire thing, now the player should be able to get hit by the boss, at least in the melee attacks. So we have one, that one worked as well. If the boss is not attacking, we don't get hit, and this is looking really good. It's a bit hard to see, but there is this squash and stretch and hit animation. Next up then, for this spinning attack, and this is getting a bit hard to read. Let me minimize all of the functions so it's not so confusing. We now have an attack logic for the two melee attacks, but the one thing we haven't covered yet is the spin attack animation. This one works a bit differently because while this boss is spinning, we always want him to be able to damage the player, which effectively means once we set spinning to true, we also want to set the can damage toggle to true. And afterwards, when we get to on area 3D body entered, meaning we know that the boss is spinning from this if spinning, and we are close to the player, then we want to disable can damage toggle. So this one should be false. Now I guess in practice, you could combine spinning and can damage toggle, but it might be a bit confusing in terms of readability. So what you could do alternatively inside of this process, or well, in the attack logic, all the way at the bottom, you can check if damage toggle is active or if we are spinning. I think both would work. But anyway, let's try all of this, and we have to run away from the boss and wait for him to do the spinning attack. Okay, bad luck. Next attempt. I hope he does it now. Here we go. And we can get hit. And the rest still works perfectly fine. Cool. And with that, we have basically finished the animation part. Now, obviously, all of this could be expanded quite a bit. For example, for any of the enemies, let's say the skeleton warrior inside of the animation tree, you could play a hit animation every time this enemy gets hit. Or once we're running out of health later on, you could play a death animation and so on. All of those would be very simple one-shots, so I don't think I really have to cover it, and we have talked about animations for quite a while at this point. I think we are slowly ready to continue with other topics. Although you could add a few more nodes in here. For example, there's the blend 3 that can blend between 3 different states. If you understood the system so far, these shouldn't be too difficult to figure out. Which means, next up, let me save the skeleton warrior, and we can start working on the particles for the magic. So the mage, the boss, and the player can shoot a magic attack, which is later on going to be a fireball. But for now, it's simply going to be a sphere that moves in one direction. I want to create a new scene. For the parent node, I want to create an area 3D and rename this thing to fireball, which I want to save inside of scenes, and in there, let's create a folder for VFX. Not the perfect name, but we only have one projectile for the fireball, so having a whole folder for projectiles would be kind of overkill. And later on, the fireball is going to become kind of a special effecty kind of thing, so it's not terribly out of place. Anyway, save it somewhere, fireball.tscn, and now we have a new scene that I want to expand by adding a CSG sphere 3D, which is going to give us a sphere, and this sphere we want to move around. Also, if you don't like how choppy this thing is, you could change the radius segments and the rings. At the moment it's 12 and 6. If we set this, for example, to 24 and 12, this thing gets a lot rounder, and I think the rings change it quite a bit. Effectively, via those two options, we are adding more vertices, and that way we can get a smoother surface. A very small detail, later on this is going to be changed a bit. For now, it's really not too important. What is, however, important is that we are going to add a collision shape 3D, which for this shape has to be a sphere. Besides that, for the fireball, inside of the collision layers, we want this thing to be on the projectiles layer, and it can see the terrain, it can see the player, and it can see the enemies. With that, we have a solid start. Now we want to spawn this sphere when, for example, the player is performing a magic attack. Or in other words, inside of the game, with the magic one selected, I want to spawn a fireball roughly at this point. For that, first of all, I want to get the right point during the attack animation. And before we get to that, the debugger is unhappy with two parts where we are not using delta somewhere. That's inside of the boss, so add an underscore there. And then the parameter body on area 3D is never used, so an underscore there as well. And then Godot should be happy again. Perfect. Minor thing, so now let's start with the real part. Inside of the animation player. And while we're doing all of this, let's once again deactivate the animation tree, and let's look at the spellcasting animation that we are using is called spellcast shoot. And while we're doing this, let's make the wand visible and hide the sword. And now we have to figure out when and where to spawn this particle. When is going to be defined by the animation. I think that's a bit too late. So here. At around 0.3 seconds into the animation, I want to spawn that fireball. For that, I have to go all the way down and call a function. That function doesn't exist at the moment, so inside of Godot's skin, all the way at the bottom, I suppose we already have cast spell. So in there, we also have func shoot underscore fireball. No need for parameters, and we don't want to return anything. And for now, I simply want to print shoot fireball. This is the function that we want to call, which means inside of the animation, at the same time, on the same call method track, insert another key for shoot fireball. Let's try if this one is working. I need to have the one selected, and I forgot to turn on the animations again. Okay, so inside of the animation tree, we want to make this thing active again. Next attempt, we have the wand, I can attack, and we're shooting a fireball. That is working pretty well. Next up, we have to figure out from where to shoot that fireball. And for that, inside of the model, I want to get this point at the end of the wand. And for that, with the wand selected, I want to add a marker 3D that we want to move to the end of the wand, like so. Gonna be a bit hard to do while the animation is playing, so once again, disable the animation tree and then move the marker into the right spot. Can be a bit finicky to do, roughly here. It doesn't have to be perfect, it just needs to be good enough. There we go. Now we can re-enable the animation tree, like so. And that looks like a good point. After that, all we have to do is get this marker 3D for the wand and then get the global position. If we now run the code, I can attack, and we're getting a position. So let's try a few different ones, and that looks pretty good. That gives us all the basic info that we need, which means next up, inside of the level, I want to minimize all of the nodes and add another node 3D for the projectiles. To this node, we want to add all of the fireballs. And really important, these fireballs need to be inside of the level scene. That way they can interact very easily with everything else. As a consequence, when we are calling the function shoot fireball inside of the player skin, we have to go to the player and from there to the level to make sure we are spawning the fireballs inside of the level scene. For that, first of all, inside of the player, I want to add a signal for cast spell with quite a few different arguments. First of all, I want to have the type of spell that we want to cast, which needs to be a string. After that, we want to have a position. This one needs to be a vector 3. Next up, we want a direction. This is going to be a vector 2. And finally, I also want to be able to define the size of the fireball, which should be a float. This signal from the player, we now want to capture inside of the level. And for that, in the level, we have to attach a script. All of the default arguments are totally fine here. So create, and we don't need any of this. Instead, I want to go to entities, get the player, and inside of node, we now have cast spell that I want to connect to the level. That way, we can check if the player is doing something. And for now, I simply want to print shoot fireball in level. That way, we can cause some code inside of the level scene. But we have to figure out how to get from Godot's skin, and more specifically this shoot fireball function, to the player and emit this signal. There are a couple ways of doing it. You could create another signal inside of Godot's skin, and when this is triggered, we are emitting the signal from inside of the player itself. Alternatively, a simpler approach would be to simply get the parent. To demonstrate that this is working, let me print the result, run the entire thing again, and now, with the one selected, I can attack, and we're getting the player character, along with the debugger being really unhappy, but that we're going to fix in just a bit. The important thing is we have the player character. And on this player character, I want to call a function, let's also call it shoot fireball. I want to pass in the global position that we are getting from the model, and that's all we need from Godot's skin. Next up, we can work inside of the player, and then create all the way at the bottom function shoot fireball with one parameter, the position, which needs to be a vector 3. We don't want to return anything, and then in there we want to get the cast spell signal and emit it, for which we're going to need a whole bunch of arguments. So let me copy all of this. The type is for now going to be a fireball. The position is what we are getting from the parameter. The direction is going to be the starting direction of the player. If you look at the model, by default, we are pointing down this direction, which I believe is -z, but you can test it quite easily. With the rig selected, you can go to transform and then change the position. So if we increase that, we are going in this direction, which means the default starting position is +z, although this value by default should be 0. As a consequence, for the direction, I want a vector 2, where we have x and z values. Because once again, we don't really care about up and down. The fireball can only go on the horizontal plane. X is going to be 0, and z is going to be 1. Finally, for the size, to get started, 1.0. After that, We have the level, and let's simply try if this is working. Now we should be getting shoot fireball in level. That looks really good. Perfect. That means now we have all the information to spawn a fireball via GD script. First of all, for that, we will need the variable fireball underscore scene, which needs to be a packed scene. To get that one, I want to preload fireball.tscn. Afterwards, inside of the level, I want to create a var fireball via the fireball scene and instantiate. Afterwards, we want to get the projectiles, and with level selected, we want to add the fireball to this projectiles node 3D. So projectiles.add child fireball. Besides that, I want to get the fireball and the global underscore position and set it to the position that we're getting from the parameters. That should already do something. If I now run the code again, we're getting the wand, and we are getting one instance of the fireball. That is looking pretty solid. To make the fireball move, inside of the fireball, I want to add a script. All the defaults here are totally fine, and we want to work with the process function. Although before that, I want to create a variable direction, which is going to be a vector2. I guess what we can also do is define a speed. Bar speed, I went with 5.0. And this could actually be a const. I don't really care about it. Now you could make this value interactive and, for example, set a different value for the enemies, for the bosses, for the player, and so on. For that, you would simply have to emit another argument when you're casting the spell. But that's such a minor point, I don't really care about it. Anyway, after that, inside of process, I want to update the position and then go plus equal. This has to be a vector 3 because we have x, y, and z, although y is going to be 0. For x, we want direction.x, and for z, we want direction.y. Also, this we want to multiply with the speed, and don't forget to multiply with delta time as well. This we didn't have to do for the player because move and slide already accounts for it. But by simply updating the position, you don't get that. So you always have to add delta to be frame rate independent. After that, inside of the level script, I want to get the fireball once again and update the direction and set it to the direction we're getting from the parameters. That's not going to work perfectly yet, although if I shoot, this is working, but if I move around and shoot again, all of the fireballs move in the same direction. They're always going this way, which is fine if we don't move, but if we have changed the direction, this is not going to work anymore. This needs to be updated inside of the player, although first of all, I want to get rid of the boss enemy because he's getting a bit annoying. Inside of the player, when we are shooting the fireball, at the moment, we are always shooting in this direction, which doesn't work anymore. Instead, at the top, I suppose we can do it below movement input. I want to have var last movement input, which by default is going to be the value we have used down here. I want to replace this one with last movement input. Also, this always needs to be a vector2. Once we have that, we have to make sure once the player is moving around and more importantly rotating, then this last movement input needs to be updated, which is going to happen inside of move logic. Effectively, all that we have to do at the bottom of the function is check if we have currently movement input. If that is the case, the last movement input is going to be the movement input that we currently have. An important thing to consider here, the reason why we need a system like this is when the player is moving, then we are getting the movement input, and this is going to give us the direction. So for example, from this value, we're getting the target angle. But this only works if the player is moving. If the player stops, then this value will become 0. Or rather, a vector with two 0 values. which for a direction would be entirely useless. So we only want to update this value if the movement input is different from 0. But that should basically be it. If I now run all of this again, I can go with the wand, this direction, shoot this direction. That looks pretty good. I can also try to hit the skeleton, and that did work, although it didn't actually do anything. But the basic system is working. And I think at this point, I should go over what happened here, because we have quite a few moving parts. First of all, we have a very simple fireball scene that doesn't really do very much. It's a simple area 3D that is moving in a direction. Not much is happening here. This we're using inside of the level scene. In there, we have a projectiles node 3D, then we are creating a packed scene, and when we are getting a signal from the player, we are creating one instance of that scene. This cast spell is emitted from inside of the player. In there, we have cast spell, and this cast spell is emitted by this shoot fireball function. This shoot fireball function, in turn, is triggered by Godot's skin. In there, we have a function that pretty much controls the parent. And this function, we are calling from inside of the animation player. Let me go to Godot's skin and animation player. Inside of spellcast shoot, when we are at the right frame, we are triggering shoot fireball, which then starts the entire process. Next up, to make the fireball actually do something, I want to add a body entered signal, add it to the fireball, and then check if hit in body, and if that's the case, body dot hit. Also, to make sure we're getting rid of the fireball, Q3. That should already trigger something. If I now shoot at the mage and hit him, this worked. Perfect. Now, all of this doesn't look too impressive at the moment because we don't really have special effects. That we're going to work on later. For now, I just want to have the basics in place, which means next up, I want to add the particle magic attack to the skeleton mage and to the boss when he does his ranged attack, or in other words, when we are calling this ranged attack animation. That part is going to be your exercise. Or in other words, like you have seen for the player, make the boss and the mage emit the sphere when they are doing the ranged attack. Pause the video now and try to figure this one out on your own. Let's start with the skeleton mage. In there, we want to look at the animation player inside of the skin. And we are using, let me find it, spellcast shoot. And at the moment, this one can't have a custom track because we didn't save the animation. And let me double check that this is actually the animation we are using. So inside of the animation tree, we are using spellcast shoot. Which means inside of skeleton mage, I want to double click on the import scene. We don't need the rig. That I want to look at spellcast shoot. We want to enable save the file. Then select the path, which is going to be inside of graphics, characters, and skeleton mage. And let's call it mage spell cast. Click on save, and then keep custom track. This one should be enabled. Now we can re-import the entire thing, go to the animation player, and then once again, go to spellcast shoot. Now we can add a track. And since this is the animation we have already seen, we know that we want to go to second 0.333. Although before we get to that, I want to add the marker 3D to the wand. And while we are doing that, let me disable the animation tree. And then with the wand to select it, add a marker 3D. And then position it to the tip of the wand. Roughly here, and make sure you are actually getting the tip of the wand. Make sure to rotate around quite a bit. This can be a very easy point to miss. I think that's all right. Once again, it doesn't have to be perfect, but in your own game, if you want to publish it, do spend a bit more time on this. Once we have that, I can re-enable the animation tree, so we have the animations. And now we can work inside of the script. For that, I want to create the same signal that we have seen for the player. In there, we have a cast spell signal with a whole bunch of parameters. This we want to have inside of the mage as well, and then create a function to shoot the fireball. This one doesn't need any custom parameters, and we don't want to return anything. All we really want to do in here is get cast spell and emit the signal. The type is going to be a fireball. The position we are getting from the marker 3D, so let me pass that in there. And don't forget, we want to have the global position of this marker. For the direction, just to get started, let's add a vector 2 dot right. And finally, for the size, 1.0. This is not going to work perfectly, especially for the direction, but I just want to have the basic setup. Because next up, I want to work inside of the level. And at the moment, we have a single mage that now has cast spell, which we could connect to the level scene right away, like we have done for the player. But that would be kind of annoying because later on, for an actual level, we want to have multiple mages. So for example, we could have 5 of these guys, and then connecting every single scene manually would be a nightmare. So this is not what I want to do. Instead, all of this I want to do automatically, which we can do fairly easily once the scene is ready. So func_ready. I want to look at all of the entities. So for entity in the node entities and get children. Now I want to check for every single entity if this entity has the cast spell signal, which we can do with entity.hasSignal. This one wants to have the signal name as a string cast_spell. Just to test if this is working, let's print the result and then add the boss back to the level scene because this one doesn't have the signal right now. And we should be getting true, true, and false. And we do. Perfect. That means we can remove the boss and turn this print statement into an if statement. If an entity has the signal cast spell, then we want to get entity and connect this signal, where we have the name of the signal, which in our case is cast spell. And afterwards, we need a function to call. Let's call this one create fireball. That function doesn't exist at the moment, so we want to func create _fireball. And I suppose for now, we simply want to print shoot fireball. And now that we have that, we can also comment out the stuff we have done for the player, because this one is going to be covered by this create fireball function as well. And while we are here, we want to disconnect the manual signal, like so. It's going to be connected anyway, but let's try all of this first of all. So once again, I can shoot, and we're getting a debugger error. Let's see what the problem is. When you are looking at the debugger and hover over it, we are calling cast spell, and the method expected 0 arguments, but we have given it 4. That is an easy thing to fix because all we have to do inside of create fireball, we have to get these 4 parameters, get them in there. And now if we try the entire thing again, I can shoot a fireball and we are printing shoot fireball. The debugger gives us a warning, but that's fine. Now the mage is not going to do anything besides the animation. And that is because when we are going to the skeleton mage and look at the animation player, or the animation specifically, for spellcast shoot, we haven't added the actual track yet to call inside of skeleton mage this shoot fireball function. But that's super easily added. Let me zoom in just a bit. I want to go to second 0.333, then add a call method track with the skeleton mage. And on this track, I want to insert a key with shoot fireball. Now let's try all of this again. And if I walk to the mage, we should get printed shoot fireball. And that works. Even works multiple times, that's a good sign. Which means at this point, we have to recreate what we have done for the player. In fact, I can uncomment it, cut it out, and then paste it inside of create fireball. Like so, make sure the indentations work, and then this should all reasonably work. The two important parameters for now are position and direction. Let's see if they do anything. So inside of the player, I can shoot the fireball. That looks good. And the mage can also shoot, although those magic effects always go in one direction. But we definitely made a start. Inside of the skeleton mage, when we have set the direction, we always go with vector right, which obviously isn't going to be correct. For the actual value, let's create another variable and call it direction. We want to get the player.position minus the position of the skeleton mage itself. The entire thing we then want to normalize, and then we have the proper direction. Let me paste it in there. That should work. Also for the position, I think this is very hard to read, so let's put it inside of a separate variable as well. Var position is going to be all of this, and then we are simply getting the position here. Now all of this is actually readable. Next attempt, and the player still works just fine. That looks good. And now for the mage, we're getting an error. That normalize is not part of a vector 3. I think it's called normalized. Let's try all of this again. And now the mage still can't shoot. And we're getting another error, so let's have a look. The debugger is complaining that we cannot convert a vector 3 to a vector 2. And that is because this direction is a vector 3, but inside of the level, for the direction, we want to have a vector 2. I suppose the easiest way of doing this would be another variable, direction 2d, which is going to be a vector 2 with direction.x and direction.z. And this direction 2d is what I actually want to use for the direction. Let's try all of this again, and now I'm confident this is going to work. If the mage attacks, we're getting the fireball, and this one can also hit the player. If the player attacks, we are getting a very slow fireball that we have to work on, but fireball can still hit the mage. So that is looking really good. Nearly done with this part. I think the one part that we have to do inside of the player, when we are assigning inside of move logic, the last movement input. We want to get the movement input, and this one should also be normalized. Otherwise, if we're moving very slowly, this value is going to become lower than 1. As a consequence, the speed would be very, very slow. Just to test this, if I now shoot and walk just a bit, we always get the same fireball speed. So that's much better. With that, we have the fireball effect for the skeleton mage, and also inside of the level, we can simply copy this little guy. So let me create a few more instances, and they should all work as well. Let's try. And they all have the same animation. They can all shoot, and that is actually working. Perfect. And I guess before we continue, the fireball right now is a bit boring. So on the sphere mesh, I want to create a material, standard material, and for this thing, we can set an albedo color with red-ish. Let's go with something like this. That looks at least a little bit better. Although much more importantly, inside of the level, I only want to have one mage, and I want to have the boss, because the boss is also able to cast a range attack. For that, inside of the code, we can delete this one line for the player's signal, and we can look at the boss when he does his range attack animation. If that is the case, we are triggering one function. We can find that inside of the simple range dictionary all the way at the top. we are calling one-hand melee attack stab. So for this animation, we need a custom track. Once again, inside of the characters, we want to go to Naganford animated and then go to one-hand melee attack stab. We want to save the file, get a path inside of graphics, characters, Naganford. There we have, let's call it boss range. Then enable custom track, re-import the entire thing. And now when we are looking at the boss and go to the animation player down here, we can go to one-hand melee attack step and add a custom call method track, which should connect to the parent node. After that, below the range attack animation, I want to create a function shoot underscore fireball. No need for parameters, and we don't want to return anything. And now, once again, we have to figure out from where to shoot the fireball and when to shoot the fireball. The where is fairly easy. We simply have to add a marker 3D to the end of the X. Right below the raycast, as a sibling, I want to add a marker 3D. And this we have to align. That become a bit difficult. Trying to do this without pausing the animation, so we're not spending too much time on this. I guess that looks okay. That is going to give us the position. Next up, when to emit this thing, I guess we have to stop the animation. So let's stop the animation, and then for one-hand melee attack step, we're getting the full animation. And I guess right at the end of the thrust, so here, we can call the method. Insert a key, and I want to shoot a fireball. I can't see the function right now. If that is the case, simply save the script, and then it should appear. Right now, Godot is complaining because we have no content inside of the function, which it doesn't like. If I now save the entire thing, insert a key, it should now work. And there we have shoot fireball. That's all we need in there. And now, for shoot fireball, we want to emit the signal like we have done for the skeleton mage, along with all of the other stuff. So what we can do is put this signal into the parent class. I simply want to cut it out and then go to enemy. In there, we want to have the signal cast spell. Since we are calling the function from the animation player, I do want to keep it. So let me simply copy the code here and paste it into shoot fireball for the boss. This could also be handled via inheritance, but I'm trying to keep it a bit more streamlined. And the issue we have here is that we need to get another argument for the position. For this marker 3D, we want to get the marker 3D for Naganford. Let me expand all of this. Everything else should still be totally fine. Let's go back to the level scene and get rid of the mage so we can focus on the boss. And if we now run the game, the boss is not animating. For that, I want to activate the animation tree again, run the entire thing, and now we have to wait for a range attack. Let's hope we get lucky. And there we get a range attack, and this didn't do anything. Something went wrong. And the reason in my case is for shoot fireball, when I added it to the animation player earlier, for some reason Godot didn't keep the keyframe. It's strange. I might have deleted it accidentally. So once again, on this point, I want to add a key with shoot fireball, and now save the entire scene and hope this is working now. I suppose while we are testing things, for the attack logic, or on attack timer timeout, we have a range attack and a spin attack animation. For now, I'm going to copy the range attack animation and then play it instead of the spin attack. So we always get a range attack if the player is far enough away. And now we have a range attack that goes towards the player, and this should also work multiple times. That looks pretty good. And while we are here as well, we can start using the size of the fireball. Inside of the level, when we are creating the fireball, we are adding in a size. And for basically all entities, this should be a value of 1. But for the boss, it should be much larger. Or in other words, when we are doing shoot fireball, we don't want to have a size of 1, we want to have a size of 3.0. After that, inside of the level, I want to get the fireball another time and then run a setup function with this size. This function doesn't exist at the moment, so inside of fireball, I want to create a function setup with a size that's going to be a float. We don't want to return anything. And all we really want to do in here is var tween create tween and then tween property. We want to target self. The property we want to target is going to be scale. For the final value, I want to use the size, but the size right now is a floating point value. And since scale is a vector free, we have to change this value. One way of doing that is simply get a vector free.1 and then multiply it with the size. Finally, we will need a duration, and I want to go with 0.5 seconds. Besides that, once the scene is ready, which means func_ready, I want to set the scale to vector 3, 0.1, 0.1, and 0.1. So the starting value is going to be really small. Once we have that, I can run this scene again, shoot the fireball from the player, and it starts to grow. That looks pretty good. And for the boss, this thing gets much larger. And the hit function still works just fine. With that, we have covered all of the fireballs. Later on, for the dungeon level, we are going to create a few more fireballs from the level. But for that, we simply have to connect a signal from somewhere, and then we are good to go. Cool. That means next up, we can work on the player UI, so the interactions are actually visible. In practice, this means I want to display the player health, the player energy, this spell the player has, we are only going to have 2, and finally, I want to display the player stamina. Once we have all of that in place, we can implement things like the player dying or a monster disappearing once it runs out of health. Here we are back in Godot, and I want to first of all close a whole bunch of scenes because we don't need any of the 3D models for now. And the entire thing started to get a bit messy. All I've open is level and player. That being said, I want to create a new scene, which is going to be a user interface that I'm going to rename to UI. This I want to save inside of scenes, and I guess we can put it inside of entities and player. In there, we have to create the various systems, and I suppose the most important one is going to be the health. This I want to store inside of a separate control node that I'm going to call arts. In the most basic sense, I want to create a margin container and then an hbox container. Via the hbox container, we are getting a bit of an offset from the top left, so that all of the hearts can be roughly in this position, with a bit of space to the top and to the left. The horizontal arrangement of the hearts, meaning they're going from left to right, is what we're getting from the hbox container. Or in other words, inside of the hbox container, I want to add a texture rectangle. And for the graphics, I want to look at graphics. There we have UI, and in there we have heart. This I want to use for the texture, place it in there, and then we get something. So let me zoom out a bit. We have one texture, and if we multiply it, then these are arranged from left to right because of this hbox container. And because of the margin container, we can go to theme override, constants, and then set a margin for the left side and the top side. I went with 10 pixels each, but it's fairly subjective. Just choose what you think looks good. This would be the starting point. And this UI scene, I want to add to the player. So another scene, UI. And now if we run the entire thing, we are getting something, although the hearts are a little bit large. For that, let me get rid of these two. And for the one heart we have, for the expand mode, we want to fit the width. And then for scale, we want to keep the aspect ratio. That looks much better. If I now duplicate the node again, this is looking significantly better. Perfect. That is a really good start, but these hearts should be more animated. Or in other words, I want to create some kind of system that these hearts can appear and disappear with a bit of an effect. And for that, I want to create another scene, which is going to be a texture rectangle, which I am going to rename to art, and then save the entire scene inside of the player folder. So save. And then for this node, the texture is going to be the heart, and for the expand mode, we want fit width, and for the stretch mode, keep aspect ratio. With that system, I can get rid of these texture rectangles inside of the UI, and then instead add one heart with the same result. Although now we can add a bit more logic to the heart and make it look nicer. For that, I am going to use a shader, a really simple one. In case you have never used a shader, I made a few videos to cover the basics on my second channel a while back. Check this one out if you are lost. I want to go to Material, then click on New Shader Material, click on it again. For the shader, I want to have a new shader. I want to have a text-based shader with canvas item, and the name can be heart.gd shader. That's totally fine. Click on Create, and now if you click on this again, we are getting some shader code. I do not want to influence the vertices at all, and I don't need the light stuff. Besides that, I want to create a uniform vector free for the color, and this can be a source color with a default value of vector free with 1.0, or in other words, a pure white color. Besides that, I want to have a uniform float progress, which is going to be a floating point value with a range of 0 to 1. The default value is going to be 0.0. And let me give a bit more space to this thing so we can see what's going on. Finally, I want to have a uniform float for the alpha value, which is also going to be a hint range from 0 to 1 with a default value of 1.0. With these variables in place, if you look at shader parameters, we have a color, progress, and alpha. The color we could change, although I do want to keep it white. For the actual code, I want to make it so that when I change this color, it changes this heart. And if I change the alpha slider, it changes the alpha value of the texture. For that, first of all, I want to create a vector4 variable with the current texture color. This I'm getting from the texture with the texture in capital letters and then the UV parameters. This is going to give me the color of every single pixel of this graphic. And this I want to use to update color.rgb. Effectively, I want to mix our texture color.rgb with the color we're getting from the uniform. And the amount we're getting from the color is determined by the progress variable. That is all we need for this part. If I now increase progress, the heart becomes whiter, and if I change the color, we are using that color. So with that system, we can change the color of the heart quite easily. Besides that, for the alpha value, I want to update color.a and get the alpha value multiplied with the texture underscore color.alpha. That way, we are multiplying this alpha value with the current alpha value of the color, and then we are getting the result. The other color also works, so this is a nice system to update the heart. That covers this shader, and to control it, I want to give the heart a bit of GD script. The default values for all of this are totally fine, create, and we don't need any of the default stuff. Instead, I want to create a function called change alpha, where we are setting some kind of target value, which should be a floating point. This is not going to return anything. All we want to do in here is create a tween via create tween, and then this tween is going to call a method underscore change alpha. After that, we need a start value and a target value. The start value is going to be 1.0 minus our target, and our target is going to be the target parameter. Finally, we need a duration, 0.4 seconds, I think is totally fine. Now Godot is going to complain that the function doesn't exist, so function underscore change underscore alpha. This function needs to have one parameter, which I usually call value, and this has to be a floating point value. And this has to be a float. Also, we don't want to return anything. All I want to do in here is get the material of the node and then set shader parameter. The shader I want to target, first of all, is the alpha value, and for this one, I want to get the value from the parameters. Then I can duplicate all of this and update the progress to be the exact opposite, so 1.0 minus the value. And I hope I didn't go too fast. In the most basic sense, via the change alpha function, if we add a target of 1 in here, then our start value is going to be 1.0 minus 1, so 0, and our target will be 1. If our target is a 0, then this value is going to be 1, and our target will be 0. These values we are then using to influence the shader that we have created earlier to mostly update the alpha value, and for the progress, we are always doing the opposite. You can see the result down here in the shader. Alpha and progress are effectively inverted. The lower alpha becomes, the greater the progress becomes. Which effectively means the less alpha we have, the wider the heart is going to become. I hope all of that isn't too confusing. I think once we start using it, it's gonna make a bit more sense. For that, inside of UI, I want to add a script with UI, and first of all, get rid of all the default stuff. Once the scene is ready, I want to create var heart container, which is going to be the box container that we have just created. So it's a bit easier to access the entire thing. Also, the one heart scene that we currently have in there, I want to delete, because all of this should be controlled via GD script. But to make sure we still have it available, I want to create another variable, heart underscore scene, which needs to be a packed scene, and this we are getting via preload with heart.tscn. With that, we have the heart container and the heart scene, so we can actually interact with them. Once the game is ready, I want to run a func setup to set up all of the hearts. For that, I need to know how many hearts the player has, which is going to be value integer, and this function isn't going to return anything. And then we can work on the actual function. Although for now, let me add pass in here, so Godot doesn't complain, and then work inside of player.gd and give the player some health, which I'm going to put below weapon active, var health, with a default value of 5. Also, while we are here, once the scene is ready, I want to have the UI node quite accessible, so var UI is going to be the player UI node. Arguably, this doesn't make too much of a change, but I think it's a bit cleaner. Anyway, now that we have that, once the player scene is ready, we are calling UI.setup with the player health. And then we can work inside of UI.gd script and create one heart for every single health point, which is going to be for I in value, then var heart is going to be the heart scene dot instantiate. This is going to create a new instance of a heart scene, and this we want to add to the heart container, which means heart container add child with the heart. Let's see if this is working. That looks good. Inside of the game, we have 5 hearts. And because of the shader, we can now simply call heart.change underscore alpha with a value of 1.0. And then all of these hearts are getting animated in, which you can make look even nicer if you add a bit of a timed offset. For that, you want to wait for a timer, which you can create with get tree and create underscore timer. Let's say with a value of 0.3, and we want to wait for the timeout signal. If I now run all of this, we are getting almost the right thing. Let me play it again. You want to look at the top left. The hearts are being animated, but they look a bit weird. That is because for the heart shader, we are running the shader on every single instance of the scene simultaneously, but we want this shader to be local to the scene. That way, if I run the entire thing again, now this looks much cleaner. And perfect. With that, we can get some hearts. So next up, we can add another function for update underscore health. For that, I want to have a value, meaning how many hearts we want to have, and I want to have a direction, which also needs to be an integer. This parameter is going to tell us if you want to add or remove a heart. Effectively in here, once the player health changes, or more specifically, when we are calling update health, we want to first of all remove all of the heart instances and then create new hearts depending on the player health. So first of all, we want to remove all hearts. For child in heart container.get children and then child.q3. To make sure this is working okay, we have to call it from inside of the player. And the easiest way to make all of this work, inside of the player health, I want to attach a set functionality with the value. That way, every time the player health changes, we can run some code. Like for example, we have done for defend. If the player health changes, I want to get UI and update underscore health. The target value is going to be the new value, and the direction is going to be the new value minus the health the player had before. Imagine the player gets hit, and a health of 5 becomes a health of 4. Then the value we are passing into update health is going to be 4, and the direction is going to be 4 minus 5, or in other words, -1. From that, we know that we want to animate the hearts in such a way that one heart disappears. That's basically it. Besides that, make sure that you're also setting the health to the actual value, so the variable actually updates. Finally, inside of the hit function for the player, we want to reduce the health by 1, so minus equal 1. And now, if I run the game and the player gets hit, all of the hearts should disappear. So we have to wait for the boss, and now all the hearts have disappeared. Perfect. And just to get the basic logic back in place, we could simply copy this for loop with the first 2 lines, and then recreate all of the hearts. This should already work. If I run the game again and wait for the boss, we get hit, and now we are losing more than 1 heart. That is because inside of the player, we need an invol timer like we had for the enemies. Although this I want to store inside of a separate node, this should be called timers, and in there we want to have a timer called invol timer. The wait time for this timer is going to be 0.8, I think, and this should be one shot. Once we have that, inside of the hit function, I want to check if not invol timer.time left. And if that is not the case, only then do I want to run all of this. And also I want to start the timer. Invol timer.start. When the player gets hit, we are checking if the invol timer is running or not. If the timer is running, then the player should be invulnerable. If this time, however, is 0, then we want to run all of this and start a timer. With that system, the boss shouldn't be able to hit the player multiple times in one attack. So there the boss comes again, and if he now attacks us, we're only losing 1 heart, and now we're losing a second one. That looks much better. Let's try this again, and this looks really good. Final attempt, single attack, perfect. That means we can keep on working on the health logic and make this look a bit nicer. First of all, I want to check if direction is smaller than 0. If that is the case, I still want to do this for loop and create new hearts. So let me simply indent it. And as a reminder, if direction is negative, we want to lose a heart. And as a consequence, we want to have all of the current hearts for the target value. But on top of that, I want to create a var extra heart, which is simply going to be the heart scene.instantiate. This we also want to add to the heart container. So heart container add underscore child with the extra heart. And the only difference that we really want to make is that this extra heart is going to call the change alpha method. Although now with a target value of 0.0. Effectively now, we are creating the target amount of hearts plus one extra heart. And this heart becomes invisible over a certain duration. That way, the player can only see the actual hearts that we want to see. If I now run the entire thing again, if the boss hits us, we're getting a nice animation of the heart disappearing. And this should work multiple times. That looks really good. For the other direction, I want to check an else statement. And in there, for I in value -1, we are creating all of the hearts -1. And then I guess we can copy these two lines and then create an extra heart like we have done in those lines outside of the for loop. So here, and this heart should become visible. Or in other words, if we want to add a heart, or if the direction is positive, then we are creating all of the hearts -1, and we're animating a final extra heart and go from an alpha value of 0 to 1. That way one heart will slowly become visible. That part we can't really test right now because the player doesn't have the heal spell yet. I suppose that's the next part we can work on. And while we're doing that, inside of the level, I want to get rid of the boss, so things are a bit less stressful. Also, we have finished the hearts part. We can now minimize the hearts control node. Next up, I want to add another control node that I have renamed to spells. Like we have done for the hearts, I want to add a margin container, and then I want to have a texture rectangle. And let me zoom out just a bit so we can see the entire viewport. The spells should be in this bottom left corner, for which I want to target the spells, then go to the top left part and click this bottom left anchor. Then we are in the bottom left. For the margin container, I want to go to theme override, constants, and then set a margin for the left side and the bottom. I went for these values with 15 and 15. Finally then, for the texture rectangle, I either want to display fire.png or heal.png. For now, let's go with fire.png. And this is much too large. So once again, I want to fit the width and keep the aspect ratio. That should look much better if I now run the game. In the bottom left, we have a small icon that indicates what spell we are currently using. To make this animatable, back inside of the code for UI, I want to create another function for update underscore spell. For that function, I want to know what spells the player has and what the current spell is. Now, this we can't really use at the moment, so let me add pass in here, because inside of the player, we don't really have spells. Instead, we only have shoot fireball, which means this system has to become a bit more flexible for the player. And let me add double spaces to everything, so this looks a bit more organized. To give the player a couple of spells, I want to use enums, which means enum and spells. Then, with curly brackets, you can define the name of spells. I have Fireball and Heal. Those are the only two spells the player is going to have. And then I want to have a variable with the current underscore spell, and this will be spells.fireball by default. And I hope you know what enums are at this point. Effectively, this is going to create a dictionary. Or in other words, if inside of underscore ready, I am printing the spells, then I can run the entire thing, and we are getting a dictionary with Fireball getting an ID of 0 and Heal getting an ID of 1. That's all that's happening in here, which effectively means that our current spell has an ID of 0. Let me print this one as well. Print current spell, and then we have 0. So this is really all that's happening in here. Now, this system we are going to use, first of all, inside of ability logic. There we have the attack, defend, and switch weapon and magic, although at the moment we are only switching the weapon. Which means next up, I want to also switch the magic. Which we're doing with if input is action just pressed, and in there we have switch spell. And I suppose we also want to add and dot skin dot attacking, like we have done for switch weapon, although this part isn't too important. If this is pressed, we want to update the current spell. For that, I want to get all of the spells that the player has. And remember, this is a dictionary with the name and an ID. If I open output, you can see this a bit better. We have Fireball 0 and Heal 1, with our default value being 0, and every time the player presses switch spell, this value should increase by a value of 1. Although if we go beyond the values inside of the dictionary, we want to go back to 0. Although now we have a bit of an issue. We can only really select a key from this dictionary via the keys, not via the integers. So this line is going to get a bit longer, but let me go through it step by step. Right now, we're getting the dictionary and we are using indexing. In there, first of all, I want to get the spells.keys. That way, I would get a list with Fireball and Heal. On this list, I want to use indexing again. So another square brackets. And then I want to get the integer of the current spell. Although this, I want to increase by a value of 1. And to make sure that we're not exceeding the length of this dictionary, I want to also add regular brackets to this entire expression and then use mod length and spells. That would be the entire line, and I think this one is going to be a bit confusing. So let me simply print the result. Print current spell, run the entire thing, and I think on the gamepad, the key is the top button. And if I press this one, we're getting zeros and ones. That is working pretty good. And if I add another spell to the spells enum, let's say other, then I should get 0, 1, and 2. So 0, 1, and 2. That looks really good. Although that's not what I actually want in here. I suppose if this line is getting too complicated, I can simply copy it and then inside of premade, add another text file, spell underscore switch, and paste it in there as a comment. That way, you can simply copy it if it gets too complicated. After we have gotten a new current spell, I want to get the UI and then update that spell. For that, I want to pass in all of the spells, and I want to get the current spell as well. Now, inside of UI, we get the spells the player has and the current spell that we are actually using. Depending on what we have, I want to display a different icon. All of those are inside of UI. If we have the fire spell, I want to show this icon. If we have the heal spell, I want to display this icon. Which means, first of all, before we are doing anything else, I want to get these textures inside of GDScript. First of all is the fire texture. And this I want to preload and get fire.png. Then we can duplicate all of this and change fire to heal, and I want to get heal.png. That way we can use these two files super easily. All we have to do, if the current spell is equal to spells.fireball. If that is the case, I want to get this texture rectangle. And just to keep things a bit more organized, once the scene is ready, so on ready, I want to have var spell underscore texture, which we are getting from this texture rectangle. And then inside of update spell, I want to get this spell texture and give it a new texture, which for the fireball is going to be the fire texture. And then if the current spell is equal to spells.heal, then I want to get the spell texture again and set it to the heal texture. And it should be spell texture.texture. That should be all we need. If I now run the entire thing and I press on switch button, then we're getting an error. And that is because inside of the player, this shouldn't be UI.update. This should instead be UI.updateSpell. Fairly minor mistake, UI.updateSpell. Next attempt. And now I can switch the spell and we're getting a different icon. Although there's one more thing that I do want to do. I only want to display this icon if the wand is selected. If we have the sword selected, then this shouldn't be visible at all. For that, inside of the player, when we are setting weapon active to true or false, then we also want to run a set value function to run some other code. First of all, in here, I always want to set weapon active to the value. So we are actually updating the variable. And then if weapon active is the case, then I want to UI get node with the spells. Or at least I hope that's what I called it. Yeah, I want to get this control node called spells. And then hide it. If that is not the case, so weapon active is false, meaning we have the wand, then I want to do the exact opposite. I want to show the spells. That's all we need in here. So now we can minimize this line. And when we are calling ready, I want to set weapon active to true to make sure that we are calling this set function. That way, if I now run the thing, by default, we cannot see the spells, but if I switch to the wand, we can see them. And if I switch back, this sword, once again, is visible, but not the spells. So this is looking really good. Perfect. That covers the spell UI. However, now we have a bit of a problem. For the spells of the player, we don't really have a flexible system. We only have shoot fireball, meaning we have to make some changes to get a proper functional system for different spells. And for that, once again, we have to look at Godot skin. Open the scene, and in there, we have cast spell and shoot fireball. As a reminder, cast spell is simply selecting an animation and then place the animation tree. Via this animation tree, let me select it, we have a bit further down spellcast shoot, and this spellcast shoot is triggering shoot fireball. This function here. This I want to rename to shoot magic. And then make sure inside of the animation editor for this key, it shouldn't be shoot fireball, it should be shoot magic. So far, this isn't going to make a difference. When we are getting the parent, we don't want to shoot the fireball. Instead, we want to shoot magic once again. After that, inside of the player, we're not calling shoot fireball anymore. Instead, we are calling shoot magic, in which we are currently emitting the cast spell signal. But this we only want to do if the current spell is equal to spells.fireball. If, however, our current spell is equal to spells.heal, then I simply want to increase the health, which means health plus equal 1. If I now run the game again, I go to the wand, I can shoot a fireball, that looks good. And if I switch the spell to heal, we're getting an extra heart. So that is working really well. Perfect. That covers the magic part. I can now minimize shoot magic and close Godot's skin. We also don't need heart anymore. And we can minimize the spell's control node. Next up then, I want to create another control node that I'm going to rename to energy. Or I suppose we could call this energy bar to be a bit more descriptive. This is simply going to be a bar telling us how much energy the player has. Once again, I want to create a margin container. And as a child for this one, I want to add a texture progress bar. For the energy bar control node, I do want to stay in the top left. For the margins, I want to go to theme override and then look at the margin on the left side and the top. They should be 10 and 50. That's all we need in here. Next up, for the actual texture progress, we need a couple of textures, 2 to be specific, 1 for under and 1 for progress. For that, inside of a UI, there is barcolor.png. This I want to drag into under and into progress. And notice here, both of those are completely white. That is because when we now add tint, we can change this white color to any other color. For example, for under, you could make this value much lower. And let me zoom in a bit as well. For this value, I went with 262626, a darkish gray color. And for progress, I went with a value of 386 FFF, which is a bluish color. After you have that, if you go a bit further down, you can update the value, and then we're getting a colored progress texture bar. Looks pretty good. All we have to do to animate this thing is change the value, and then we are good to go. This one is going to be really simple. Inside of the UI GD script, I want to add another function, update energy. All we need for this one is one parameter for the value. This needs to be an integer. And in there, we want to get the energy bar and update the value with the value we're getting from the parameter. This energy bar doesn't exist at the moment, which means, like we have done before, on ready var energy bar, and it's going to be this texture progress bar. Now this is going to work, and it's quite readable. After that, inside of the player, we have to go to the top, and below the health, I also want to have var energy. The default value here is going to be 100, but we do want to add a set function with value, like we have done before, and effectively get the value and assign it to energy, so we're updating the variable. After that, UI.update energy with the energy value. This should already call this function down here and update the bar. However, we are never actually changing the value of energy. To make that work, inside of ability logic, we are emitting a spell inside of this else statement. For example, what we could be doing in here is if energy is greater or equal to 20, only then do we want to cast a spell, and then every time we are casting a spell, energy minus equal 20. I'm assuming that all spells cost 20 energy. If you wanted to make this a bit more flexible, you could, for example, go to shoot magic and then subtract energy depending on the spell. In my case, I don't really care about the magic that much, so I'm going to keep it simple. Let's try all of this, and I want to get a spell and shoot magic. We are updating this value. And if I'm out of energy, I cannot cast a spell anymore. That looks pretty good. Also, the default value inside of the UI node, right now it's 28, should be 100. That's a good start. Next up, we also have to make sure that the player recovers the energy, so we don't just have 5 spells. That's a really easy thing to add. I want to use another timer that I called energy recovery timer. For this, we have a wait time of 0.2, and this should auto start. One shot should not be enabled. After that, I want to get the timeout signal and connect it to the player. Every time this times out, I want to increase the energy by a value of 1. Once we have that, we can cast some spells and the magic recovers. That looks pretty solid. With that, we are nearly done. The one thing that we now have to add is when we are assigning a new value to energy. Because of the timer, this value can very easily become greater than 100, which shouldn't be the case. To limit it, I want to use the min function to get either 100 or the value depending on which one is smaller. That way, this value can never exceed 100. Let's try all of this now, and I can cast a spell. That still looks pretty good. It also works with healing. Perfect. And if I cast a few more spells, then at some point I run out of mana or energy, and we cannot cast a spell anymore. So this is looking really good. Finally then, inside of the UI, I want to add another control node for the stamina bar. That one is going to work a bit differently compared to the other control nodes. Or well, not that differently. We are still going to use the same UI system. First of all, I want to add a center container. To the center container, I want to add a margin container, and then I want to add another texture progress bar. I suppose we can first of all add the texture progress bar. For that, we have circle.png. Simply drag this into the textures. I guess for now, simply under is fine. That way, we're getting a circle, and via tint, you can change the color. Let's go with the same color that we have used for the energy bar, to 6, to 6, to 6. And now, this thing is a bit darker. On top of that, what is really important is that you're updating the fill mode from left to right to clockwise. That way, if I add circle.png to progress, we can update the value, and we're getting a circular progress bar. If the value for clockwise was left to right, then we would get something like this, which I guess also is kind of a cool effect, but not what I want to go for. So clockwise, and then this thing looks really good. And I guess before we continue, I also want to change the progress tint to something more greenish. Let's go with something like this. Just play around and see what you like. In my case, I am more concerned about the position, because this stamina bar should be in this top left bit, so it's a bit to the top left of the player. For that, the stamina bar should cover the entire window, like so. Once we have that, the center container could also cover this entire area, and then we are already centering the stamina bar. To offset it a bit, I want to get the margin container, constants, add a margin to the left, and a margin at the bottom. The margin to the left, in my case, was 320. The margin to the bottom was 300. That way, it's a bit to the top left of the center. If I run the entire thing, that looks about right. That covers this part. Next up, we have to make all of this interactive. For that, I want to create function update underscore stamina, which is going to need a current value, which is an integer, and a target value, which is also going to be an integer. We are not returning anything. All we want to do in here is var tween create tween, and then tween.tween method. This method I called change stamina. Our start value is going to be the current value from the parameters, and the target value is going to be target. The duration will be 0.25. Now Godot is going to complain because this change stamina function does not exist. That we can change quite easily. Function change stamina, where we want to have a value that is going to be an integer. Now, this function is actually going to update the stamina texture progress. And to make that a bit easier, all the way at the top, I want to get it on ready. Var stamina bar, and then simply drag and drop it in there. That way, all of this is much easier to read. To update the stamina bar, I want to get stamina bar, and then update the value and set it to the value that we're getting from the parameter. That's all we need for now in here. Next up, inside of the player, we need one more variable for the stamina. The default value for this one will be 100, and we want to do something when this value changes. Once again, set with a value, and then UI.update stamina. I want to add in the current stamina value, and then the value that we want to get to. After that, I want to actually update the stamina and assign it the value. Although, while we're doing this, I do want to be a bit more careful and limit this value to a range of 0 to 100. In other words, I want to clamp this value with a minimum value of 0 and a maximum value of 100. Next up, to actually see something, we have to change the value of stamina. And in my case, this only happens when the player is jumping. That happens inside of jump logic, inside of this if statement. Like we have done for the magic, I want to check and stamina is greater or equal to 20. If that is the case, I want to reduce stamina by 20. Let's try all of this now. And if I jump, we are lowering the stamina circle. Although for that to work, we want to set the start value to 100. And also, like we have done for energy once again, we need another timer that is going to recover the stamina. Stamina recovery timer. We want to capture the signal inside of the player, and every time this one times out, stamina plus equal 1. Also, while you're here, the wait time, let's go with 0.15, and this one should auto start. Now, if I try all of this again, we're getting a full circle, and if I jump, this decreases and goes back to a full value. I can do this multiple times. That is looking really good. Great. And if we're out of stamina, the player cannot jump anymore. With that, we are nearly done. The one additional thing that I want to add is if the stamina is full, so if the value is 100, then I want to hide the stamina circle. Or in other words, the stamina circle should only be visible if the stamina is below 100%. For that, inside of UI, I want to add 2 more functions. The first one is going to be function change stamina alpha, where we are getting a value that should be a float. For this one, like we have done before, I want to create a tween with create tween and then tween.tween method. The function I want to trigger, let's call it change alpha. The start value is going to be 1.0 minus that value, and the target value is going to be the value itself. For the duration, I went with 0.25. After we have that, we have to create the underscore change alpha function with a value that should be a float. Really, all that we want to do in here is get the stamina bar dot modulate and then the alpha value. This we want to update via the value that we're getting from the parameter. That's literally it. And once again, if we're adding a 1 for the value, then the start value will be 0 and the target value will be 1. If we're adding a 0 to the value, then the target value will be 1 and the final value will be 0. That makes it really easy to go from visible to invisible and from invisible to visible. That we are going to use inside of the player. After we have updated the stamina, I want to check 2 things. If the current stamina is equal to 100, or the maximum value that you have. and the current value is below that point. If that is the case, we want to make the stamina bar visible. Or in other words, UI.change stamina alpha with a value of 1.0. Besides that, if the value is equal to 100, then we want to hide the entire thing, which means UI change stamina alpha with 0.0. That should be it. If I now run the entire thing, by default, you can't see it, but if I start to go around, then it becomes visible, and if it fills up, then it disappears. And this I can do multiple times. Let's wait for it to fill up again. There we go. Now it disappears. And to make sure that by default we cannot see the stamina circle, you want to go to the texture progress bar, visibility, modulate, and then set the alpha to 0. That way I can run the entire thing once more, and we cannot see the stamina circle, but once the player jumps, it becomes visible again. Perfect. That means we are very nearly done. The last few minor things that I want to add inside of the player. If the player runs out of health, so health is equal to 0, then we want to close the game, which we can check right inside of health. If this value changes, we also want to check if health is smaller or equal to 0, and if that is the case, get _3 and quit the game. To test that one inside of the game, let me add the boss again, move him a bit further up here. Let's try all of this now. And there we go. The game has ended once the player is out of health. I suppose for a real game, you would want to go to some kind of game over screen or restart the entire game, but in my case, I think this is good enough. That means, next up, I want to reopen the enemy scene. And in there, I want to add, let's do it below the export variables, var health, which by default is going to be 5. And on this thing, we want to add set value, where we are overwriting the variable. This always has to be in there. And on top of that, I want to check if after that health is below or equal to 0, then I want to destroy this scene. Besides that, inside of the hit function, this one here, I want to reduce the amount of health by 1, which means health minus equal 1. This should work for the skeleton warrior and the skeleton mage. However, for the boss, remember, we are overwriting the hit function with this one. So in there, we also have to add health minus equal 1. Let's try that one. And I have to hit the boss multiple times. Make sure I don't get hit myself. And there we go. The boss has disappeared. Perfect. Besides that, I also want to test the other enemies. So let me get rid of the boss and then add the skeleton mage. For this one, when the scene is ready, I want to lower the amount of health to 3. This should be all we need. Let's try. And now I can hit the skeleton. The skeleton can still shoot at me. And if I hit him multiple times, this also worked. Cool. I assume all of this is then also going to work with the skeleton warrior, so I don't have to worry too much. Let's get rid of the skeleton mage. And that means we are very nearly done. There are just 2 more minor things that I want to work on. If you look at the bottom, the debugger right now is a bit unhappy. For 2 reasons. The first one, if I click on it, when we are creating the fireball inside of the level scene, we are never actually using type. Now, originally for this project, I was hoping to have more magic attacks, but I ran out of time, so we only have 1 type. Since we're not using it, we can simply add an underscore here, and then Godot should have 1 debugger warning less. And we are not getting any warning anymore. I suppose that's a good start, but if we add the skeleton mage again, so skeleton mage.tscn, and now try all of this again, then the debugger has one warning, that the signal cast spell is declared but never used in the class. If I click on it, Godot is complaining about this cast spell inside of enemy, which we aren't connecting directly, but inside of the level, so level.gd, we are using that signal. To ignore the warning, you want to write at warning ignore, and the warning we want to ignore, you can find in the drop-down menu unused signal. So unused signal, and then we can run the entire thing again, and Godot should be happy. That looks good. Perfect. That means now I can get rid of the skeleton, and we're finished all of the interactions. Next up, we can work on the environment and then actually create proper levels. So let's build some levels. And broadly speaking, you can build levels in Godot in 4 different ways. Number 1, you can combine a couple of basic meshes and give them a texture. That's what we have already done, although the level is very basic. Number 2, you can import a level from another software like Blender. For complex environments, this is very popular. Number 3, if you want a simpler terrain for an open world, for example, you can use a plugin to create that straight in Godot. And finally, number 4, you can create simple 3D pieces and then combine them in a grid. This is quite similar to a tile map in 2D. None of those are terribly complicated. The main issue for level building is that we have to import and place a lot of elements, which is quite labor intensive. Also, simply creating the level isn't enough. You also need to add lighting and environmental data. And we are going to talk about that as well quite a bit. Furthermore, I will talk about smaller topics like physics and path following, concepts that you see reasonably often in a 3D level. Once again, here we are back in Godot, and inside of the level, that's the only scene that we need at the moment. Let me close everything else. This is the level we have right now. And if you look in the scene tree, we have level, and in there we have the environment. This contains all of the level data. At the moment, we simply have 2 static bodies, and that's literally it. Both of those have a mesh and a collision shape. If you wanted to make all of this look a bit nicer, for example, what you could be doing is you can go to the mesh and then add a material. This would be a standard material, and then in there, to albedo, you could add a texture. And the texture we have inside of the grid. There we have a bunch of options you could be working with. I suppose I could go with dark texture 9. This one looks alright, and drag it in there. And then we have a different kind of texture that we could be using here. If I try the entire thing, looks pretty alright and feels much better than the plain white texture. A similar thing we could do to this object, simply add another material, new standard material, and then work on the albedo. And let's give this one a different mesh. I suppose we could go with orange and then texture 9. Drag it in there, and then you get something like this. Now, obviously, you are not going to create super realistic environments with this kind of system, which is totally fine. Generally, you would do this to block out a level, so that you have a basic idea where things are supposed to go and how different entities would operate within this level. Once you have that, you can actually create a nice looking level and place it in the same position. So just to get started, doing something like this is totally fine. And there are a couple of nice tricks that you could use here. For example, if you want to have an infinite environment. At the moment, we have this static body for the floor, so if this disappeared, the player would fall forever. But what we could be doing is add another static body 3D, and to the static body 3D, we could add a collision shape 3D. For this collision shape 3D, we're going to need a shape, and most of these shapes are very simple objects, like a box, a sphere, a capsule, and so on. But on top of that, we also have a new world boundary shape 3D. If I click on that, on the surface, nothing really happens. However, if I run the game now, and I run outside of the platform, let's do this a bit faster, then Godot is not going to fall. And that is because of the static body we have just added. Effectively, world boundary shape 3D is a 2D plane that covers the entire world. Meaning, if you want to have a basic plane all the time that the player cannot fall through, this is what you would be going for. And besides that, you also have similar kind of nodes. For example, a height map shape and a concave polygon shape, along with a convex one. If you play around with these values, you can get some fairly nice effects. Although I want to stick with a world boundary shape 3D and then keep it at that. I don't want to make things too complicated. Next up, another really interesting thing that you could be adding is a CSG combiner. Add a new node and CSG combiner 3D. This is combining simple 3D shapes. So as a child to this thing, you could, for example, add a box 3D that we have to make just a bit larger. Right now, we get this box that I want to scale out just a bit. Let's place it over here, then stretch it out just a bit. Something like this is totally fine. And besides that, I want to add another shape. Let's go with a cylinder. There we can see it. And this I want to have at the corner of this box. And I guess we can make it just a bit larger. Something like this. And that looks all right. If I now run the game, we're getting the shape, but there's no collision because we are simply adding a mesh without any collision shape. So this isn't going to do very much. However, what a CSG combiner node can do is you can first of all add an operation. So right now we have a union. But on top of that, you can also use collisions. And if you do that, you're getting a collision layer with a fairly complex shape. Meaning if I run the entire game again, we can jump on the thing and we're getting a much more interesting shape, which can save you a ton of work and is a pretty nice effect. And well, that is basically it for the first way to create a level. You simply add different kind of bodies and then you have a very simple blockout for a level. That's literally it. Which means next up, we can work on the second way to create a level. The one that you are probably going to use the most for a really nice looking level. If you look at the environment, there we have a couple of files and subfolders. Just to get started, the one you want to open is called Overworld Environment. Double click on that. Godot should load for a second, and then we can see a level that was built in Blender. And this one contains a whole bunch of stuff that we are going to import. Now for the details, I want to start a bit more simple. So close this one and then go to Import Demo. If you open this one, you can see a tree. On the left side, you can see we're importing a scene with a mesh, and that's how the mesh is looking like. Not very much is happening here. I guess another thing to keep in mind is that we are also importing a texture. But that's just about it. So the way you would be using this, you would right click on it and then new inherited scene. With that, we are getting a tree, and this tree we could save. Let's save it under scenes and levels. I guess we can keep it inside of this one and then rename it to tree_test. With that, we are getting a tree, and this tree we could add to our current environment. It means tree test.tscn, and make sure you're getting .tscn, not glb. Those we are going to look at later. Open this one, and then you have a tree. Also, before we continue, let me move this CSG shape a bit further this way so Godot doesn't collide with it right away. Let's try it now, and then we have a tree. Unfortunately though, this tree does not have a collision shape, so for game purposes this doesn't do very much. To give it a shape, we can do a couple of things. What we could do, for example, inside of this tree is simply add a static body 3D and then give this a collision shape 3D. For the shape for this one, I guess we could simply go with a cylinder shape and make sure it roughly lines up. We can go with something like this and then make it a bit wider so we cover the entire tree. Roughly like this. Also, for the static body, make sure you are on the environmental layer, or the terrain layer to be a bit more specific. If you now run the game again, we have a collision shape that looks pretty alright. Although this is super imprecise. For example, this branch has no collision because we only have a cylinder for this tree and literally nothing else. Which means for any object that's even a bit more complex, this approach isn't ideal. Fortunately, we have already seen a better way. For now, I want to get rid of this collision shape 3D, but keep the static body 3D. Next up, I want to select the tree mesh, and then at the top, you can see mesh. If you click on that one, you get a whole bunch of options. The first one is create collision shape. If you click on that one, you get two options, the collision shape placement and the type. We can either create a sibling or a static body child. I usually go with sibling, but both would be totally fine. Besides that, you can create different kinds of meshes, and I suppose we can simply create the default options, so create now, and then we're getting a collision shape 3D. And this we have to add to the static body, and then we have a much more sophisticated mesh for the collision. If I now run all of this again, we are getting much more precise collision, and this branch also gets collisions as well. A bit hard to test, I suppose. If we move the tree a bit further down, you can see this much better. There you can see we have really nice collisions for every single part of this tree. And if you look back at the tree, we can do this in a couple of different ways. So if you click on Create Collision Shape again, if you add a static body child and create, then Godot is going to create a static body along with the collision right away. The result would effectively be the same. If I delete all of this, create another mesh with the collision shape, static body child, and if we then use a different kind of mesh, for example, a multiply convex, and create, then you can see we are getting lots of shapes that we could be working with. Getting the right balance here really depends on what you want. For example, for this tree, you might want to have collisions with the actual tree, so the wooden bits, but not for the green parts. And then creating something like this makes your life much easier because you could delete, for example, this part, and then you don't have collisions with these leafy bits. It's very much up to you and what you have in mind for your game. Basically, how you want to approach it is for your mesh, you want to play around with the different options and then see what works best for you. As always, there's no universal answer. Simply use what works best for you. In my case, I'm going to stick with the most basic one. However, there's going to be kind of an issue because for the actual game, if you look at environment, there you can see we have a whole bunch of objects that we would like to use. And turning every single one of those into a separate scene and then adding the static body to it is going to be a lot of extra work, which is why I would rather want to automate all of this. And fortunately, this we can do. Although to understand how this is going to work, we have to look at Blender, which means in my case, I want to open import demo in Blender itself. This is not a part that you have to follow, although it would be super useful. I guess if you're just getting started, simply understand how the system works, and at some point in the future, try to work on it yourself. Here we are in Blender, and this is what you should be seeing by default, or something very similar to it. We have one object, and this object you can see on the right, there we have tree, this as a mesh, and then we have a texture called Nagon Fort. If you click on this icon in the top, then you can also see the colors, which looks much nicer. And basically what we're getting inside of Godot. And the really nice thing that you can do in Blender is rename this mesh and add dash call. That's all you need. If you now go to File and Save, or simply Control S, you are saving the file, and we can go back to Godot. Godot is now going to re-import, And if you now look at the tree, we're getting a static body by default that's inherited, meaning we don't need those two options anymore. Simply by having the tree, we're getting a static body 3D. Or in other words, if you double click on import demo, then Godot is going to get a mesh and automatically create a static body 3D with a collision shape. Because of that system, we don't actually need the tree test. We could simply add import demo right away, which means to the environment, I simply want to drag import demo into it. And now we're getting a tree with a collision shape. Let's try all of this. And once again, we are getting the same collision shape. That looks really good. And while we are here, I want to go to scenes and levels and then get rid of tree test because this one we don't need anymore and Godot wasn't happy about the naming. And that is basically all you need to import basically any kind of data or well, graphic into Godot. That means to create a level inside of our current level, I want to get rid of all of the static bodies like so, and also import demo should go away. The environment node should be entirely empty. In fact, the only actual node that we have inside of the scene is the player, because this one should always be there. That's totally fine. Next up, I want to create a new inherited scene. The parent scene is going to be the level. Click on open. And now we can create the overworld. This you also want to save inside of the same folder. That looks all right. And now, inside of the environment, we can add the actual main level. That is going to be inside of graphics, environment, and there we have overworld environment. If you double click on that one, Godot is going to load for a second, and then we get a whole bunch of things. We have a couple of stones, we have a few more stones, then we have the floor, and then we have the Godot logo along with a tunnel. On top of that, we also have a sun. And this one was created in Blender as well. But this is not actually what I want in this scene, so I'm going to click on Skip Import. If I now click on Re-import the entire thing, I can create a new inherited scene. And then, if I zoom out a bit, we can see the entire level. And this is quite a large one. Also, if you look at the scene tree, we have a static body for the floor, but not for anything else. That we can work on in a second. First of all though, I want to save all of this and then create overworld environment. I guess to keep the naming consistent, overworld skin would work here. This I want to save, then we have a scene, and this I want to add as a child to our overworld level. Overworld skin.tscn, and now you can see how large the world actually is. The player looks tiny in comparison. Let's move Godot to the actual starting position, this hill bit here, and make sure you're getting her in the right position. Inside of 3D, this can be very confusing. Also, if the zoom in becomes really unresponsive, so I try to zoom in as much as I can, and at some point this bar has filled up, so we cannot go any further. That is because the zooming, if you click on perspective, is perspective. If you set this to orthogonal, then the scrolling is going to work much better, especially for larger levels. It's unfortunately a bit hard to explain the difference between these two. Just use them and see how they feel. Now we have the overworld level, and this scene I want to test. So let's run this scene, and then we have a really large overworld with everything else working just fine. However, if I try to walk into this tunnel, then you're going to see in a second, this is not going to work. We are simply falling through it because this tunnel does not have a collision shape. Or in other words, inside of overworld skin, we would need a collision shape for this tunnel and for these other objects as well. If I hide their visibility, you can see what's going on. For all of this, we need a collision shape, which means back inside of Blender, I want to go to File, click on Open, and then we get the current file path. This one is fine. And in there, I want to get overworld environment.blend. Open this one, And then you can see what we have created earlier along with the texture. This one we don't need, so just ignore it. On top of that, to see the colors, I want to click on this icon and now rename a couple of things. There you can also see we have a floor collision. This I want to rename entirely to tunnel-call. And I guess this would be rocks-call. And this would be, I know, rocks2-collision. I can now save the entire thing. So click on save. And if I return to Blender, all of this should get updated. That looks pretty good. I can now go back to the overworld, run the scene, and now we should get collisions with this tunnel. And that looks really, really good. We can now explore the entire level, and there are always collisions on all sides. Perfect. I believe just for the Godot stone thingy, we don't have collisions. So in there, we can simply jump into it and nothing's going to happen. Which I suppose for now is totally fine. And that is basically it. Via this system, you can import really complex levels and have them ready inside of Godot right away, which can be super handy. Now, still creating all of this is going to take you some time. It doesn't really matter if you do it in Blender or in Godot, it's simply a ton of stuff that you have to create. Just be ready for that. In fact, there is going to be a larger thing that we have to work on. If you look at objects in the environmental folder, there we have a whole bunch of GLB objects that we want to place. Basically, all of those already have the right collision naming, which means if I add the barrel and then move it to the floor so we can actually hit it and run the game again, simply by adding this file, we get the scene, we get the graphics, and we're getting the right collisions. So that is all we need. With that, we have a barrel. Works pretty good. That means now we have to create the entire level and add all of the elements. For example, you want to add a couple of trees. They are a bit further down. So there we have a whole bunch of rocks, targets, trees. All of this should be added to the level. And then you eventually get a really nice overworld. Something like this, except we are going to need a lot of trees. Now, while you do all of this, there's one thing that can be super useful. If you look at the top, there's View. And via this tab, you can have multiple viewports. For example, what I like to do is have 2 viewports, and then we have 2 windows, with one only having a top view. That way, we can tell very easily where elements are in the 3D space. So for example, this tree I can copy by pressing Ctrl D and then move it a bit further down here. And I guess we could rotate it. And if I zoom in on this side, we could give it a bit more of a rotation, something like this. And then move it a bit further over here. Always make sure that you are also on the floor. This can be sometimes a bit difficult to do. Once again, this is going to take you some time. I also want to have water inside of this level. And for that, I want to go back to one viewport. This area here is going to contain water later on. And for that, first of all, I want to move the trees and the barrel into the environment node so things stay clean. We don't want to have anything inside of entities at the moment. I only want to work inside of the environment. In there, I also want to add a mesh instance 3D. The mesh I want to create is going to be, at least for now, a new plane mesh, which we have to move roughly over here. At the moment, we can't really see it because it's very small. So there, you can see the mesh. And this I want to stretch out quite a bit, so we are covering the entire area. That means I want to increase the X size by a lot. Let's go with 300. We need even more. 600 should be enough. And then for Y, we also need quite a bit more. We basically want to create a really long and wide strip that we then have to lower a bit. So that is starting to look a bit more like a river. I guess needs to be quite a bit wider. Do something like 250. that gets closer to it. And depending on the height, you can determine how deep the water is. Later on via a shader, we're going to animate this texture. For now though, that's not going to be too much of an issue. What I do, however, want to do is add a material, under material, standard material, and then I want to add albedo with a bluish color. Something that roughly fits in there, doesn't have to be too precise at the moment. I suppose this one is okay. These outer parts here, outside of the level, are not going to matter because the player is never going to see them. So don't worry too much about those. Alrighty, and with that, we are basically ready to place a whole bunch of elements, and this is going to be an exercise. I want you guys to add all of the elements to the overworld to create a proper level. Which means you want to spend some time to add lots of 3D objects to this overworld and then make a nice looking level. That's all it is. On top of that, there's a castle blend file that you should be adding, and the bridge object does not have a collision shape, meaning you either have to add it inside of the blend file or in Godot. Both would be fine. Now, placing all of these elements is going to take you some time. That being said, since this is a tutorial, you could get away with placing a couple of elements so you get the basic principles and then keep a more basic overworld. I suppose just get started and see how much you enjoy the process of level building. If you only have a few elements, that's also totally fine. Don't spend too much time on this unless you really enjoy it. Anyway, pause the video now and see how far you get. And here we go. I have now added a whole bunch of stuff to the overworld, mostly trees and rocks, along with a castle over there, and then some smaller elements, like for example, these rocks, a bridge, and a few camps, like this one here. And while doing this, I would really recommend to keep things organized, and in my case for that, I have added a few more Node 3Ds, for example for the trees. Also, what I forgot to do is for this water, the mesh instance 3D, we should rename all of this to water. And I hope you could do all of this yourself. I don't think it should have been too difficult. For most of the time, you are simply dragging an element, for example, from the objects. You want to have a barrel, you drag it in there, and then you place it wherever you want it to be. For your own projects, the two really important things that you want to keep in mind is that when you look at the children, you have to make sure that you have a mesh and a static body 3D for the collisions. And these collisions also have to be on the right layer. So in my case, layer 1 is always the terrain. That's the default option, and this is why you always want to have the terrain on layer 1. That way, you can import things and use them right away without having to change the collision layer. It's super handy. Now, besides that, what you also want to keep in mind is for some larger objects. For example, for the bridge. If you open this one, bridge.glb, there you can see we are only importing the mesh, but we are not importing a collision layer. Because of that, I have created another scene with the bridge and then added a static body 3D to it, along with the collision shape. And this I created by simply going to mesh, create collision shape, and then create a static body child with trimesh. That's all you need in here. Besides that, for the castle, we have a blend file that I have imported as a separate scene. And in there, we have the castle, and to that, I have added a few static body 3Ds to get collisions everywhere. That's literally it. That means we can close quite a few things. And then we have a reasonably sized overworld. Oh, also, at the starting position, I've added a few more elements. Nothing too crazy. Oh, I guess another tip that might be useful. If you click on one of the items, by default, you get this gizmo. And this allows you to rotate and to move it on a certain axis. If you look at these top icons, you get a few more options. And those you can also get via hotkeys with WER. Scale mode, for example, is quite useful. That one lets you scale the object quite nicely, which can save you some time. There's also a rotating thing and quite a few more options. But other than that, that's basically all we had to do. Which means now we can try to run all of this, and that is looking pretty good. we now have a whole bunch of elements that create the overworld. So I'm fairly happy with this, although for a real game, you would want to spend a lot more time on this. Also, I have spotted some trees here that are floating in the air. I think all of those are way too high. So that is a thing you simply have to work on. If you spend some time on it, it shouldn't be too bad. Anyway, with that, we have the overworld, and that should actually be fairly straightforward. Now, another thing you do want to keep in mind here is performance, because we have added a lot of elements. I didn't really count them, but simply by looking at the trees, you can see we now have a ton of stuff. At the moment, at least in my case, the performance is still really good. But if you want to publish the game, you'll want to test all of this on a much weaker computer and also make sure that you are looking at the frame rate. If you add too many elements, you can very easily get a low frame rate that makes the game basically unplayable. Other than that though, that's pretty much it. With that, you can import a level from a Blender file and then add more stuff to it. Fundamentally, it's not a complicated process. Which means next up, we can work on the third way to create a level. And for that, we want to create the dungeon level. Or to be a bit more specific, the level inside of the castle. For that, if you look at dungeon, we have a whole bunch of objects. Those are going to work differently compared to what we have done inside of the overworld. I guess the way to get started, I want to create a new inherited scene. The parent scene should be the level. And then we have a new level that I want to save right away. Let's call it dungeon.tscn. And just to have a look what we have inside of these files. For example, for the floor, if I add this to environment, we have a floor tile. There are a few more, and those we want to use. All of those, by the way, have roughly a similar size to make them work a bit better together. Now, for all of these objects, we could try to arrange them in such a way that they create a coherent level. Would be possible, but would also be really annoying to work with. So this is not what I want to do. And fortunately, Godot has a much better solution. That solution is a node called grid map. This is effectively the equivalent of a tile map. It's basically expecting a couple of graphics and then lets you place them inside of a grid. For that though, we're going to need a mesh library, which we have to create in a fairly specific way. Let me save the scene and then create a new one, where the parent scene is a basic 3D node, which I want to rename to Dungeon Tiles. And I guess let's save this one right away as well, inside of the levels folder. That's totally fine. And to this scene, I want to add all of the graphics inside of the dungeon folder. As a result, we are getting a whole bunch of graphics. These are all the tiles that I want to use for the dungeon. Or to be a bit more specific, I want to use them inside of the grid map. To do that, you want to go inside of the dungeon tile scene, to scene, and export as. There you have a mesh library. I want to export that, and then we need a folder to save all of this in. I want to do that inside of graphics. There we have environment and dungeon. Then we need a file name. Let's for now call it dungeon no collision. For the file ending, we can keep the default one here. That's totally fine. Then I want to click on save. And now Godot is going to save. That's all we need in here. And by the way, the objects here not being visible is totally fine. Next up, we have to go to dungeon. And then inside of the grid map node, we want to add a mesh library. In my case, I want to go to quick load, and then we can see dungeon no collision, the file that we have just created. If I click on open, we can see all of the objects that we have imported. And those we can now place. Although, if you play around with this yourself, you can see that the grid itself is too small for these tiles. So I can get very easily some overlapping stuff here. For that, you want to go to cell and then adjust the cell size. For this one, I have an X size of 4 and a Z size of 4 as well. That way, the graphics cover exactly one cell, which makes placing things much easier. if you want to work over multiple levels, you want to look at the top. There we have the floor. At the moment, we are on floor 0. If I go one higher, then we are going up by a bit. And in there, for example, you could place a couple of walls, something like this, although not ideal yet. The issue we have right now is that for these walls, we have a certain height. And this one is inconsistent. For the floors, we have a height that is very, very small. Whereas for the walls, we have quite a tall height. I think the easiest way to account for that is to create 2 grid maps. Which means I want to duplicate this and then have a floor grid and a wall grid. And then I want to hide the wall grid and inside of the floor grid. If you hold Shift and right click, you can delete cells or graphics inside of cells. After that, I want to make the wall grid visible again. And for now, with Shift right click, once again, delete the walls. If I now go to floor 0 on the wall grid, I can place the walls here just fine. And they do have a very slight overlap with the floor below. We can simply go to transform and give the wall grid a very slight Y offset in the positive direction. Let's go 0.1, I guess 0.2. And once again, we have to make sure that we are getting rid of the floor on the wall grid. So Shift, right click on all of this. And then we are getting a better outcome. Now we can see that we have a bit too much of a Y offset. So 0.1, still too much. Let's just stick to 0 and have a very slight overlap. That's still fine. Cool. I hope that wasn't too complicated. So basically, right now we have a floor grid where we have only the floors, and then we have a wall grid with only the walls. And we can add stuff to either by left clicking, and if you want to delete stuff, you Shift right click. Besides that, you can also rotate the graphics. You either want to go to grid map and then cursor rotate X, Y, and Z, or ASD. You basically always want to use the keyboard shortcuts because they're much faster. If I press A, we are rotating this way. If I press S, we are rotating this way. And if I press D, we are rotating this way. In my case, S is the most useful rotation. Then we're getting something like this. And if I add a corner that I can rotate with S once again, we can add quite a few elements, something like this. And then we have a very basic room at the very least. For now, this is good enough, although we will change this quite a bit in just a second. Before that though, I want to move the player up just a tad, so Godot is standing on top of the floor. Now, with that, if I run the game, this is not going to work. Because we have no collisions, Godot is simply going to fall through the entire thing. Not terribly useful. Which means we have to figure out how to add collisions to this wall grid. Which fortunately you can do, but it's going to take a bit of work. Because for every single one of these grid tiles, we have to add a collision layer, which can take you some time. The way you would approach it, inside of the dungeon tiles that we have just worked with. Let's start with the first one. To this floor dirt large 2 tile graphic mesh, we have to add a collision layer. And the best way I found to make that work is to make it local, first of all, down here. Then you can see the mesh right away. And to this mesh, you have to add a static body 3D. So static body 3D, and then you need the collision shape. This could, for example, be a very simple collision shape 3D, where we have a box shape, for which we have to adjust the size. We know that X and Z have a size of 4, and Y can be 0.1. That might still be a bit too much. Let's look at it from the front. You can see the collision layer has to go a bit down, something like this. Inside of transform, we want to go down by negative 0.03. And this number should be consistent across different floor tiles, so that Godot doesn't get stuck between them. This is our first floor tile, which means we can minimize this one, hide it, and then work on wall 2, at least for now. This one could also work with a basic collision shape, although it is getting a bit more complex. So the way I want to approach this one, just to have something else, is I want to make this scene local, and then inside of the wall, go to mesh, and create collision shape with a static body child and a tri-mesh. Like so. And then we have a much more detailed collision shape. And that would be the basic principle. You want to have a node 3D, then a mesh, and then a static body 3D, along with a collision shape. If you have that, and you export this scene again as a mesh library, let's call it dungeon underscore collision test. This I want to save. And then if I go back to the dungeon, if I now get rid of the mesh library by clicking on this one, and then quick load a new mesh library with collision test. Open this one, and now make sure that you have on floor 0 the one graphic floor dirt large. This one is the only tile right now for the floor that has collisions. These other two do not have the collisions. We'll work on that in just a second. For now, I want to run the game. And we have a collision for the floor. At least for this one tile. If we go over here, this is not going to work anymore. Besides that, for the wall grid, I want to do something similar. I want to get rid of the current mesh library and then quick load collision test. That way, this single wall should have collisions, which we can test by running the game again. And now we have collisions for this one wall, but none of the other ones, so you do have to be careful. That's a good start. Next up, we have to make sure that for all of these tiles, we have a proper static body 2D for the collisions. And I think for that, I'm going to jump ahead just a bit. I have just finished, and now for every single graphic that we have imported, we have a collision shape, and we made the graphic local. You don't have to make the graphic local, I just feel like it's easier to access everything. Besides that, for the floor tiles, large 2 and large 2 rocks, to each mesh I have added a Y offset to move it down just a bit more. That way, all 3 of the floors are exactly on the same height, which makes it easier to walk between them. Now that we have that, I want to export this mesh library as dungeon collision. Oh, and by the way, you might be wondering why I'm always saving this in a new file. And this might be make-believe, I'm not sure if this is still the case, but at least in the past, if you overwrote one of these mesh libraries, you occasionally get some buggy behavior. This is probably fixed, but just out of habit, I am always creating a new file. So now click on Save, and then inside of the dungeon, we should be able to use that. Although before that, I'm also going to save this scene inside of the pre-made folder. So save scene as, and then inside of pre-made, there we have the dungeon tiles. So you can just copy that and not have to create the collision shapes for every single object yourself. After that, inside of the dungeon, I want to get the floor grid, get rid of the current mesh library, and then quick load dungeon collision. The same thing I want to do for the wall grid, and then quick load dungeon collision. After that, let's add a few more floors with a bit of variety, so we can test all of that. And then on the wall grid, I want to test all of these walls to make sure this is working. Guess we can add one here, and then finally this one. If I now run all of this, we should have collisions. That looks pretty good. There's collisions with this wall as well, and this wall. Perfect. I am very happy with that. That means now we have to create another level by simply using all of these tiles. This, once again, is going to be your exercise. I want you to create the dungeon level using the grid maps we have already used, and on top of that, you could also add other objects, simply to flesh out the level a bit more. And just as before with the overworld, this doesn't have to be too complex, but do spend at least a bit of time on this so you have a basic level. Pause the video now and see how far you get. And here we go. I have spent a bit of time creating another level, which ultimately isn't that complicated. For most of it, I have a floor grid and then a wall grid with 2 floors. That's basically all I did. Besides that, I added a few more objects. Oh, and by the way, for that, I forgot to mention, inside of environment, I added a dungeon objects folder, which contains a few objects designed for the dungeon. Nothing new in there, so I hope this still made sense. I guess the one additional thing that I did here was this wall-y kind of thing for the door. Effectively, this is simply a mesh instance where we have a box mesh as the shape. And then I gave it a material with an albedo color that is pure black. That way it looks like we have some kind of door. Not perfect, but for our purposes good enough. If I now try to run the entire scene, we have a level that looks pretty alright. And then we're gonna have a level transition here later on. For now, that's not too important. And then you have to do a bit of jumping to get to the next platform. And ideally reach it as well. But the level works, so I'm happy with that. Which means with that, we have covered the second way to create a level. You simply use a grid map and then place a whole bunch of tiles to create a level that hopefully is fun. I think if you practice this, this also isn't too difficult. Which means we can come to the final way to create a level. And before we start with that, I want to close overworld skin and dungeon tiles, so that we only have overworld and dungeon open. Now, the final way to create a level is going to be via a terrain editor, which allows you to create a custom terrain overworld kind of thing. However, to get that functionality, we have to install a plugin, which fortunately is not very difficult to do. You want to go all the way at the top to Asset Library. Then Godot is going to load for a second, and then you want to look for Terrain 3D. This one here. You simply click on it and then download. Now Godot is going to download for a second. Depending on your internet speed, this might take longer or shorter. Shouldn't take too long though, it's only 40 megabytes. Then you get this dialog, and on there, you want to click on Install. Then Godot is going to install for a second. This shouldn't take too long. And then we have installed the entire thing successfully. Now we have to restart. After the restart, on the surface, not much has changed. However, if you look at the file system, we have gotten 2 more folders. The first one is called Add-ons. In there, we have Terrain 3D. Not too important right now. The more interesting one is we have a demo folder. In there, we have a demo for the terrain plugin. So you want to open demo.tscn, and then you can see something. Although right now, this isn't going to work perfectly because we have to enable the plugin. For that, you want to go to Project, Project Settings, then you have Plugins, and you want to enable Terrain 3D. If I now close this dialog, we can click on Terrain 3D, and then we get something that you probably haven't seen yet. On the left side, we get a whole bunch of icons, and in the bottom, we have Terrain 3D. And via this system, you can influence, let me zoom out a bit more, you can influence all of this. For example, via this raise button, you can raise parts of this texture. And for that, let me zoom in just a bit, and I want to raise this part here. I simply have to draw on it, and then we are raising the terrain. If you want to have this on a larger area, you can increase the size. And if you want this to be stronger, you can increase the strength. And then you can keep on drawing, and you get something much more interesting. This also works with lowering, something like this. And then you have a whole bunch more options. For example, this one is for slope, where we can go from one point to another, and then we have a slope. Let me do it again. I want to go from here to here, have a slope, and then we're getting a slope. Via this Terrain 3D node, you can create really complex levels, which is also fairly easy. Although there are limitations. The most notable one is that you cannot make caves like we have done in the overworld. So in the overworld, we have this cave here, meaning we have stuff on top of the player. Inside of the terrain plugin, this we cannot do. you basically always create an open world. Although what you could also be doing is create a hole in there with this button and then create a hole there, after which you could import a graphic and then add a tunnel in there. That's the basic idea. Although before we continue, I want to close this scene and then create a new inherited scene with level.tscn being the parent. After that, inside of environment, I want to add terrain 3D. After we're doing that, everything changes quite a bit. And now we are getting the options we have seen earlier. That's a good start. Also, let me zoom in on the player. You can raise the terrain with this button just as before. And for that, I want to reduce the size of this thing and the strength so it's not too strong. Something like this. And if I now draw on this, we have a hill. On top of that, for this terrain 3D, we can set collisions. Those are enabled by default. And then we have the usual collision layer and mask, which means if I save this, let's call it terrain.tscn, then Godot is going to save for a bit. And we can run the entire thing, after which we should have the level. All right, that didn't work. And I think the reason is Godot is below this area. If we move up and move her a bit over this side, we can try all of this again. And then the entire thing is going to work much better. Once again, we have collisions, we have hills, and we have proper collisions that work with everything else as well. So that is looking really good. Although the obvious problem now is that, well, we don't have proper textures. This looks a bit samey. To fix that part, you want to go to Terrain 3D and then create a new texture. This is then giving you a couple of options on the right. We can set an albedo color and a couple of textures, along with a name. And let me call this one grass. For grass, we want to have a greenish color, so let's go with green, something like this. This, at the moment, is going to make the entire level green, because we only have a single texture, and Godot is going to use this for everything. So I guess besides that, I want to create a second one. Let's call this one rocks, for which we want to have a more brown grayish texture. I suppose something like this is fine. Doesn't have to be too specific. And now for this one, we can draw, and then we are getting different colors, although we still have the same texture pattern in the background. To fix that part, you want to go to graphics, and there we have textures, and there we have terrain plane. If you now click on this icon to modify the texture and drag terrain plane into the albedo texture, now we are getting a pure green color. The same thing, by the way, I want to do for the rock texture, so drag this one in there. And now we are getting proper colors, more or less. I think the green color here is a bit too strong. Let's make it darker and a bit more like this. I think that's more workable. So now I can raise the terrain and we can create some mountains that are slowly becoming visible. And if I make sure that Godot is on top of all of this, somewhere here, then we can try the entire thing again and see if it looks a bit better at least. Here we are, and now we have a much more interesting level. Everything else still works just fine, so this is looking fairly solid. That being said, if you look at the terrain node, Godot is going to complain about two things. Number one, that the storage resource is not saved as a binary resource. To fix that one, you want to go to storage and then right-click and save the storage part. Really important for this bit, Godot wants this to be in the .res file format. Why that is, I have no idea, but let's call it terrain_storage, then save. And now we have a custom option in here. Now, if you click on it, the options aren't that interesting, so we're not going to work with them. As long as you save it though, Godot should stop complaining. And there we go. If you go outside and into the scene again, the warning disappears. Although, if you're doing that, the entire map resets, which isn't ideal. So just that we have something, I want to add a few more things to it. I don't know, something like this. And then we can also add some rocky bits and try all of this again. Then the loading times are becoming much better. And now we are once again getting the same scene. Mostly done. There's one more thing that I do want to do. Inside of the demo, we have a blending between the grass texture and the rock texture, which effectively means that the higher we go, the more of a rock texture we are getting. And this you do inside of material. For this one, you have to make sure that height blending is enabled and that you have an auto shader. This one right now is going to look a bit weird. That is because the auto base texture and the auto overlay texture are inverted. If I set this to 1 and the other to 0, this is looking much better. And now, if I create a hill, at some point we should be getting more of the rock texture. Something like this. And then you can create much more interesting terrains. And I think I should explain, if you look at Terrain 3D and click on the texture edit, there you have an ID. For grass, this is 0, and for the rocks, this is 1. If you go then back to terrain and the terrain material, the auto base texture should be the one for the hill, and the auto overlay texture should be for the ground. I hope that makes sense. And well, that is basically it. If you want to get started with Terrain 3D, this is how you would do it. I am not going to use this kind of tool too much because I'm quite happy with the overworld and the dungeon. But if you wanted to create a much larger overworld, this is how you would approach it. There are quite a few more options that you could play around with on the side. I guess one that I really want to cover is instance meshes. In there, you can assign a 3D object. By default, you have this flag kind of thing. And if you use that, you can draw a whole bunch of 3D objects that is quite randomized. If I zoom in just a bit, you can see that we have created a whole bunch of 3D objects. I can also move Godot into this area, somewhere here, run the scene, and then we are getting 3D objects, although without a collision shape. But still a good start. And if you wanted to add your own objects in there, you simply want to add plus, then give it a name. Let's say I want to create a tree. And then you want to have a scene file. I can quick load one. I want to get tree, let's say tree 1, put it in there, and then we have a tree. If I now paint, we are getting a couple of trees, although not too many. That is because when you look at the inspector, we have a density slider. Right now, it's fairly low. If I increase this one, we're getting a whole bunch of trees. You can also set a height offset, and if you look at the bottom in Terrain 3D, they can modify the height, the scale, the rotation, and the color. And you can even set a material override if you want to do something even more crazy. But other than that, this is a way to create more complex environments. The one limitation here, though, is that at least I don't think you can get collisions, which means if I run the game, Godot can simply run through all of this. So you do want to be careful here, but at least to get started, this is pretty nice. And well, this would be Terrain 3D. That being said though, I don't want to cover this one in too much detail. Let me close it and then focus on the overworld and the dungeon. Because now that we have the basics, we can work on lighting. And there we do have to do quite a bit, because at the moment, this scene looks, I guess, okay, but not amazing. There's a lot of stuff that we want to change. First of all, before we do anything else, I want to zoom in just a bit and look at these objects in more detail. Let me expand all of this as well. And now, if you look at these textures, let's say we can start with the tree. If you look very closely and compare this image to what you have in your project, this might look different. On your end, it should actually look better. And that is because if I click on this tree, Or well, to be a bit more specific, I want to look at graphics. There we have the environment. In that folder we have objects. And I think this is tree 4. If I open this tree, I think this is the correct one. And once again, if you look at the top, we have this weird texture effect that doesn't really look that smooth. That is because when Godot is importing all of this, it's compressing the texture for it, which you can stop by going down and then under the GLTF tab, there's embedded image and you can select uncompressed. If I select that and re-import everything, then this tree is going to look significantly better. Now for the demo project, I have already done that. So in your case, all of the trees and objects should look just fine. But in my case, for this project, I haven't done that. So same for the shrine. Let me try to find it really quick. There we have the shrine. And we have this weird texture effect, which we can get rid of by having an uncompressed texture, then re-import. And this is looking much better. So if you're working on your own project and you have this weird effect, that's the reason. Making sure you have the proper imports with the right texture is really important. Now, those are the smaller objects. Besides that, we also have the Blender import. Or in other words, if I minimize the objects folder, we are importing this overworld environment. If I open the import dialog for this file, Godot is going to think for a second, and then we have this import, which has the same issue. Although for this one, I don't have access to the GLTF tab. So how can I get uncompressed textures for a Blender import? Well, the way this one works, when you're importing anything from Blender, so for the overworld and for the castle, Godot is going to create another folder with the textures, which means in this case, we have a dungeon and a Nagon texture. For the overworld, we are using the Nagon texture. And with this one selected, you want to go to import, and in there, you have a compress tab. For this, you want to select high quality, and then re-import, after which all of this is fixed. If you now look at the cave, this is much better. Besides that, we can look at the castle over here, and if I zoom in just a bit more, you can already tell we have the weird color effect. This we can fix by going to dungeon texture, high quality, re-import, and there we go. Now this is looking much better. Especially if I run the game. This is a much nicer effect. So if you look at this dungeon, it feels significantly nicer. That means before we continue, for this project, I am going to import all of the objects with the high quality setting. So I go to barrel and then have uncompressed textures. Alternatively, I could also go to texture and then enable high quality. Both would be fine. I just finished and now all of the textures are uncompressed, which inside of the game is already going to make a difference. So for example, if you look at these barrels or the shrine at the tree, much nicer. The same also applies to Godot. She now looks quite a bit nicer, although depending on the video compression, this might be hard to see. That's the first part that you always want to keep in mind. When you're importing graphics, you need to have the right texture. However, there is a trade-off. A higher quality texture will look better, but it will need more storage space, and it's going to be harder to process. As a consequence, you want to find some kind of trade-off between the two. For example, if an object is really far away, let's say later on, we're going to have a couple of birds on top of the level. Those don't need good textures because they're not going to be visible that much. And generally, if things are further away, for example, if you put a tree on these rocks around the corner, the player will always be far away, so we never get to see the textures up close. So having slightly worse textures might be a good idea here. This is just something to keep in mind. When you make your game, simply play around and see what works best and gives you a good performance. It really depends on a whole bunch of factors. But other than that, this shouldn't be too difficult. So next up, we can start working on the light and the environment, or these two nodes to be specific. And for that, inside of the level, I want to get rid of them entirely, so we can start from scratch. If I now save all of this, this is going to look a bit bland. And while we are testing this, I want to add a camera so we can see a bit better what's going on. For that, first of all, I want to have two viewports like this, and then to the overworld temporarily add a camera 3D. And this camera we want to preview like so. And then for now, look at the player. I guess something like this is going to look okay. Then we can see what's going on. After that, I want to go to this top tab again and then add a sun and an environment. Let's start with the sun. So I want to add a sun. That gives us a directional light 3D. And in there, we're getting a bunch of options. First of all, we have a sky mode with light and sky, and we can have light only and sky only. The basic way this is going to work is that you get light from the sun, and this light is being reflected by the sky, which means if you have a blue sky, then this blue color is going to influence the level. Although this you can toggle, but you basically never want to do it. Most of the time you want to have both. After that, you have directional shadows, in which you can influence the shadows quite a bit, although that's not what I want to do. This one usually is fine by itself. The much more interesting tab is light. In there, you can influence the light color. This is something we have already seen. If you make this, for example, blue, you're getting a really blue scene. If you make it pink, purple-ish, then you get a different color. Most of the time, for this color, you want to stick to white or something very close to white. Anything else is going to give you a really strong effect that you want to control very tightly. In my case, I'm going to go with F0, F0, and F0. Basically a pure white with just a little bit of gray. Besides that, we can control the light energy and the indirect light, although this one right now doesn't do very much. I'm going to keep those at the default values. I think all of this is basically fine. Besides that, we have the shadow, and there we can enable and disable shadows. Fairly straightforward. We can also control the opacity of the shadows. Once again, quite straightforward. And the shadow blur. This I want to set to 4.5. And for the opacity, I want to go with 0.9. And that is basically it for the directional light. You can't really do that much in here. The more powerful node is the environment. So let's add this one. Add environment to scene from this tab up here. And then you get a world environment, in which you have a bunch of options. The environment, camera attributes, and compositor. The most powerful option is the environment. In there, you get a whole bunch of stuff. First of all, we have the background. That is all the background you can see. Right now, we have a sky, which means we have the sky itself and a ground along with a horizon. This you could change to, for example, a clear color, and then you only have a clear color. And once again, remember, the light we're getting from the sun is being reflected by this, which means inside of the game, if we have this grayish background, the game is going to become a lot more gray as a consequence. Or in other words, if I play the entire thing, it looks really, really gloomy. Not a great effect. Besides that, you could also set a custom color, which allows you to set any kind of color that you want. By default, it's black, which gives you an even gloomier effect. If I run the game now, it looks like we're playing a horror game. So, not ideal. That being said, I do want to keep a custom color, but with a different kind of value. I want to go with 7B, A2, E6. This is a bluish color, which right now is going to make the game look really weird. But that's fine, because in the next option, we can set the ambient light, for which we have background, disabled, color, and sky. I want to go with a plain color. That way, you can already see we're getting a lot of a second color. And for this color, I want to go with the value, let me copy it in, F7 D5 dB, which is going to be a very light brownish color, I suppose. And from this color, we're getting the ambient light, while we keep the background light for the sky. And for this ambient light, we can also control the energy, and the same we can do for the sky. Although this you don't want to change too much. In my case, for the ambient light, the energy should be 0.6. That way, this color isn't too overpowering. And with that, we are getting a decent looking sky and the rest of the game looks quite colorful. So not too bad. Now for these options, you could add a bit more. For example, we could add sky, we could disable the entire thing. Basically, you want to play around and see what gives you the best color. To get good at using light, you simply have to experiment and see what works best. After a while, you get a decent feel for it. This covers the background and the ambient light. Next up, we have reflected light, which is super simple. We can either get reflected light from the background, disable it, or have the sky. If I use different options here, you can kind of see what's going on. Basically, from where the light is being reflected, if we use it from the sky, we are getting the sky from earlier. In fact, if I set the source to background, we don't get a sky at all. But if I set it to sky, we have a sky option, and in the sky, we have a procedural sky, and in there, we can set a custom color. Not something I want to do. I want to go with the background. But if you had a sky, you could change quite a few things in there. Not too important. Next up, we have the tone map. And this right now is set to filmic. If I change it to, let's say, linear, then we get a slightly different color value. If I look at Reinhardt or Aces, you can see we get slightly different color values, which you can also influence with exposure and white. It's kind of hard to explain the differences. I want to go with linear because I think it looks best. And don't worry, we're going to change this a bit. You could also stay with filmic, which I guess by default looks a bit better. After that, we get a whole bunch of weird sounding options. SSR, SSAO, SSIL, and SDFGI. SSR stands for Screen Space Reflections. If I activate this one, you can see in the background, that's going to be a bit hard to see. If I zoom in with the camera, not really visible either, very faintly visible. In the background there, we are getting a few reflections. I think you can see it there in the camera better. Effectively, this option makes the game a bit more reflective. So let's try to run the game, and then I can show you better. This reflection from the cave on the grass, we are getting because of the SSR option. We basically enable more reflections inside of the game. And this you can control, for example, with this slider, you can set how much you're getting. In my case, I don't want any of that, so I will keep it disabled. Next up, we have SSAO. This stands for Screen Space Ambient Occlusion. If I activate it, you can see what this one does. It gives us corner shadows. I think if I rotate the camera a bit towards the cliffs, this is going to be much more visible. Let's look at this side. And now, in the world environment, SSAO, enable and disable, you can see it especially in the fence and in the cliff. And these options you can also manipulate, so there you can get more shadows around the corners. I do want to have SSAO enabled, but I want to keep all of the default options. After that, we have SSIL. This stands for Screen Space Indirect Lighting. If I activate it, we're getting even more corner shadows, for which you can set a radius, and then you can tell quite well what's going on. Like with SSAO, I want to have this enabled with all of the default options. So radius should be set to 5. After that, we have SDFGI. If I enable this one, we're getting quite a strong effect that transitions in. SDFGI stands for Signed Distance Field Global Illumination. So effectively, this gives you a global light with a whole bunch of options, although I don't want to use any of this. I think the game looks fine on its own. And let's have a look at the player again. Next up, we have Glow, which is already enabled, and in there, we can do quite a few things. I think the most notable slider is Bloom. This one gives you a lot more glow on the entire thing. If you have this one enabled and you set the intensity, you can also make this even stronger. Now, in my case, for the intensity, I want to have a value of 0.09. Makes the entire thing a bit brighter. And for the strength, I want to go a bit down, 0.85. For the bloom, I want to go with the default value, so it's not too strong. And then for the blend mode, I want to go with screen, which is barely visible. The other options I'm not going to touch. And once again, in your game, simply play around with all of this and simply see what looks good. That covers glow. Next up, we have fog, which gives you fog. For this game, I actually want to keep a very faint amount of fog, with a color very similar to the sky. The value is A2, DF, E3. From that, you're getting a bluish color. And for this one, I want to set a density that is super faint, 0.0001. This is going to give us a super faint bluish color that you can see especially in the sky. Oh, and also, at this point, you might realize from this camera, we can see what the game actually looks like when it's being played. But in the editor, this looks different. Now everything looks a bit bluish. That's something that can be a bit annoying in Godot. The preview and the actual game are going to look different. Meaning, when you're working with light, you always want to have a camera preview somewhere in there. Otherwise, you basically have no idea what you are doing. Just to double check, let me run the game. And this looks fairly alright. That means, next up, we can look at the volumetric fog, and this one is giving you volumetric fog. For all practical purposes, this is very similar to fog, except a bit more powerful and quite a bit nicer looking. If I run the game now, we basically are playing Silent Hill. And like we have done for the normal fog, I want to keep the fog with a very low density, 0.005. If I do that, by default, we cannot really see a fog. However, if you look at the sky and I toggle the fog, you can see that with this option, our sky becomes a lot brighter. Effectively, the further away the fog is, the more visible it becomes, which especially for the sky makes a huge difference. Now besides that, you can add a few other things in here, but I'm not too concerned. Next up, we have adjustments. This I want to enable, and then we can set the brightness, the contrast, and the saturation. This one is super visible. You can make the game look really weird. Actually quite fun. If you want to have a super crazy game, this is actually hurting my eyes, so let's not do that. You do want to be careful here what you are doing, so don't change these values too much. For this scene, I want to go with a brightness of 1.1 and a contrast of 1.2. Gives the entire thing just a bit more punch. So let's try this again, and that is feeling nicer. With that, we have all of the environmental options. There are quite a few, and you can change a lot of things in here, which are also going to influence the game massively. Meaning this is a part where you really want to spend some time and practice things. There basically never is a universally best choice. You simply have different styles that you want to go for, and then you play around to get to that point. So once again, this is something you want to practice, which you are going to do for the dungeon in just a bit. But first of all, we have two more things: camera attributes and composer. Camera attributes are quite simple. In there, you can create a new camera attributes practical or physical. The easier one to work with is camera attributes practical. This one gives you blur and exposure. For blur, if you have far enabled, then we are getting blur. And you can set the far distance to set when the far blur should start kicking in. And I think to really visualize how this works, I want to select the camera and rotate it to see the entire level, something like so. If I now set the far distance, you can see we're getting blur at some point. On top of that, we can have a far transition. If you look at these rocks, the beginning of the rock is sharp, but the end of the rock is blurry. And the transition is super visible, which isn't really looking good. That is because our far transition is quite a small value. If you make that value greater, then you're getting a much smoother transition. In my case, for the far distance, I'm going to go with 150, with the far transition being 250. Also, we can set the amount to set how much blur we want, for which you want to generally have a low value, 0.06 in my case. Then we can try all of this, and we are blurring things the further they get. which is a pretty cool effect. Besides that, we can also set auto exposure, which makes the entire thing basically brighter or darker. This one isn't too important. That is basically all you can do inside of the camera. I guess one thing I didn't mention yet is when you have a camera selected, you can also set a field of view, which basically tells you how much you can see. Let's have a look at the player again. Right now, our field of view is 75 degrees. If I make this lower, we can see less. If I make this value greater, we can see more. Although I want to keep the default value here. With that covered, we basically have lighting introduced for this game. So let's go back to one viewport and try all of this, but we have already done that. So for the overworld, I am quite happy how this looks. Once again, for your game, you can play around quite a bit to see what works for you. But this is definitely a good start. And to practice all of this, inside of the dungeon, I want you guys to add a custom light to make this scene nice, dark, and atmospheric. Or in other words, add the light and the environmental node and set the values in such a way that the entire level looks quite nice. Pause the video now and see how far you get. To get started on the level, I want to add the sun, and then we can update the light and the shadows. For the light, I want to have something slightly darker, and I guess a good value here would be all 6s. Everything else I'm going to leave as it is, and then we can work on the environment. On this, we already have an environment. For the background, I want to go with a sky, which is giving us another sky option. In there, we have a sky subnode, and there we have a procedural sky material in which we can set a color. The sky color, I think, is totally fine, so I'm not going to change this one. But for the ground, I don't want to have a gray color, I want this to be pure black. That way, inside of this scene, this abyss looks like it's never ending. That's all I want to do for the sky. Next up, ambient light. For this one, I want to use a color, and then you can see inside of the background tab, we are also getting a color, which by default is pure black. Now for the color for the actual level, I really want to make sure that this thing isn't getting too dark. So I'm going to go with C7, C7, and C7, which is a lighter-ish color. The energy is totally fine. This we don't have to change. Next up, reflected light. Background here is totally fine. If you choose anything else, it wouldn't really make a difference either way. Next up, tone map. This I haven't changed one bit. After that, we have SSR, and while we are doing all of this, once again, I want to add a camera 3D, have a look at the player, get 2 viewports, with one being the camera, and make sure we are actually looking at the player. Like so. And this made me realize that Godot needs to be on the floor. So when we are starting all of this, Godot should be here-ish. Next up, world environment SSR makes the game look a bit better when we have it enabled. You can also play around with how strong this effect is going to be. I think the default value is fine. After that, we have the ambient occlusion, which is adding a lot more corner shadows. The default values for this one look fine. So next up, we have the indirect lighting, which I think is also a nice effect. After that, global illumination makes the entire thing a lot more blue, which I don't really like, so I am not going to use this one. Glow and fog I am also not going to use, but I do want to use volumetric fog. If we enable this one, the entire scene gets a lot darker, which I think is a bit too much. So let's go with 0.02. That still works. Finally, we have adjustments, which I don't really want to touch. Maybe make the entire thing just a little bit darker. Let's try the entire thing, and I guess that looks okay. The really important thing that you want to keep in mind here is that this dungeon scene and the overworld shouldn't be too different. The game should generally feel like it's one coherent thing, meaning the lighting shouldn't change that much. That being said, for the dungeon, we do want to have a nice, dark, murky atmosphere. Once again, play around. There isn't a universal answer. Also, while we are inside of the dungeon, I also want to have the camera blur, so camera attribute practical, depth of field blur, far enabled, and keep the same values, 150 and 250. Although I think for the dungeon, this isn't going to matter that much. I guess if we look at the far end, yeah, you can maybe barely see it, but this really isn't doing too much. Now, besides the world environment and the directional light 3D, there are a few more things that we can add to make the lighting feel a bit nicer. The first one is called fog volume. And for this, I want to move the camera just a bit further back, like so. And then you can already see in this part, we have just a bit of fog. And that we can influence by using these control points. We can drag out the entire thing and get a lot more fog. Can be a bit hard to control sometimes, but there you can see it much better. We are getting fog for the entire level. And this fog we can also control. We have a size slider inside of the inspector. Then we can set a shape and we can set a material. The default one is a fog material in which you can set density, you can set an albedo color, and you can set an emission color, which is going to be much more visible. Although for this one, I want to keep the default colors, but I guess we can make this a bit less black. There are a few more things that you could change, but they're getting a bit more advanced. Now, for this entire dungeon level, I want to have fog basically everywhere. Which means I want to drag this out to cover the entire level, like so. And before we start, I want to set the density back to 1. So we can see if things a bit better. Actually, let's go with 1.4. Next attempt. And then we are getting a whole bunch of fog, which, especially if you look over there, makes the game feel more like a dungeon. The sky here doesn't help too much, so once again, experiment and see what looks good. Finally, besides that, Godot has different kinds of light. At the moment, we have only used a directional light 3D. Besides that, if I type in light, we also have a omnilight and a spotlight. An omnilight is basically a candle, and a spotlight is a flashlight. Or in other words, if I add an omnilight, we are getting a little object that emits light in all directions equally. I guess for that one, if we look a bit to the right, there we have a torch on the wall. And this I want to illuminate via this light node. And then for this omnilight, we're getting light in all directions equally, for which you can also set a range and basically a strength. Although the default values I think are totally fine. Besides that, for the light, you can set a color. For the torch, let's say I want to have a more reddish color. And for this, you can change the energy. You could, for example, flicker this one, but I'm not too concerned. That would be the first light. It's super easy to use. There isn't that much to it. Besides that, we have a spotlight, and this is basically a flashlight, which means if I point this at the player, like so, and look at the entire thing, this spotlight at the moment points towards the player, and from that we are getting light, which at the moment isn't really visible, but if I increase the energy, you can see it much better. If I increase the range, we're getting, well, more range, and the attenuation gives you a lot more energy. Finally, via the angle, you can make this entire thing really wide or really narrow. For this kind of light, I couldn't really find a good purpose inside of the game, so I'm going to delete it. With that, we have covered light for the entire game. Or at least I have introduced it. There's a lot more that you could be doing. But I don't want to spend too much time on it. Instead, I want to talk about some other things that you occasionally see inside of a level. Specifically, I want to talk about two things: having an object follow a path and physical interactions. To get started, I want to add a bird following a path that is going to be on top of the level. So the bird is going to fly around here somewhere. For that, we need two things, a bird and a path. The bird you can find inside of graphics. There we have environment, objects, and then we have bird red body GLTF, a red bird. Notice here, for this bird, we have the compressed textures, meaning this bird isn't going to look amazing. But that's totally fine, since this bird is far away, it's not going to matter. Number two, we want to have a path. And for that, I want to have inside of perspective the top view. And then create a path. I guess this we can do inside of entities. In there, I want to add a path 3D. To this, we're going to add a path follow node, and then this path follow node is going to follow the path. But first of all, we want to have a path 3D and then draw a path. So simply select a couple of points and then make sure when you want to close the path, you want to click on this icon, close curve. That way you're getting a proper closed curve instead of 2 points that are right next to each other. Besides that, you can also select this option and then shift drag these nodes and curve them out. With that, I can create a much nicer looking path that is more rounded. And something like this, I guess, is okay. Also, really important at this point, at the moment, we are looking at this thing from the top. If you look at it from a different angle, you can see it is really low, which for now is totally fine. It actually makes it easier to see what the bird is doing. But later on, we can move the entire thing up to somewhere here. That way, the bird is actually in the sky. Next up, to this thing, we want to add a path follow 3D node. And then this thing has a progress bar, which lets you follow this path. And that's literally it. This is working like it does in 2D and is generally fairly straightforward. Although in my case, the way I want to use it, let me get rid of this node and instead create a new scene. With the parent node being path follow 3D, which I want to rename to bird. To this node then, we are going to add the bird red body model. And right now, Godot didn't add the texture. Although inside of the import statement, it does have it. So I think if we just re-import the entire thing, it should work. And there we go. Now we have a bird. Sometimes it can be a little bit weird. Anyway, this is the bird that we want. Besides that, I want to save the entire thing, which we are going to do inside of scenes. And in there, I guess it could be in entities. And let me add another folder for other. And then I want to have bird.tscn. To actually use this bird, I want to go to overworld and then add the bird as a child to our path 3D. And then, if I zoom in just a bit, we are getting the bird in this position. And if we increase progress, then the bird is going to move. Although this you want to do very carefully because the movement is quite fast. If I look at it from this side, you can see we are moving the bird. Although, if I zoom in a bit more, you can see that the bird is going the wrong way. Or in other words, the bird is flying in this direction, but is pointing the other way. To fix that, you simply want to enable Use Model Front, and then you are good to go. Which means what we can now do, inside of the bird, we can add a script to it inside of the same folder. That's fine. Then we want to cover function underscore process and get progress of the node. So inside of path follow 3D, we have progress, and this actually moves the path follow node along the path. This value we want to increase by some kind of speed. Let's for now go with 40, and don't forget multiply with delta. That should be it. If I now go to the overworld, run the entire thing, then we should be able to see the bird flying along. And it is a bit hard to see, and the blur does not help, but the bird is definitely moving. I suppose what we could be doing is move the entire thing a bit closer to the player, although I'm not sure if that is going to help very much. Let's try it again now, and there we can see the bird moving along. Looks alright. So this is definitely working. Next up, I want to animate the bird just a bit. And for that, I want to right-click on the node and then make local. That way we get access to all of the meshes. Those I want to add straight to the parent node and then get rid of the bird red body node. Just makes the entire thing a bit easier to organize. After that, I want to add an animation layer in which I want to add a new animation called bird underscore flap. For this animation, I want to add a property track and then move the left wing and the right wing. Let's start with the left wing, edit, and on this thing, I want to get the rotation. Also, let me zoom in just a bit on the animation timeline, like so. That makes it a bit easier to see. First of all, when we are starting the animation, I want to have a Y rotation of 0. Then I want to go to 0. Let's say roughly here, 1.67 seconds. Add another key, and for this one, I want to have a Y rotation of 30 degrees. And that way, we are getting the wrong angle. So let me look at it from up here. Right now, the wing is going this way, which obviously isn't correct. Or in other words, I don't want to rotate along the y-axis, I want to rotate along the z-axis. That way, we are getting the wing going up and down. Much better. Right now, the wing is going up. A bit later, I want another key where the wing is going down to, let's say, -30. That way, the wing goes up, the wing goes down. I want to stay down here for just a bit, so another key with the same value. And then around 0.6 seconds, I want to go back to the default value. 0 seconds, and then the entire thing can be 0.6 seconds long. Also, this should be repeated, meaning if I play the entire thing now, we are getting a very basic wing flap. This I also want to do for the other wing, which means add track, add another property track, wing right, and get the rotation. For all of that, I can copy these keys. So select them, Ctrl-C and Ctrl-Shift, and then we are getting almost the right behavior. Since we're now working with the other wing, we have to invert these values. So positive becomes negative, and negative becomes positive. Which means this should be positive 30, this should also be positive 30, and then we should be good to go. Now let's try off this again, and the bird is flapping the wings. Perfect. That means now, inside of the overworld, this should be working. Although, before we work on that, I forgot one thing, and that is that we want to autoplay this animation. So now, let's try the overworld again, and then we should have a bird animation. And there you can see it. It's barely visible, so we don't have to worry too much about the animation or the textures, but I think this is alright. Which means I can select the path 3D and move the entire thing up by a fair amount. That is definitely too much, so let's go here. And try the entire thing again. Now we should get bird somewhere up there. I think this was still too high. Once again, creating a level does take quite a bit of time. Play around with this quite a bit. See what looks good. Maybe now it works. There should be a bird somewhere. And there we can see one bird on top, just flying around. The blur even makes it disappear, so this is a nice bonus. Generally, having a path and a path follow node is super easy to work with, so I don't think this is going to cause you many troubles. Which means we can finish this part and close the bird. That covers another topic. Next up, I want to do just a bit of physics. In other words, inside of the dungeon, let's have one viewport for now. If I look at Node 3D, there we have somewhere the collision objects 3D and the physics bodies. So far we have seen a static body, a character body, and an area 3D. Besides that, in 3D, you're getting quite a few more options. The first one is a physical bone 3D, and the second one is a rigid body 3D. And as a child of that, we have a vehicle body 3D. Vehicle body and physical bone 3D do become a bit more advanced, but I do want to cover rigid body 3D because, in the most basic sense, it's quite simple. If you have used this one in 2D, you should feel right at home. So let's add this one, and then we have a rigid body 3D, which, like in 2D by default, is giving you a warning that this node has no shape. Let's add a graphic to it, let's say the barrel, and then for this barrel, I want to make it local, so we are getting the mesh and can discard the static body. I only want to have the mesh itself, nothing else. Now we have a barrel, and for that thing, I want to create a collision shape, which should be a sibling and trimesh. If I'm doing that, we're getting a collision shape 3D. But now Godot is going to complain again. When used for collision, concave polygon shape 3D, this is what we have created with this option up here, is not going to work well because it's intended to only work with static objects. For rigid body 3D, this is not good at all. So let's not do this one and get rid of it. So what can we do instead? Well, there are two ways. Number one, you could simply add a basic collision shape 3D and then select one of these options. For the barrel, you could go with a cylinder shape and then update the shape so that it roughly fits something like this. Obviously, refine it. But this, once again, is not going to be perfect because the barrel isn't a perfect cylinder. As a consequence, this isn't what I want to do. Instead, once again with the barrel 2 selected, I want to go to Mesh and create a collision shape again. However, now I don't want to have a trimesh, I want to have a single convex. If I create that, we are getting a mesh that works really well for the barrel, so we are covering the shape basically perfectly, and Godot is not complaining. So once again, when you're creating a mesh, try these different options. Some of these do work with physics, others do not. You just have to experiment and see what works best. Anyway, now that we have that, let's move the barrel, I don't know, roughly here. And if I now play the scene, this should do something already. And there we go. Was a bit hard to see, but we're getting collisions, and the barrel fell from an elevated position, so we do have gravity. I guess if I move it a bit over to this side and move it up with some rotation, you are going to see this much better. Next attempt, and now the barrel is falling, and we're getting basic physics. That is pretty much it for physics. And as a reminder, a rigid body 3D is more or less a physical object in the real world. Or in other words, if you want to move this thing, you have to apply a physical force. If you look at the inspector, there we have a rigid body 3D, and for example there we can apply a linear velocity. For example, for the linear velocity for z, let's give it a value of 5. And then also, I want to move this barrel just a bit this way, so we don't hit Godot right away. Let's try now, and if I run the game, the barrel is going to be moved in this way. Or instead of moved, I should say, when the game is starting, we are applying a linear velocity in this direction. Although by default, this is not what I want to do. Instead, I want to move this barrel as a consequence of a collision with Godot. Or in other words, let me run the game again. If Godot is colliding and pushing the barrel, we should actually move the barrel. When we are colliding, there should be a physical force applied to this barrel. For that, we have to write just a few lines of code inside of the player. All the way at the bottom, I want to have another function. Let's call it physics logic. No need for parameters, and we are not going to return anything. For all of this, I first of all want to get all of the collisions with physical objects, which I can get with for I in get slide collision count. Inside of this for loop, we want to get the actual collider, and this we can get via get slide collision, and this wants to have a slide index that we're getting from the for loop, meaning in there, I want to insert I. On this collision, we can get the collider. meaning this is the actual object we have collided with. And after we have that, we can simply check if the collider is a rigid body 3D. And then we can do something with this rigid body 3D. For example, we can get the collider and then apply a central impulse, which wants to have a vector 3. So let's give it one vector 3. For now, let's simply go with right. This should already work, although we do have to make sure that we are calling physics logic. That should happen inside of physics process after move and slide. Physics logic. After that, I can run the dungeon scene, and if I collide with the barrel, I think from here, it looks pretty alright. But that is because this direction is to the right in terms of Godot spaces. And I just happen to move from here, so it looks okay, but if I go from any other direction, let's say here, the barrel is still moving in this direction and then stops on this pile. I don't always want to move the barrel to the right, I want to move it relative to the player. For that, we have to get the slide collision once again. Let me copy it in there, and on this thing, we can also get the normal via get normal. To understand in normal, imagine the game right now from a top-down perspective. We have the barrel here, and we have the player coming from this side, touching the barrel on this point. The normal, in this case, is going to be this direction. And we want to move in the opposite direction, so this value needs to be negative. If I now run the dungeon scene again, I can collide with the barrel and move it in any direction. I can also move it a bit closer to this abyss and then try to jump on top of it and go to the other side. That works really well. And with that, we have very basic physics interactions. It really doesn't need that much work. All you have to know is how to get a physics object, or more specifically, a rigid body 3D, and then you need to be able to apply an impulse along with a direction. Now, generally, physics is a larger field, so I don't want to spend too much time on it, and this would be a separate tutorial. Simply because if I go outside of the maximized view and go to the Add Node tab, in terms of physics, you have a rigid body 3D, and you have a whole bunch of joints. Although for this game, I couldn't really find a good way to use them. So instead, I want to rename the rigid body 3D to barrel and then move it into the environment. And this is going to cover the physics part of this tutorial. Once again, you can do a lot more with physics, but I think this video has gotten long enough. So let's keep it a bit more simple. Which in my case means that I want to have a level transition and some enemies, and then we are done with this part. I think the level transitions are a bit simpler. All we want to do for that, let's say inside of the dungeon. When the player gets close to this area door thingy here, then I want to do something. And that something is load the overworld. With the door mesh selected, I want to add an area 3D, which I want to rename right away to door area, and then add a collision shape 3D. To that thing, I want to add a box shape and then arrange the size so we get something that's a bit easier to hit. Doesn't have to be perfect, but it should be easy to get to. This works reasonably well. When the player gets into this area, I want to emit on the area node body entered. And for that, inside of the inspector, make sure the collision layers are correct. This area should not be on any layer, so nothing can see it, but it itself can see the player. So mask layer 2. After that, we want to have body entered and connected to the level. However, that's not going to work yet, because inside of the dungeon scene, I want to load the overworld. And in the overworld, I want to load the dungeon scene. Which means we need to know in what scene we are in, and then run some custom code. I think the easiest way to approach that, if I open the level script, I want to turn this into a class with class name and call it level. That way, inside of the dungeon, for example, I can remove the script, add a new one, dungeon.gd is totally fine, and then this should extend the level class. And also at this point, I realized that the parent node should be called dungeon. That I think makes a bit more sense. After that, we don't need the default methods, and instead I want to get the door area and connect the body enter node. And just to make sure this is working, when the player enters, let's print player entered. Then I want to try the dungeon level, and we simply have to run towards the door, and we should get something. Player entered. Perfect. If that is the case, I want to call a function, let's call it switch level, with a target being the overworld. Now this function doesn't exist yet, which means I want to create it, but I want to create it inside of the parent level class, because that way we can reuse it for the overworld. Func switch level with a target that should be a string. For now, let me add pass in here, because before we can do anything else, I want to create a const dictionary with the scenes. All that we're going to do for this one. We have, for example, a dungeon level, and the path for this one will be inside of scenes. There we have levels, and in there we have dungeon.tscn. Drag this one in there to get the proper file path. The same thing I want to do for the overworld, meaning you simply want to drag overworld.tscn in there, like so, and then you're good to go. That allows us inside of switch level to simply get the tree, don't forget to call it, and then change scene to file. For that, Godot wants to have a file path to the scene that we want to load, which in our case, we're getting from the scenes dictionary. And from the dictionary, we are picking one scene via the target parameter, which we are then calling, for example, inside of the dungeon. Godot should be happy. That looks pretty good. Let's try all of that. And if I run into the door area, we are getting to the overworld. So that's looking pretty good. Now you could add a transition here. That would actually make the entire thing look much nicer, but in my case, once again, I want to keep it simple. Although, what we do have to keep in mind is that the debugger is unhappy for two reasons. Number one, the parameter body is never used. That is not a problem, we can simply add an underscore, and then this is not an issue anymore. Besides that, inside of switch level, down here, Godot is complaining that we are removing a collision object. And it really wants us to use call deferred instead, which we do via call deferred down here with a function name. Let's say in this case, I want to call underscore switch level. And afterwards, we have to pass in an argument, target in this case. From that, we can create a function underscore switch level, the same name that we have used up here, along with an argument, target, which once again needs to be a string. And then in there, I want to do the thing I have done earlier. Via this call deferred, Godot is making sure that we are not messing with physics while we are changing the scene. I guess that's a bit overly simplistic, but it gets the job done. Let's try all of this now. Once again, the game is running, and if we walk into a door, we're getting the overworld, and the debugger is happy. Perfect. Which means we can work inside of the overworld, and I want to move the player towards the castle area. So for that, player selected, and I guess if we look from the top, this is the easiest way to move everything. Then zoom in and place Godot roughly here in front of the castle. And also make sure that Godot is not floating in the air. So I guess down here, That looks about right, and make sure we are basically perfectly on the floor. Looks about alright, just to test things. Looking good, perfect. So now to the castle, we can add the same thing that we have done for the dungeon. Inside of the environment, I want to find the castle down here. Add an area 3D that I want to rename right away to castle area, which is then going to get a collision shape 3D. And for this at the moment, we have to rearrange the area 3D first of all. Let's move it here. Once again, this does not have to be perfect. And I guess if we add an actual shape to the collision shape, box 3D, you can see a bit better where we are. Make sure you have the collision shape 3D selected so you can see the actual shape, and then you want to move it in front of the door. There you can faintly see it. We have the blue outline for the collision shape. This I want to rotate a bit so we are covering the entire area, and then move it here. Once again, for real game, you want to fine tune all of this a lot. But for my purposes, I guess this is fine. Cool. With that, we can get the signal from the area 3D. Although that, I want to capture in the overworld, which means I want to remove the script, add a new one. The default stuff here is fine. I want to get rid of the default functions and then inherit from level. After we are doing that, we want to go to the castle area, body entered, connect. Oh, and also, I forgot, inside of the collision area, we only want to have a mask for layer 2, meaning we can only see the player. In there, I don't really care about the body. In fact, all I want to do is call switch level with the target being the dungeon. That should be it. If I now run the entire game, I can run into the door. We are loading the dungeon level, and if I go back, we are back in the overworld. So that is working fairly well. Perfect. So with that, we have a fairly basic level transition. Obviously, having actual transitions like fading to black and then fading out again would be better, but that's not too hard to implement. Which means, next up, I want to add a couple of entities, so the enemies and the boss, and then we are good to go. And in the most basic sense, this should be really easy. To the entities node, I want to add, for example, the skeleton mage, and then just to test things, let's move that one close to the player. Here, make sure he's not floating in the air. That's actually going to be an issue in just a second. So make sure he is kind of close down here, and then move him roughly there. If we now try all of this again, you can already see a bit of an issue. Namely that for the enemies, so let me open enemies.gd, this one. When we are moving the enemy, there's no gravity whatsoever. And as a consequence, if an enemy is floating in the air, there's no way to come down. Luckily, this is easy to fix. Inside of enemy GD, and more specifically move to player, I also want to have a small bit for gravity. I want to check if not is on floor, and if we're not on the floor, then I want to get velocity.y and subtract some small value, let's say 2. If that is not the case, else, meaning the enemy is on the floor, then velocity.y should be 0. That way, inside of the actual level, the enemy is going to fall down until we reach the floor, and everything else is still going to work just fine. I can also attack this enemy. That looks good. Now, you might be wondering, how do we get this enemy to walk up? So there's a small hill, a bit hard to see, but there, basically, everything works automatically because the collisions here help us a lot. And let me explain actually. So this might be very hard to see. Just have to find a good spot. But just imagine we have a hill going up this bit. If the enemy gets on this point and goes up, then the collisions are going to push him up. the only issue that we have to worry about is gravity going down, because for that we had no logic whatsoever and no collisions to move the enemy up or down. But, well, besides that, I want to add the skeleton warrior as well, which should work by itself because we are once again inheriting from the enemy class. Let's hope this one doesn't cause problems. Let's move in right to the floor. Like so. There we go. And we can try all of this. And he's walking towards us, along with going up a hill. That looks pretty good. And I guess we should try again going downhill. Make sure he's following us. Now, one limitation of going down a hill is that the particles always go in a straight line. So this isn't ideal, but that's a minor issue. You can fix that in your own time. Besides these two enemies inside of the dungeon, I also want to add the boss in this larger bit, which we can do super easily. Entities, add the boss, and then move him over here. Then we can test all of this, and I just have to make sure I don't fall into the abyss. There we go. And now we have the boss. The boss is walking towards us, and we're getting particles. And I'm not sure if I reactivated the spin attack from earlier. Let's check that in a second. But first of all, we're getting the other attacks, and we can attack the boss. All of that is still working just fine. Inside of the boss, I want to make sure that we don't get the range attack down here. This should be the spin attack. Sorry about that, I should have fixed that ages ago. Anyway, with that, we have level transitions, and we have enemies inside of the level. Now for this thing, you could add a lot more enemies throughout all of this. That I think you can do on your own. At this point, this shouldn't be much of a challenge. In my case, I think we're good to go for this part. We are nearly done with the game. The last part will be about adding some nice visual bits to make the game look much better. Meaning we are going to work on 3D shaders and particle effects. Both of those can get really complex, so I will try to keep it as simple as possible. But even with that, it can still get quite easily confusing. I suppose we can start with something simple and then work our way up. Here we are back in the game, and I want to start with some basic particle effects. Which means, let me try to find the player once again in front of the castle. When the player is running around, I want to spawn a couple of particles. And I think the best place to do all of that is inside of the dungeon. So let me open dungeon.tscn. And then I guess we can also hide the fog. That way things are becoming a bit more visible. There we go. Besides that, I also want to open player.tscn. Inside of the player, I want to add another node. And if you go to the dialog and type in particle, you can find a lot of stuff for 3D particles. We have GPU and CPU particles. But besides that, for the GPU particles, we have a lot more stuff that we could be working with. That is because in 3D, we can have particle collisions and particle attractors. That way you get a ton of control over the particles, but that's not something I'm going to cover. Instead, just to get started, you want to work with GPU particles. And once again, as a reminder, GPU particles are more powerful than CPU particles, because the GPU can do a lot more. You basically only want to use CPU particles if you are targeting a really weak system. Say, for example, you want to work with an old phone or a website, then CPU particles might be useful. But most of the time, GPU particles are what you want to go with. Then you click on Create, and then we have GPU particles with a couple of warnings. At the moment, Godot is complaining that we are missing two things: draw passes and the material. Both of those you can find on the right side. There we have the draw passes, in which we can add a pass. That comes in a second. And besides that, we can have a process material, which can be either a shader or a particle process material. In my case, I want to use a particle process material. And if I select that, not much is going to happen. Also, while we are here, let me hide the Godot skin so we can see what's going on. And at the moment, we can see that, well, we can't see anything. For that, we will need draw passes. You simply want to add draw pass and then select a shape. I want to go with a sphere mesh. And then you can see something. Effectively, via the draw pass, you can select the shape, and via the material, you can set the behavior. For example, inside of spawn, the position, you can have a point emission or a sphere emission, and loads of other things. If you want to change the color of these objects, you could click on the pass and in there add a material. This can be lots of different things. I want to go with a standard material 3D. And then in there, you are getting the usual options. So for example, if you wanted to make all of this super red, you could do it. Although not something that I want to do. In my case, for the color, I want to make it a bit darker. So B2, 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 which is a fairly light gray. Besides that, I want to remove this specular. So these boards look a bit more flat. And that's basically it. With that, we have the object. Next up, I want to work on the process material, because in there, we can set the actual behavior. Effectively, these particles should be emitted when the player is running, and they should go in the direction opposite to the run direction. Also, they should be going upwards, which means we have to make a few changes. First of all, inside of the spawn position, the emission sphere should be 0.6. That way, we're getting a slightly smaller radius, and if you compare this to the player, you can already see that we have to make a few more changes. Next up, I want to look at the accelerations, and in there we have gravity. If you set this to 0, then we don't get any movement. But in my case, I want them to move up by just a bit. I guess a value of 1 here is totally fine. Next up, I want to look at display and scale. In there, we can set the scale, which in my case is going to be a value between 0.1 and 0.3. That way, all of this looks significantly more appropriate, which I think is already doing quite a bit. Let's try to run the dungeon scene and see what this is doing. So we're getting particles, that looks pretty nice, and if Godot is running around, they also look fairly nice. Besides that, inside of the player, or well, the GPU particles, and those should actually be renamed to run particles. I think you get the idea how all of this is going to work. We can set the draw passes, and in there, we can set the shape and the material. Besides that, we have the process material, and this determines the behavior of the emitter. And there are loads of options that you could be playing with. And that's pretty much it for basic materials. I guess another thing I haven't mentioned yet is that you have the amount. If I set this to, let's say, 100, we're getting something crazy. And you could also, inside of time, make the entire thing more explosive. That way you get more particles at once. It could also be one shot and loads of things that I think are fairly straightforward. Now in my case, I don't really want to go into too much detail, so an amount of 10 is perfectly fine. Although there's one more thing that I do want to cover. If you go down just a bit further, under geometry, you can set cast shadow, which in my case I want to be off, and we can give this a bit of transparency. Let's say 0.25, maybe. Something you want to play around with. But anyway, let's try all of this now. We should not get a shadow for the particles anymore, and they should be a bit more transparent, which I think looks alright. Let's try all of this inside of the overworld, and still looks okay. Not amazing, but for a basic game, it's good enough. That being said, I only want to play these particles when Godot is running, for which we are going to need just a bit of code. Inside of the player, and let me expand all of this, I want to first of all get the particle emitter, which we can store under the UI on ready var run particles is going to be, and now we can simply drag the run particles in there like so. That way we can control the run particles much more easily. After that, when Godot is running, inside of the move logic function, we want to start the emitter, which effectively means at the end of the function, I want to get run particles and then dot emitting. This value is either going to be true or false. This value we are getting by, first of all, checking if Godot is on the floor and Godot is running. And I guess we can also check if the movement input is different from vector 2.0. Or in other words, this value is going to be true if Godot is on the floor and running in a certain direction. If any of these values is false, then we are not going to get any kind of emission for the particles. If I now run the dungeon scene again, we don't get particles by default, and if I walk around, we also don't get anything. But if I start running, then we are getting particles, which looks pretty good. Perfect. And well, that is basically it for particle effects. They are not that complicated, at least as long as you're working with basic concepts. Obviously, if you start adding other kinds of nodes to it, like attractors or collisions, you could also add shaders to all of this, then things get a lot more complicated. But that would be a separate tutorial. So I want to keep it simple and do an exercise. Inside of the dungeon, we have a torch that right now looks a bit boring, which means I want you guys to add a particle effect in here to make all of this look much better. Or in other words, for the exercise, create a basic particle fire effect for the torch. Pause the video now and see how far you get. Back inside of the game, I want to create a new scene, 3D. This should be let's call it a torch. To this, I want to add the torch scene that we have already seen. And then we can add a GPU particle 3D node, which we first of all have to move around just a bit so we are inside of the torch, like so. That looks all right. After that, we will need the draw pass and the material. For the draw passes, I want to have, once again, a couple of spheres. And for the process material, a basic particle material. That way, we're getting behavior, and I suppose to get started, we can add a standard material 3D, and then give it an albedo color. This one should be a bit more reddish, something like that to get started, should be alright. That's all I need for this part. Next up, inside of the particles. For spawn, I want to have a sphere position that gets 0.2 in terms of the radius. And let me expand all of this. That's a bit more visible. And besides that, for the accelerations, the gravity, I want to have a default value of 1, which is already helping a lot. Next up, for the display and the scale, I want to scale all of this down by a lot. Let's start with 0.1 and 0.2. That is getting us a lot closer. Besides that, we can also set a color curve, which by default is going to be white. So for this, I want to set a color ramp, which is a gradient 1, where I want to go from a red color to a more yellowish color. Something like this. Now, this at the moment hasn't really done anything. We do not get a yellow color whatsoever. And that is because inside of the material, we are only using the albedo color, which is a good start, but not good enough. Instead, what we want to do now, since we're getting the color from this color ramp, we want to enable vertex color use as albedo. This one should be on. And now you want to have a white color for the albedo. And that is looking quite a bit nicer. Although not perfect yet. We want to have a lot more red in there. Something like that. And I guess the yellow color could be a lot more orange. This is something you really want to play around with and just see what looks good. I guess I can go with a lot more of a red color. In your case, just play around a lot more with this and you should get somewhere nice. Since the player isn't going to look at this too much, and let me save the entire thing actually inside of, I guess, scenes and VFX. Yeah, we can have the torch. And then we get something decently okay. After that, inside of the dungeon, in the environment node, I want to add the torch.tscn and move it back to where we used to have the torch. And we can place it pretty much there, and I think we have to rotate it. Like so. And then try the entire thing. Cool. That looks alright. I think we need a lot more particles, which we can do very easily. Inside of the torch for the particles at the top, I want to go with, let's say, 30. Try all of this again. And then much better. So once again, play around. And if you add a shader to all of this, it could look even better. Also, what we can do at this point, since we don't need this torch anymore, and this torch was supposed to be lit up by a light that I just have to find. It was this OmniLight 3D. All of this we can combine. I want to cut out the OmniLight and paste it inside of the torch. Then save the scene, go back here, and then get rid of this torch. We don't need it anymore. And instead use the other torch, which should also give us the light now. Although I guess it's a bit hard to see. I want to get all of this a bit closer, like so. And then we're getting just a bit of light, which I definitely want to be closer to the torch itself. There we go. This feels a bit better. And this is also much better organization. Meaning now we have a torch object with particles and light, which you can just place wherever you like inside of the scene. You could copy it and then move another torch over here without any problem. And with that, we have GPU particles. Now, obviously, there's a lot more you could be doing with particles, but that is going to be another tutorial. In my case, I am good to go with the dungeon and with the player and also with the torch. Next up, I want to work in the overworld and add a whole bunch of shaders. 2 in particular. One is going to be for the water, meaning at the moment the water is super boring. It's basically just a blue mesh that doesn't do anything. This we want to animate via a shader. Besides that, I want to add some grass to all of this, which is going to be another shader. This means at this point, we have to come to the really fun part, 3D shaders. I think if we get started with the water, that's going to be the easiest part. And for that, I want to create a new scene, which is going to be a mesh instance, for which the mesh is going to be a plain mesh, which we also have to scale up quite a bit. I think in my case, I went with 500 by 500. And this I also want to save inside of the VFX folder. Although before that, I want to rename the parent node to water and then save it in here. After that, in the overworld, we can get rid of the water mesh that we have used so far and instead add water.tscn, which right now is going to be a giant mesh that we have to put in the right place. So roughly here, and make sure you are getting the bridges mostly okay. Doesn't have to be perfect, and you can make changes later on quite easily. But alright, this is looking pretty good. Now, before we continue, another thing that we have to do. Essentially in a bit, we're going to drag the vertices of this mesh and then move them up or down, which at the moment is not going to work well, because if you look at the wireframe, you can see that we don't have that many vertices to begin with. Luckily, we can change that very easily with subdivide width and depth. In my case, I want to have a value of 100 for each of those. And then you can see we have a whole bunch of vertices that we could change. I can demonstrate in just a second how this is going to become important. But for now, let's go back to display normal. And then we can start changing the color. For that, I want to go to Material, create a new shader material. And in there, we have to create a new shader. To get started, I think using a visual shader is going to be the easiest. This one has to be spatial because we are in a 3D space, and then we need a name. I guess water.trace is totally fine. Now click on Create, and then click on water.trace. After which, you are getting a visual shader system. And let me give just a bit more space so we can tell what's going on. Also at this point, I hope you have done at least a few basic shaders before. I guess I have already used a shader on my own for the heart, but this one was super simple. Once again, if you have never used a shader before, check out my short video series on them. It's going to be super helpful. Anyway, like in 2D, you would add nodes here to get certain kinds of behavior. For example, you could add a color parameter, which is going to be the water color. For this one, I want to have a default value that is going to be blue for the obvious reasons. Something like this. And this I want to connect to albedo, after which we're getting a blue color. If I save the entire thing, go back to the overworld, now we are getting blue water. Pretty good start. And I think we have to move all of this just a bit further in this direction. Cool. With that, we can change the color fairly easily. Also, I think while we are here, let me minimize everything and then add a camera 3D again, just to get a slightly better view of what's happening. I want to have two viewports again, and then have the preview on this one. Then we can look at water in quite some detail. I guess like so works well. And we can look a bit further down. Right now, we have a color parameter that is giving us a blue color, which is a vector 4, and this we're using for albedo, which is a vector 3, and via the node system, we are simply ignoring the fourth value. That's all that's happening in here. Besides that, for alpha, Godot is expecting a float. You can see that by the gray node. And that we can add with, let's say, a float constant, and then give this a value of, let's say, 0.9. which I then want to connect to alpha. And this is a bit hard to see. Let's go with 0.5. Much more visible. Also, the difference between a constant and a parameter is that a parameter can be changed from inside of the inspector. Or in other words, if I go back to the water, once we have a parameter, we get shader parameters, and there we have the color, which we could change to whatever we want. But the default value is blue, which I want to keep. Besides that, for now, I want to make sure that the roughness for all of this is getting also a value of 1, which is going to be another float constant, and this I want to connect to the roughness. This value being 1 makes the entire thing less shiny, which I think for this kind of game is a good effect, although in practice this is quite hard to see. Anyway, with that, we are getting a basic color, which still isn't doing very much. This is not moving whatsoever, so the water is fairly boring. That being said, if I try the entire thing and simply look at it, it's not completely terrible. But once again, very boring. So we want to animate this. And for that, we want to look at a different kind of shader. At the moment, we are creating a fragment shader. Besides that, we also have a vertex shader. This works like in 2D. Via a fragment shader, you can change the color and the alpha, along with a few other things. With a vertex shader, you are updating the position of the vertices. Or in other words, if I go back to the wireframe, via this vertex shader, we can update all of these points. The way this is going to work is we have to update this vertex parameter, which means, first of all, I want to get the current vertex position of the, vertices. This is going to be a vector 3 with x, y, and z, which means once we have that, what we could be doing is add a value to it, which also should be a vector 3, and then connect it to the output. Then by default, nothing is going to happen because these values are 0, 0, and 0. But if I change them, let's say for x, I increase the value, then we're moving the entire thing further to the right, or to the left if the value is negative. And this also works with y. Let's say if this value becomes 200, then we're moving up by a lot. A bit hard to see because the sky is blue. That's much better. So effectively, via this operation, we are moving all of the vertices in the same direction, which is a good start, but not exactly what we want to do. Instead, I want to have a random value that we want to add in here. And this random value we can get from a texture 2D. Once again, this works like in 2D. Texture 2D, and on this thing, we want to add a noise texture 2D. Inside of that thing, you want to make sure it's seamless, and then you want to create a fast noise light inside of the noise tab. After that, you can see a noise, and the noise I want to go for is cellular, with fractal being none. That way we're getting this beehive kind of looking thing. To make it a bit more pronounced, you can get Euclidean squared. That way you're getting more extreme values. You can play around with these values a lot. For example, adding a bit of jitter can make it look nicer. There's also domain warp to get a bit more randomness. But this is something you can fix on your own. In my case, I simply want to get the color values of all of this and then move pixels up by the amount of white that we have inside of this picture. Or in other words, if we have this whitish bit here, then I want to move the pixels up by a lot, but only for this part. If we have a black value, like in this bit or in this bit, those would be roughly here and here, I guess, those should not be moved up at all. And well, this part is actually already basically done, because all we have to do is get this vector for color and plug it into the add node. That way, right now, this is very barely visible. So for example, there you can see a very slight tilt. The issue at the moment is that the values we're getting from this texture 2D are very small. At best, if we have a white color, we're moving up by 1 pixel, which is very small given that the size of this thing is 500 by 500 meters. To fix that, we want to multiply these values by a certain amount, which we can get via a float parameter. I want to call this one wave height. And this value I want to multiply with the vector 3, which means I want to have multiply vector 3 has the wave height in there and then the texture information for the second value. And this value I want to add to the current vertex position, which right now doesn't do anything because the default value for the float parameter or the wave height is 0. As a consequence, this value becomes 0 as well. To fix that, let's give it a default value of, let's say, 5, and then you can see much better what's happening. So now, I guess if I make this a 10 or even a 20, you can see much better what's going on. I guess even better, if I remove the transparency for now, this becomes much more easily visible. Actually, that didn't help. So back inside of the fragment, I want to have alpha, and then look at the vertex. And if we look at just the right angle, you can see what's going on. We're getting a water kind of shape. That is because wherever inside of the texture we're getting a white color, we are getting a value of 1. And this value at the moment we're multiplying with 20, and that value we are then adding to the vertex position. Now at the moment, we are adding it to all 3 parts of it, so X, Y, and Z, and we are moving all 3, which isn't really needed. We only want to move the pixels up or down. But I guess moving the entire surface a bit further to the left and a bit further down doesn't really make that much of a difference, and this keeps the entire setup more simple. So I can leave it as it is. With that, inside of the overworld, let's try all of this. This is going to be very hard to see because we always have the same color, but you can tell if I move down here, we are definitely getting some waves. Not too bad, but definitely needs improvement. And the most important thing that we have to add is that whenever the water gets higher, so if we have a wave, like for example, this bit here, The higher we get, the more of a white color I want. Which means we have to get this texture 2D into the fragment shader and then use it to affect the color. That we can do in a couple of ways. For example, you could copy the texture and then paste it into the fragment shader. Possible, but not really elegant. Instead, you would rather want to create a varying. Via that, you can move values from a vertex to a fragment shader. The way it works, you want to click on Manage Varyings and then Add Varying. Then you can set a data type. I want to create a vector free. Let's call this one the texture V for varying. After that, you get two options. Either you want to go from a vertex to a fragment shader or from a fragment to a light shader. You unfortunately cannot go the other way. Or in other words, you couldn't go from a fragment to a vertex shader. Simply because vertex shaders are calculated first and then the fragment shaders are being calculated. Because of that, you can never go from a fragment to a vertex shader. It's a one-way street. Anyway, once you have that, create, and then nothing is going to happen. That being said, if you add another node, you can set a varying setter. In there, you can pick the texture V that we have just created and get a value. The value that I want to get is from this texture 2D, like so, and then once again, nothing is going to happen. But now we can go back to the fragment shader and add a varying getter. So if we select the texture V, we are getting the vector 3 that we have set inside of the vertex shader. And effectively, all I want to do is, first of all, move these two nodes a bit further down, so I have more space. And I guess we can expand all of this, so it's much easier to see. This varying getter is a vector 3 with the texture color information from this texture 2D. This we want to multiply with the color, and that way we're getting the white parts wherever the vertex was lifted up the most. Or in other words, I want to add a multiply vector 3 node, and then multiply this node with the texture V node, and get the albedo color as a result. And now, the higher up we go, the more of a color we are getting. Not perfect yet, because if we are down here, we are multiplying the color with a value of 0, so it becomes invisible. Let's say instead of multiplying, I want to add the value. And that gives us a much brighter looking thing. Inside of the overworld, this is also giving us a much better result. To get a bit less white color, I want to not directly get the texture. Instead, I want to get the power of it first of all. For that, I want to use the power function and then get the value in there, which right now doesn't do anything because we have a power of 0. But if I change this to a 2, we have a power of 2. That way we're making every color a bit stronger. Or in other words, if a color is white, it becomes whiter. If a color is black, it becomes darker, which gives us a lot more contrast. And I guess what we can also do to have a bit more control over the color as a whole, we can add multiply, drag it into this path, and then multiply the value with, let's say, 0.5. That way, the white is much less dominant. Also, I think we have a bit too much transparency. This shouldn't be 0.5. Let's go with 0.85, just as a test. That way, inside of the game, I can try all of it. And still not looking amazing, although we're definitely making progress. A major issue is that this graphic is really, really large. Right now, we're looking at it without context, so this looks like a small piece of water. But inside of the overworld, this thing is as large as basically the entire level. Because of that, we can't really see what's going on. To fix that, I want to work on the scaling. So inside of the material, I guess we want to go to the shader material, vertex, and then work on this texture 2D. Inside of fast noise light, we can set the frequency. And this one basically is the scale. If I increase this value, then we are getting much more detail. Something like this. And now, inside of the game, I can try all of it again. That looks a lot more like water, although now I think the wave height might be just a bit too high. That we can fix quite easily. Inside of the shader parameters, we have wave height, which I want to set to maybe 4. A bit hard to see, but let's try it in the overworld. I guess that's getting better. Definitely an improvement. Might be a bit too low now. We can play around with this later. For now, since this isn't animated, it doesn't do very much. Let's work on that. For that, we simply have to pan this texture 2D. All I need for that is a UV panning node, which I want to connect to the UV information. And then if I increase the offset, we can move the entire thing either left or right. Or forwards and backwards, I guess. By default though, these values should be 0 and 0. These values should move automatically, which we can get via the time node. Although this by itself is going to be a bit fast. If I add it to the offset, then we're getting really, really fast water. But now, inside of the overworld, I guess it kind of works, but it's super, super weird. We definitely want to slow down all of that, which we can do fairly easily with a multiply node. I want to get the time for the A parameter, and then for B, let's go with 0.05. Something we have to experiment with. But now, this is looking quite a bit nicer. Now we can try the overworld again. And you can already see, this is feeling much more water-like. Not perfect yet, but at the pinch, you can imagine this to be water. Next up, I want to make sure that we can control the direction of the water. For that, we will need a vector 2. Let me find it really quick. Vector 2. And this should be a parameter. So vector 2 parameter. There we go. I want to create a direction. No need for a default value. All I really want to do is get the vector 2 and then multiply it with the value that we are getting from the time. So I want to multiply it like so, and then get the offset from that, which right now is not going to do anything because our vector 2 is getting a value of 0 and 0. But if I change it to a 1, we're moving to the right, and if I make this value a -1, we're going to the left. And I think inside of the level, we want the water to go only to the right. Something like this. So now we are going from this point to this point. I suppose we can add just a bit of y offset of 0.2. Then we're going a bit more this way, which I think should rather be a -0. Maybe 1.5. I guess that looks about okay. Let's try it now. And definitely a bit of water. Still not perfect, but you can definitely believe this to be water. I think another issue that we can work on inside of the water is when we are working with the texture 2D. This one is still a bit too large. Let's make it a bit finer, like so. And then we're getting a bit more information here. Also, while we are here, we can try to increase the subdivision width. If I make this 200 and 200, it becomes quite a bit more detailed, although that didn't actually do that much. This is something you really want to play around with, and the shader is already getting a bit more complex, and I don't want to overkill it. So I think, just to get started, this is not terrible. Although there's one more thing that I really want to do, and that is, let me expand this thing a bit. When the player is in the water, I want to have a bit of an indication that we have an overlap. Or in other words, I want to get the stuff behind the water. For that, Godot has a really useful node, which we are getting inside of the fragment shader. The node that we want to add is called proximity fade. This one gives us the pixel behind the water up to a certain distance. The concept can be a bit weird, but if I connect this value to the alpha value and then go back to the overworld, inside of the viewport, the entire thing now is going to get really weird. So there we can't really see anything anymore. And inside of the game, we still get water, but if I drag the camera a bit closer, you might be able to see this in just a second. Okay, this is still really hard to see. Instead, let's do this a bit differently. I want to keep 0.8 for the alpha value, that way we can see the water. And I want to use the proximity fade for the color. And in just a second, this should make a lot more sense. I want to grab the color and the add part with all the earlier stuff. And I guess this could be a bit better organized. It's very easy to get messy visual nodes, so always be careful here. We're getting the color, and to that color, we are adding the texture. To that value, I want to add something else. So vector3 add this one, and then connect this vector to it, which right now is not going to change anything because we are adding 0, 0, and 0 to this water. But now let's test what happens if I connect the proximity fade to that. Inside of the preview, nothing is going to change. But if I go to the overworld, then we're getting a massive difference. So what happened here? Basically, you can see that we're getting a pure white color unless there's something behind the object. Effectively, that means this proximity fade is looking up to a meter what is behind the object. If it doesn't find anything up to a meter, it is returning a value of 1, which we're then adding to the color, so we're getting a white color. However, if it is finding something behind that object, then we're getting a lower value. As a consequence, we are either keeping the blue color behind it, or we are getting a white color, which is an interesting start, but right now not terribly useful. The way we can make this useful is by inverting all of this, which we can do via a 1- node. To that, I want to add the proximity fade, and the output should be for the color. Then right now, the entire thing becomes white, because there's nothing behind it at the moment. But inside of the overworld, we are getting something really interesting. Let me run the game now. Wherever there's something behind the water, we're getting a white color. And this also applies in real time. So if the player is in there, we can see the bottom of the player, which is a pretty interesting effect. And I think this water is still way too fast. But we are definitely making progress. So inside of the shader, vertex, the speed should be this multiplication here. And let's go with 0.4. That way, it's just a bit slower. And I guess we can also grab the water and move the entire thing down by just a bit, like so. And then we can talk a bit more about proximity fade. This node can be a bit confusing, so I hope I didn't lose you entirely. Effectively, this node looks at behind the shader and then tries to find some kind of object. After that, it's going to return either a 1 if it doesn't find anything, or some kind of float if there's an object behind it. And the float is going to be the distance. We are nearly done with this part. I think one bit that is a bit too much is the white color. To fix that, I want to multiply it with another value that is going to be, let's say 0.5. And this value I actually want to add down here. That way the white color becomes less pronounced, and inside of the game, this looks quite nice. So now, inside of the game, we are getting water that is looking okay. Still not amazing, but I think for this project, it's definitely good enough. Cool, so with that, we have the water shader. One really important bit. Next up, we have the grass shader. And for that, once again, I want to create a new scene. Just as before, I want to create a mesh instance that I'm going to rename right away to grass blade. Let's save it right away inside of scenes and VFX. And also, I only want to have one viewport. After that, If you look at the file system, under graphics, we have VFX, and in there we have a fireball and a grass blade object. This is what I want to use right now as the mesh. And this is going to give us a grass blade, which I want to add to the overworld right away. Although for that, inside of the environment, I want to add another node 3D with the grass, and in there, I want to have the grass blade, which we now have to position. And I guess we can move it down a bit and also move the camera a bit further up there so we can actually see what's going on. I suppose the best place for this is the start position up here. There we have a bit more space. Like so. And then the grass blade, I want to move here and make sure we can actually see it. Placing this right now is a bit annoying. We are going to find a better way of doing this in just a second. Anyway, I want to place the grass blade here on the floor, something like so. And then also move the player over here. I want to get the player, move Godot here and up, and then try the entire thing. This part still works, and we can't see the grass blade. However, if I rotate the camera, there we can see it. That's an issue I don't think I've talked about yet, but for 3D objects, usually only one side is visible. This one you can see, this one you can't see. That is because for most objects, like for example this tree, you can only see, well, one side, which is the outside. If you look at the inside of the tree, it would be hollow, or well, you couldn't see anything. This is something that you can disable inside of the material, or inside of the shader. Both would work fine. In my case, I want to use another shader for this, so geometry, and I want to add a material override. There, we can add a shader material, click on it again, and then create a new shader. For this one, I want to create a normal code-based shader. The mode can still be spatial, and the name grassblade is totally fine inside of the VFX folder. Create now, and then we can write some code. We don't need any of the light. This one can go entirely. And the fragment part is also going to be fairly simple. Although first of all, I want to get rid of the one side thing. So even in the viewport, we can see the grass from this side, but we can't see it from this side. To disable that, you want to update in the shader the render mode and then set it to cull disabled. Don't forget the semicolon. If you now save, you can see the grass blade from both sides. Much better. Besides that, I want to get two colors, which we once again get via a uniform. And I want to create a vector-free color, which is going to get a hint for source color. This I want to duplicate. Next up, I also want to have a shadow color. Once we have that, inside of the shadow parameters, we are getting two colors. For the main color, I want to get 00BB65, which is a greenish color. For the shadow color, I want to have all sixes, which is a neutral gray, I suppose. And now, for the fragment color. I want to first of all maximize all of this, and then to update the color, we have to target albedo. Like we have done in the water shader, there we have albedo. We are targeting the same value. This wants to have a vector free. For example, we could use the color here straight away. If I do that, we're getting a green color. This also works inside of the overworld. If I run out of this again, we are getting a grass blade with a shadow, and then this works on both sides. Not a terrible start, although also not ideal. And let me zoom in just a bit so all of this is more visible. Yes, that's a good balance, like so. I want to mix the color and the shadow color, so that the higher up we go, the more of the normal color we get, and the further down we go, the more shadow color we get. That we can get by mixing the current color and the shadow color. The amount we're going to mix it by is uv.y. If I do that, we are getting more of the first color the higher we go, and less of it the further down we are. That looks pretty alright. If you wanted to, you could also multiply the shadow color with the color to get a bit more of the main color, which I think looks a slight bit better. Once again, colors can be a really fickle thing, so just play around with this. Anyway, that's all we need for the fragment. We can minimize this. The much more important part is vertex. In terms of updating the vertices for this thing, we have to do two things. Number one, it should move in the wind. And number two, it should be displaced by the player. For all of that, we are going to need quite a few more things. First of all, I want to have a uniform sampler 2D called curve sampler. And for this, I want to repeat disable. This is effectively going to give us a curve texture that will determine how much influence we get for each of the height segments of this blade of grass. Next up, I want to have a uniform sampler 2D again, which is going to be the wind sampler. This is going to be another noise texture, which we are going to use to simulate wind. For that, I want to have repeat enable, and I want to set filter linear. Besides that, I want to have a uniform float wind underscore strength with a value of 0.4. All right, via that, we're getting a whole bunch of stuff. And furthermore, with the grass blade material selected, we have to set a curve and a wind sampler. The curve is going to be a curve texture, this one here. And then you want to define how much influence we get via the curve. I want to create a new curve, and in there, the value I went for is a curve that goes down like so. We can play around with how this thing works in just a bit, but for now, I just want to have a basic shape. Besides that, for the wind sampler, I want to have a noise texture, which needs to be seamless, that's super important, and then we have to give it a fast noise light texture again. This one is mostly fine on its own. I do want to change fractal octaves to 1 though. That way we're getting much less turbulence, I guess. So if you make this value greater, you're getting finer values, and the lower this value gets, the more simple all of this becomes. That's all we need in here. With that, we have the textures, so now we can write some code. First of all, I will need the global position of this blade of grass, which I want to store inside of a vector 2 called world underscore position. This is going to be a vector 2 with node position world.x and node position world.z. Once again, we only really care about the horizontal position, so world position.y we don't really care about. Next up, I want to have a float with the curve value. And this one should once again be determined by uv.y. In my case, I want to get the texture and then get the curve sampler. For the sampling position, I want to create a vector 2 with uv.y and 0. Or well, 0.0, so Godot is happy with the data types. This right now is not going to work, because from this, we're getting a vector 4, which we can't assign to a floating point value. Fortunately, we only really care about the x position, so that is all we need. All right, so what is this one doing? And I guess I can make the grass blade just a bit bigger. And then update, once again, the vertex position. To that, I want to add a vector 3 with the curve values. If I do that, the blade is going to move a lot further to the right. Or in other words, the higher we get, the further we're moving in this direction. And this is influenced by the curve. If I now get the curve texture, update this, you can see in real time that we are making changes to it. This works on both ends, although I don't want to change the target value. I only care about this one, and then let's put it here. And I hope this isn't too confusing. We're getting the curve here, and from this curve, we are targeting the values by the amount by uv.y. And this we're then adding to the vertex. I think to understand all of this, you just want to play around with it a lot. It's kind of hard to explain. Now, besides that, I also want to get the float for the wind. And for that, I want to use texture once again with the wind sampler. And then we need a position, for which I want to use the world position, the one we have just gotten, and then make it much smaller. Let's say multiply it with 0.08. And to that, I want to add the time. Although this time is going to go really fast, so this I want to multiply with 0.05 again. From this value, I only want to get .x. And don't forget the semicolon. That way Godot stops complaining. Now, basically what we are doing inside of this noise texture, we are grabbing one point via the world position. This could, for example, be this point. And then, since we're adding the time to it, we are going further and further to the right inside of this point. And depending on what color we get, either white or black or some shade of gray, we're getting a different kind of value. And this is going to be our wind. This value is what we actually want to multiply with the curve value, which right now isn't going to do anything. That being said, if I replace the curve with the wind, then we should get a bit more of an animation. And that looks fairly alright. Although I think what we also need at the moment is that we are starting at this point here and then going in this direction. So we never get to this other side, which obviously wouldn't be ideal. That we can change by putting all of this into parentheses and then subtracting 0.5. That way we are moving between both sides. Much better. Finally, I want to get a vector 3 with the actual wind underscore displacement, which needs to be a vector 3. For this vector 3, I basically want to have the wind, and this I want to multiply with the strength of the wind. That value we have to find up here, wind strength, so vector 3 multiplied by the wind strength. And if you want to be fancy, you can also add 1.0 minus uv dot y. That way, we are adding more of a displacement at the top of all of this than we are at the bottom. Oh, and also this needs to be capital UV. And that way, we are getting a blade of grass that is moving fairly alright. Let's try all of this inside of the game. If I now run the overworld, we are getting one blade of grass that is swaying in the wind. It might be swaying just a bit too much, but not too terrible. Also, you can see the movement here is a bit much. The grass is going really high up. But that we can work on later. For now, inside of the shader editor, I have covered, let's call this one the wind. After that, we can work on the layer displacement. For that, we have a problem. The grass doesn't know where the player is. Or in other words, we know the player is here and the grass is here, but the grass has to know where it is relative to the player. And this, ideally, we want to do in any kind of scene. Meaning, if you have multiple scenes, you don't want to have a custom shader that always needs to get the player. Fortunately, if you look at project settings, there we have globals. In there, we can set shader globals. In my case, I want to set a player underscore position, which is going to be a vector 3. This I want to add, and then we have the player position, which now inside of the code, which now inside of the script for the player, we have to update. This is going to happen before we are doing anything else. So in physics process, before the move logic, I want to update this global position, which we can do via the rendering server dot global shader parameter set. First of all, we need a name, player position. This one is totally fine. And then we want to set the global position of the player. That's all we need. With that, we can track the position of the player inside of any kind of shader. Although to get it, you at the top have to set global uniform vector 3 player underscore position. Once we have that, we can work inside of the player displacement. First of all, I want to get a vector 3 with the direction to player. This is simply going to be the player position minus node position world. That way, we know what direction the player is. Besides that, I want to have a float with distance to player, which is simply going to be the length of the direction to player. Which means with that, we know the direction and the distance. That means we can now update the vertex position. And for now, I want to set it to the negative value of direction to player. And don't forget the semicolon. That way, we're moving all of the vertices in the opposite direction compared to where the player is, which is going to give you some effect. Let me run the game again. And now, if you look at the grass, it's a bit higher up. And if I get close to it, you can see that we are moving this thing quite a bit, which is, well, a bit strong. But effectively, it is now moving in the opposite direction compared to the player. Or to be a bit more specific, we are drawing all of this in this particular position. The actual position of the mesh has not changed. This effect we have to moderate just a bit. And for that, I want to have a float fall off, which is going to check if the player is close by or not. And the best way to check that is via a smooth step function, for which we want to have 2 points. I want to have 0.0 and 1.0. And then check via the distance to player where we are within this range. If the player is far enough away, I want to get a value of 0.0. If the player is really close, I want to have a value of 1. And if the player is in between, I want to have a floating point between these two values. All of which we are getting via the smooth step function. And this value I want to invert. So 1.0 minus the smooth step. And then we have all that we need. I want to get the negative direction to player, multiplied with the fall off, and multiplied with the curve. And that way, inside of the overworld, we can try to run the entire thing once more. We should be getting something. And it doesn't really look like something is happening yet, although I think there's a very minor effect. I suppose what we could be doing, let me zoom in just a bit more and select the leaf, this one here, and then move it down just a bit more so we are right on the door. And then inside of the shader editor, I want to make this effect just a bit stronger, which we can do by multiplying it with some other value. Let's say for now 4.0. Then we can try the entire thing one more time. And now we should be getting something. So there you can see the blade of grass is affected by the player position. Obviously, this is a bit too strong right now, but we can work with that. I guess inside of the shader editor, this could be a uniform, but I'm going to go with 1.5 just for now to have a slightly more noticeable effect. So let's try the scene again. And we should be getting a fairly minor effect. And there we're getting something. So this is looking okay. Cool. With that, for now, we have one blade of grass. That's not terrible, but this is also really annoying to work with. So I guess what you could be doing is, if I go outside of full screen, you could copy this grass blade and then move it to another position, rotate it, and then do this over and over again, after which you would eventually get a proper grassy area. The shader would still work just the same. But obviously, this wouldn't be a good approach with all of this. So that's not what I want to do. Instead, I want to use another external module. For that, inside of Asset Library, you want to look for Proton Scatter. This one here. click on download, then Godot is going to download for a second. Then you get another dialog on which you want to click install. Then Godot is going to load just a bit more. And finally, everything was installed, so we are good to go. Or well, first of all, you have to go to project settings, there we have plugins, and you want to enable Proton Scatter. After you have done that, back inside of the 3D scene, to the grass node, I want to add Proton Scatter. Click on create, and now if you zoom out a bit, somewhere in the scene, you should be getting something new. So if I zoom in there a bit, we have a whole bunch of boxes, which right now doesn't really look impressive. But what we can do with that, if I move this node close to an actual area, you're getting a loading screen, and let me put it here. I guess just a bit higher. Now we can see it, and there we are getting all of these boxes arranged on top of the surface. Or in other words, if I move it across this cliff, then Proton Scatter is going to rotate and place all of these boxes in the right position. And this you can modify a lot. When you're adding one Proton Scatter node, you're getting a scatter item and a scatter shape. If you have the scatter shape selected, you can see the shape that we are working with, and this you can modify. Meaning if I grab the red dot, I can extend the entire thing, and then we're getting boxes across the entire cliff. Besides that, the shape can also be updated. You have a base, a box, a path, and a sphere, with the sphere being the default. Besides that, inside of Proton Scatter, you can modify a whole bunch of things. For example, the amount by default is 75, but this could be, for example, 5000. Then the thing is going to load for a bit, and we're getting a lot of objects. And all of this is also going to be visible inside of the game. There we go. And we're getting a lot of boxes. Now, for these bits here, we were too far away from the cliff, so sometimes you do have to be a bit careful. But other than that, this is working really well. And if you look at the other options, there you can do a few more things. For example, under randomized transforms, you can, well, randomize the transforms, meaning the position, rotation, and scale for every single object is going to be randomized. And this you can modify. There are a few more options, but they aren't too important. Now, the one that I care about the most is scatter item, because in there we can get a custom scene to display. By default, we have brick.tscn. But if I change this and load from scenes, VFX, and grass blade, I can open the scene, and we're getting a whole bunch of grass. And all of those also have the shader, which means if I run the game again, we're getting all of the grass, and we are getting displacement. So this is working really, really well and feels significantly better. Which means for the starting area, you want to have Proton Scatter selected, and then move all of this a bit more over here. I guess what we could be doing at this point, with Proton Scatter selected, we can randomize the transforms. For example, for the scale, if you set all of these to 0.5, and this you want to do for all three of the attributes, then the grass is going to become quite a bit bigger, which means if I run the game again, now the grass is quite a bit larger. And once again, this is something you want to play around with. There is a ton of stuff that you can do, and well, it's super powerful. But other than that, I think the grass shader has gotten a bit too complex. So I hope all of this wasn't entirely confusing. It was definitely the most complex shader. But this is basically it. For the rest of the game, if you want to have a really nice overworld, you would want to add a lot more Proton Scatters, and then add grass everywhere, and then also make sure that the performance doesn't suffer too much. Because the more objects you add, the worse it's going to get. So you do want to experiment with that a lot. In my case though, I'm done with the grass, so I want to get rid of this grass blade instance. We don't need it anymore. Proton Scatter is going to work just fine. And next up, we can work on the fireball. For that, we already have a scene called fireball.tscn, which at the moment is a red ball, which really doesn't do very much. And to fix that, we have to make a couple of changes. First of all, we don't need the CSG sphere anymore. This one should go entirely. Instead, I want to have a mesh instance once again. And then, inside of graphics, we have fireball shell mesh. This I want to use for the actual mesh. And then we are getting a kind of tear-shaped object. You will see in a second how all of this is going to work. I guess while we are here, I want to rename this thing to fireball mesh. After that, I want to go to geometry and material override. In there, I want to have a new shader material, click on that, then click on new shader, shader, spatial, default, fireball, that's all fine, and create. Then we are getting some shader code again. For all of this, we only want to work with the fragment shader, so the vertex function can go entirely. On top of that, I want to create two uniform sampler 2Ds. One is going to be for a noise texture, so let's call it noise sampler. And for this one, I want to filter linear bitmap and repeat enable. Then I want to have a second sampler 2D for the gradient, meaning the name should be gradient sampler. For this, I want to filter linear, and this is going to be a source color. Once you have these two options, inside of the shader parameter, you're getting a noise sampler and a gradient sampler. For the noise sampler, I want to have a noise texture that is going to look fairly similar compared to what we have done in the water. And also, this needs to be seamless. I want to create a new fast noise light. And for this, I want to have a cellular noise type. After that, inside of cellular, actually inside of fractal, you should get none, which is all we need for now. For the gradient sampler, I want to have a fire shape gradient, which is going to be a gradient texture 1D, for which we want to have a starting color that is fairly red with just a bit of yellow, something like this. And the end color is going to be a slightly orangey yellow. Something like this. As always, play around to see what you like. Righty. With that, we have a noise texture and a gradient. That's all we need. Next up, inside of the fragment, I want to have float, let's call it noise. And for that, we want to get the texture of the noise sampler along with a UV position. And from that, ultimately, we want to get one of the values. Since it's a grayscale texture, it doesn't really matter which one. So let's go with X. This at the moment is not going to do very much. That being said, what we could be doing is get the alpha and set it to the noise we have just gotten. If you're doing that, you can see that we have some of the texture in there for the alpha values, which kind of looks like a start, but this isn't doing very much. Also, before we continue, this thing is facing the wrong direction at the moment. For that, inside of the fireball mesh, I want to go to transform and then give it an X rotation of 90 degrees. That way, we are at least working on the right axis. And once we have that, I want to animate the texture. Or in other words, when we are sampling from the noise sampler, I want to update the UV, which we can do quite easily by subtracting a vector 2 with 0.04x and with time on the y parameter. That way, this thing is going to be animated. That's all we need for this part for now. Next up, I want to work on the color. For that, I will need a vector 3 gradient. Or in other words, I want to get the color from the gradient sampler, which as a reminder was a gradient from red to yellow. For that, once again, we need a texture function with the gradient sampler. And then some kind of UV value. This is going to return a vector 4. To get a vector 3, we want to have RGB. And this we could already assign to the albedo color, like so. Don't forget the semicolon. And then we're getting some kind of color, but well, it's not great yet. Most importantly for now, I want to make sure that the red part is in the front and the yellow part is in the back, which means we have to update this UV sampling. Instead of getting the UV right away, I want to have a vector 2 with UV.y and 0.0. That way, we are inverting the entire thing and start at the top with the sampling. And by top, I mean front. I think you get the idea. I want to make sure that we have a cleaner cutoff between the invisible and the visible points of this fireball, which means we have to update the alpha value. And for a cleaner separation of values, you always want to use the step function, where you set an edge and a floating point value. In my case, the edge could be negative 0.15. And then for the actual value, I want to have the noise texture multiplied with uv.y. This is not going to do anything. That is because this shouldn't be multiply, this should be minus. That way, we are getting a much nicer value. So effectively what happens at the moment is the further we are going to the right, the less of a value we are getting here, so the cutoff point will be lower. So the flame slowly disappears towards the end, which is a super nice effect. Cool, that's a really nice start. Although there's one more thing that I want to do, and that is to add a Fresnel. And in case you don't know what that is, here we are on godotshaders.com, and there you can see this is a Fresnel. It's basically a whitish outline, kind of like the event horizon for a black hole. The math for that is getting a bit complex, so I'm not going to worry too much about it. Instead, I'm going to copy the line that you can see on the website. And generally, this website is super useful, so I'm going to add a link to it. Back inside of Godot, I want to add this function for a Fresnel. And you can see for that, the math is getting just a bit more complex and beyond the scope of this tutorial. And the way you would use it, let's do it before we are doing alpha. I want to set the emission. And for that, I want to get the gradient and then add a step with a starting value of 0.25. Then we want to have the Fresnel, where we have to add a floating amount, a vector-free normal, and a vector-free view. The value is going to be 2.0. The normal is the normal. That comes with the shader. And then we also have the view. And all of this we want to multiply with the gradient. If you now add a semicolon, we're getting a really cool effect that is maybe a bit hard to see, but there you can see we kind of have an outline thing around it. And if I change the step value to, let's say, 0.1, then I can modify the size of it. I guess 0.4 kind of looks cool. Just play around with all of this. And just in case you're wondering, normal is the normal of a vertex, so basically where this thing is pointing outwards. And view is our camera view, which is really important for this kind of effect. Although, once again, for that sort of thing, it's, well, a bit more advanced. Anyway, with that, we have a pretty cool looking fireball effect. But we're not entirely done yet. If you look at the fireball from this side, you can't see anything. That is because, like I've mentioned earlier, for 3D objects, we are only rendering one side, which is the side you can see right now. But if the player shoots from here, that's not going to be impressive. To disable that, you want to set the render mode to cal disabled. And then you are going to see the back of the fireball, which is a much nicer effect. On top of that, to make it look a bit less hollow, I want to add another mesh instance 3D, for which the mesh is going to be a sphere mesh that fits roughly in there. Scale this thing up as much as you like. I'm happy with the size so far. Much more importantly, I want to add a standard material to it that we are going to make red first of all. That way, I guess we can go with something a bit darker. Let's go with this one. After that, you want to go to emission and enable this value. That way, let me just select it on the right angle. You can set an emission color, which is going to emit a certain kind of color, which I want to be a pretty strong red. That fits into the fireball quite nicely, so it should be slightly orangey. Something like this. And now, if we set the energy multipliers to something higher, you can see that we're getting a pretty neat effect. And that, once again, is something you want to play around with quite a bit, but I am quite happy with how this thing is looking. Nearly done. there's just one more thing that I really want to do. And that is sometimes when you look at the fireball from a weird angle, the entire thing starts to look just a bit weird. So if you look around, you can kind of see what I'm talking about, I hope. Right now, this part here is looking kind of strange. That we can fix with alpha, scissor, threshold, and then 0.5 in this case. That way, we're getting rid of all of that and only see the outside. Much better. Now we have a pretty good looking fireball that we then have to add inside of the scene. Which means inside of the overworld, let me try to run the entire thing. I want to shoot a fireball, and that is coming together quite nicely, although the rotation isn't ideal yet. But we are definitely making progress. For the direction, I want to work inside of the fireball, and we already have some code in here. For that, I don't want to work inside of ready, because inside of the level, when we are creating a fireball, we are creating the fireball, and then we are adding it as a child to projectiles. Once we are doing that, we are calling the ready function, which should be that one here. But what we are not doing is updating the direction. That only comes afterwards, which means if we try to get direction inside of ready, it would always be a default vector 2, which doesn't help us at all. Instead, we want to work inside of the setup function. This one is being called after we are updating the direction. So in there, I want to get the fireball mesh and update rotation.y. For the value, I want to get the direction and the angle. If I try this one, it's not going to work yet. So we are getting something. Effectively, we just have to update this value a bit to make it more appropriate. The changes I made to it are negative direction angle plus pi divided by 2, and then to the entire thing plus pi. That way, inside of the overworld, we should be getting the right direction. And that is looking pretty good. Cool. I guess we could also update the speed of these because they do seem very slow, but that we can work on later. First of all, I also want to check if the enemies are working as well. They should be okay by default. For that, I want to go back to the castle area over here. Let's make sure we are on the floor. Then we can try the entire thing again. And now the mage should be shooting at us with a proper fireball, and that is feeling much better. Perfect. I can also shoot back and try to hit the mage. For that, I should be on the right height, but that looks alright. And I think the speed here is quite a bit too slow. Let's go with something like 9. It's nearly twice as fast. But once again, experiment, and you should be getting a much nicer result. Let's try, and that looks pretty alright. One more thing to finish up with the fireball, and that is that at the moment, if the fireball doesn't collide with an entity, it is never going to end. To fix that, I want to add a timer node with a wait time of, let's say, 15 seconds. That should auto start. By the time it's finished, I want to get a timeout signal and then destroy the fireball, just to make sure that we keep a maximum amount of fireballs. Otherwise, we might cause performance problems. And with that, we are done with the fireball, which is a super cool effect. That means I can close the fireball and the grass blade. There's one more shader that we need, and that is going to be inside of the entities. I guess for now, we can start with the player. Let's open that one, and I want to work inside of Godot's skin. Effectively. When Godot gets hit, I want the entire model to flash in red. And when we are casting a healing spell, it should do the same thing, but with a green color. And also, before we start, I think what we can do is make the entire thing a bit more neutral. I want to target all of the various parts of Godot and then make them flash in a color using a shader. For that, we have to start with one of these body parts. It doesn't really matter which one. So I guess for the biggest one, we can start with the body. On there, we have a surface material override, and inside of geometry, we can add a material override and a material overlay. The material overlay is what I want to work with. In there, you can add a standard material or shader material, and I want to go with the shader. Then click on it again, create a new shader. Normal shader, spatial, and Godot skin is totally fine. Although actually, let's call it overlay. And then we can save it inside of VFX. That makes a bit more sense. This shader we are going to reuse later on for the enemies. So make sure this is reflected inside of the file system. Alrighty, with that, we have another shader. And if I click on it, we are getting the normal shader code, for which I only want to create a fragment shader, meaning we don't need vertex or light. And then I also want to create a couple of uniforms. The first one is going to be uniform vector 3 for a color, and for the hint, I want this to be a source color. Besides that, I want to have a uniform float for the energy. This one can get a default value of 1.0. And then I want to have a uniform float for the alpha value, which is going to get a hint range from 0 to 1 without a step size. The default value is going to be 0.0. And after we have that, inside of the fragment shader, this part is actually going to be super easy. I want to set the albedo. That is going to be the color multiplied with the energy. After we have that, we are getting a black color. So inside of the shader parameters, this is a color you can change and then do something with it. I suppose for now, we can go with a greenish color. Doesn't matter too much. So with that, we have a color and we are overwriting the albedo parameter. But inside of the model, we can't see anything. That is because for an overlay, by default, the alpha is 0. Meaning if we update alpha and set it to 1.0, then we can see the green color. If we set it to something like 0.5, then we have a green shading. And what can make this effect look a bit nicer is if you make it unshaded, meaning inside of the render mode, you can set it to unshaded, and then you don't get shadows anymore. Finally, the last thing that we need is alpha is going to get the uniform alpha. That way, inside of the inspector, I can set the alpha value and get a green overlay. If I make the energy stronger, for example, set this to a 5, then we're getting a bit of glow as well, which could look nice. We have to play around with this. Besides that, for alpha, the default should be 0.0, so we can't see anything. All of this should only be controlled via a tween in just a bit. That's a nice start, but now we have another problem. We are only ever coloring the body, but we also have to do it for all of the other parts. And for that, I want to get the entire overlay material and then save it as, inside of the player, let's call it not Godot skin, but Godot overlay. .tress, that's fine. Then we can go to Godot arm left, geometry, material override, quick load, and look for Godot overlay. If you expand this one, we are getting the same color along with the same energy and alpha values. After that, arm right, same thing, quick load, overlay. Then we have to go to the head, in there, material overlay, quick load, and the overlay once more. Finally, for leg left, same thing, and then we are doing leg right. All right, there we go. With that, we have a shader for every single part of Godot. And what is really nice now as well, if I target any of these options, let's say for leg right at the moment, if I increase the alpha value, we are updating all of the shaders. That is because inside of resource, this is not local to the scene. We always update the entire shader for every single instance. So alternatively, you could also go to the body and there increase the alpha value and you get the same effect, which makes the entire thing much easier to control. That means inside of the code for Godot skin, I want to create, let's do it all the way at the bottom, a function heal underscore tween. No need for custom parameters, and we don't want to return anything. After that, I want to create var tween via create tween, and then tween a method. The method we are going to call underscore heal effect. The start value is going to be 0.0, and the target value for now is going to be 1.0. The duration will be, let's say, half a second. Next up, we are going to need a function underscore heal underscore effect, for which we are going to need one argument that I usually call value, which has to be a float. Now for this method, I want to target Godot body, although you could target any of the body parts. It doesn't really matter. In there, we have a material overlay, and this material overlay can be set via the shader, which means set shader parameter. The shader parameter that I want to target for now is alpha, and the value it's going to get is what we are getting from the parameter, which, at least to get started, should be all we need. I guess what we can try to do, once the scene is ready, meaning func underscore ready, I want to call the heal tween, just to make sure something is happening. After that, in the overworld, we are getting a green Godot. Looks good. Obviously, this isn't what I want to do, so let's get rid of it for now. Instead, I want to work inside of player.gd, because in there somewhere we have shoot magic, and at the moment we are either casting a fireball or we are healing. When we are healing, I want to get Godot skin and then call the heal underscore tween, I think I called it. Yep, heal tween, this method. Which means inside of the overworld, I can shoot a fireball, and if I change the spell to healing, I get a heal effect. Cool. Now, to make sure that Godot doesn't stay green, after this tween has finished, I want to call a second tween method with the same function. Although now, we're going from 1.0 to 0.0 over a duration of, let's say, 0.2 seconds. Inside of the overworld, let me heal really quick. And that's not looking too terrible. Not the most amazing effect, but I think for a simple heal spell, this is good enough. What I think is also going to help quite a bit is to reduce the opacity to 0.7 as the max value. Which means we want to go up to 0.7 and then for the reversal from 0.7 to 0.0. After that, inside of the overworld, we can try a healing effect again, like so. And that feels quite a bit nicer. I also want to be able to set the color of the shader. For that, I can simply duplicate this line and then change the color part of the parameter, for which I want to create a color dot green yellow. Now, setting this color is quite important because we want to use the shader for a heal effect and a hit effect. The only real difference is the color that we are getting. Fortunately, it's not that difficult to change. Let's try it again. Inside of the overworld, I want to cast a healing spell. And now we're getting a slightly different green that's a bit more yellow. I think in my notes, the actual color that I used was light underscore green, which looks a bit better, but once again, just play around and see what you like. So heal effect again, and that feels much nicer. Next up, when Godot gets hit, or in other words, when we are calling the hit function. At the moment, we are playing an animation, and then we are aborting any attacks that we currently have. Besides that, I want to play a tween, a similar one that we have seen for heal tween, meaning I can copy all of this, paste it in here, and then I want to create a hit effect, which is a method that doesn't exist at the moment. So function underscore hit underscore effect with one parameter for the value. For this, once again, we are going to do basically what we have seen inside of this function. So we can copy it once again. The only difference now is that I don't want to get light green. Instead, I want to get fire brick. And also, I want to set the duration to something shorter, let's say 0.3 and 0.1. You could also change the alpha value to, let's say, 0.5 as a maximum value, but that is just fine-tuning. Once we have that, back inside of the game, let's try to get hit, and then we should be able to see this tween. And there we go. We can see, okay, this is not going great, but there you can see, once we get hit from the fireball, we're getting a short red flash. And that is basically all we need for this final shader. Let me clean up the code just a bit. There should always be a proper amount of white space between all of the functions. That looks much better. And with that, we have finished the code for Godot's skin. And now this shader I want to reuse for the boss, which means we have to get all of the meshes, give it a material, and then trigger it inside of the hit function. That part is going to be your exercise. I want you to give the boss a hit shader that flashes red, like we have seen for the player. Pause the video now and see how far you get. Let's start with Nagon Fort Body. In there, I want to go to Material Overlay and create a new shader material. The shader we already have. We just have to quick load it. It's called Overlay. Add it in there. And then we have shader parameters. If we increase alpha, we can set a custom color for the body of this model. Let's set it to 1 for now, because I want to add a color right away. Something red. I guess we can make it a bit more orangey. Just go with a color that you like. And I guess for the maximum alpha value, we can go with something like 0.7, like we have done for the player. Looks about alright. Maybe a bit lower, 0.5. That's better. Since we are only going to have a single color, we can simply set it inside of the inspector and then call it a day. With that covered, I want to have a default alpha of 0 and save the material. Save as inside of the enemies. I want to have a boss overlay.trace file, which we're then going to apply to all of the other overlays. Once again, I want to quick load, and this should be boss overlay. Just to test if this is working, if I now increase the alpha value, we're getting the arm as well. Perfect. And there we go. This covers all of the body parts, meaning if I increase the alpha, we're changing the color for the entire model. So next up, inside of the code, we have to look for a hit function, which is this part here. At the moment, we are simply printing that the boss was hit, which we don't need anymore. Instead, I want to create a tween via create tween, and then tween.tween property. The method name, let's call it underscore hit effect. The start value is going to be 0.0 and the target value will be 0.5. For the duration, let's go with 0.3. This we can then duplicate. The start value should be 0.5, the target value 0.0, and the duration 0.2. Next up, we have to create a function underscore hit effect with a value that is a float and won't return anything. Inside of this function, we want to target one of the meshes. Let's go with the body, and in there, we want to get the material overlay and set a shader parameter. The only parameter that we have to target is the alpha value, and the value that we want to set, we are getting from the function parameter. Godot is still complaining because this shouldn't be tween property, this should be tween method. There we go, this is much better. And that should be it. if I now reopen the dungeon scene, I can place Godot in a much better position, right next to the boss, try the entire thing, and let's shoot a fireball at the boss. That is looking pretty good. We can also get hit by a giant fireball, so this is working quite well. Perfect. Besides the boss inside of the overworld, you could also add this shader to the enemies. You could add it to those two enemies as well, but I think you get the principle, and this isn't too complex. So I think we are done with the shaders. This is actually all we needed. And I think overall this isn't too difficult besides the grass shader, which is getting a bit more complex. Anyway, with that, we have a pretty nice world, so there's just one more thing that we have to add. And that is going to be sounds, which is a small part, so let's do it right away. For that, I want to work inside of the player. If you look at the file system, there we have audio, and in there we have 4 different files. A sword sound when Godot is attacking, a stream for the river, steps when we are walking, and some background music. Audio files aren't really that complicated, so I want to keep this as simple as possible. Inside of Godot, we want to add another node 3D to keep things organized. Let's call this one Sounds. To this node, I want to add an audio stream player 3D. And basically in 3D, you have an audio listener 3D, an audio player 3D, and an audio stream player. The difference between these two is that an audio stream player 3D cares about the position, meaning the further away we are, the less of a noise we are getting. Whereas a pure audio stream player simply plays audio. Now for the player, it doesn't really matter which one you choose, since the person playing is always close to the player character. Actually, this we can check inside of the overworld. If you go to water and add an audio stream player 3D with stream.mp3, then you can set this to autoplay, and you can set a max distance, which you can even see inside of the inspector. So this is the physical position of the node. And if I give it a distance, there you can see a circle that tells you for how far we can hear it. And to make sure this is actually working inside of the game, we have to make sure that this file is looping, which you can't do inside of the inspector. For that, you want to go to import and then activate loop. Now you want to re-import this stream file, and then this file is going to loop automatically. Now to test all of this, I want to put the player. Let's find Godot really quick. I want to put the player a bit closer to this point, roughly here. And then we can try all of this. By default, you should hear something now. That is working pretty good. And the further I run away, the less we can hear. That's basically all we need for this part. Next up, inside of the player, I want to add an audio stream player for the sword attack, so sword, sound, and I want to have a step sound. The sword sound is going to be sword sound.wav, and the step sound is going to be steps.mp3. These steps should be played repeatedly, which means inside of import, loop, and re-import. And I guess while we're here, the same I want to do for music.ogg. Re-import with loop enabled, and then these files are looping. The sword sound is really easy. All we have to do inside of the code for Godot, or well, the player, when we are doing the ability logic down here, and we're getting a weapon attack, I also want to get the sword sound and play it. After that, in the overworld, let's move Godot a bit further away from the water, so we only hear the sword. Play the game. And now if I attack, we are getting a sword sound. Not the most amazing one, but for a basic game, it should be good enough. I suppose what we can do inside of the inspector for the sword sound is to reduce the volume just a bit. minus 10. So it's not too noticeable. Next up, for the step sound. I want to play this sound whenever Godot is running. And for that, inside of the code, I want to expand all of this. We want to check the move logic. And that's the only method that we need. In the most basic sense, all that you have to do is get the step sound and toggle the playing attribute. This one should be true if we are on the floor, so is on floor like so, and we have movement input. This would be fine in theory, but in practice this is not going to work, because effectively what we are going to do is keep on pressing this button continuously inside of the game really fast, which is not going to sound good. But just to demonstrate, if you're on the game and run around, it sounds horrible. Instead, what we have to do is check, first of all, if we are on the floor and moving, so these two statements. And if that is the case, I also want to check if the step sound is currently playing. Let me copy it. And only if that is not the case, then I want to play the sound, which means then playing should be true. However, if neither of those is the case, meaning else, we want the sound to not play whatsoever, meaning it should be false. That way, we don't need this line anymore, and we can try the overworld. Now, when we are running around, we are getting step sounds, although those are a bit loud, which means inside of the inspector, this should be minus 20. Next attempt. That feels a bit nicer. It's going to be very difficult to hear. And I guess that's a good sign for steps. If they're too noticeable, it's going to be a bit annoying. Cool. With that, we have all that we need for the player. And well, with that, we have basically finished the entirety of the player. We can now close the scene. The same for the boss and the dungeon. The final thing that I want to do inside of the level, I want to add an audio stream player with music.ogg. This one should be set to autoplay. That way we can go to the overworld, play this thing, and we are getting some sound. And with that, we have finished the entire game. Now, to make it really nice, you probably want to add a lot more material, like for example grass or enemies, all across this overworld and the dungeon level. But if you've gotten so far, you have a really good template to expand this game and add more and more stuff. Eventually it's going to look really good. So I hope this tutorial was helpful, and I'll see you around.